Please, during the question period, try to be concise in your answers. If you're turning around, if you don't know exactly how to answer or whatnot, we will cut you off and just pass to the next question because we only have 10 minutes. Normally we have 12 or 15. So we're just going to try to get as many questions out. It's not a bit pressure on you or anything, but we just want to clarify things because the reports were long, a lot of teams are present. So that being said, good luck, be spontaneous, be fun, entertain us, and I'm really excited for this. So good luck, everyone.
Is there like a direct link to the computer? Yeah, let's try to. That's starting where.
So I think that will be the sign on your future function, right? All the team and the team. Like you have
Thank you, panel, and good morning, everyone. We're the University of Manitoba, and we're here to present our proposal to the CSCE and SCCE, the Point Creek Canoe. Now, before I begin, I'd like to introduce everybody. My name's Cameron. I was a junior captain this year. Up here with me is Austin, our mixed design lead, and Kate, our senior captain. In this presentation, we'll be going through 5 main sections: our guiding goals, hull design, mixed design, production, and project management. Our guiding goals were 2 main ideals that we wanted to really emphasize throughout our design this year. those being sustainability and streamlined construction. In our hull design, we opted for a more paddler-centric design this year, and we did this through 3 key design principles, those being making it easy to paddle, making it constructible, and making it durable. To ensure ease of paddling, we introduced a soft chine, which increases the secondary stability of the hull. As well, we made the hull symmetrical, which allows for more room for paddlers in the canoe, which makes for a more comfortable ride. Next, to make it more constructible, we sloped our walls at a 97-degree angle. This makes it far easier for our members to place on casting day, making for a much quicker construction. Finally, to make it durable, we went through a thorough structural analysis in 5 different loading cases to ensure the canoe would be suitable for water. Now I hand it off to Austin, who will cover the mix design.
Thank you, Cameron. This year on Mix Design, we focused on sustainability, workability, and the cohesiveness properties of our concrete. For sustainability, we increased the amount of SCMs. We used a high-grade slag to ensure we had the strength needed when we decreased the amount of cement. Historical data from our other canoes was used to determine the best material for the job. The next thing we focused on was the workability and cohesiveness properties of our concrete. We did this by decreasing the amount of large aggregate within our mix and adding a new medium-sized aggregate to our mix. We tested this with the mock-up section where we determined we had the right flow and cohesiveness properties to build a concrete canoe. I'll now pass it off to Kate for the production.
Thank you, Austin. So for production this year, our main goal was streamlining construction, and we did this in a few key ways. The first was switching from a male mold to a female mold. The female mold was much easier to demold, which resulted in less damage. In turn, we could reuse it time and time again in a mass production scenario. Additionally, this year we had a lot of new team members who didn't have much experience placing concrete. The female mold ensured that no matter who was placing the concrete, the canoe would have a smooth outer finish. In terms of production, we wanted to keep it simple on casting day. We used simple construction techniques that have been tried and true by our team. We began with 10 millimeters of gray concrete, followed by carbon fiber reinforcement mesh, followed by 10 millimeters of yellow concrete. This meant that we did do away with our concrete inlays. In order to maintain our visual appeal of the canoe, we moved towards concrete stains. This reduced the overall labor hours and reduced concrete waste as fewer pigmented mixes had to be made. The culmination of these effects can be seen from last year to this year. Throughout casting, demolding, and the aesthetic features, Coin Creek Canoe took 33 fewer hours to build for a similarly sized canoe. Our project management this year focused on value stream mapping. This looks complicated, don't worry, I'll break it down. So this is our recruitment process, so a complex process that newer team members may not be familiar with. So what we have in green is the task process, essentially what all the steps that need to be done in order to complete our recruitment. In red, we see the information flow, who we're trying to communicate with, and in black at the bottom are time ladders. This is how long it took to do each task, as well as the time between tasks. When everything is laid out like this, it makes it easy to identify the inefficiencies, which we can address moving forward into next year and this year through our increased financial abilities being the hosting team. The Coin Creek Canoe is inspired by the Royal Canadian Mint. It embodies a strong management spirit and value for your money. Our construction was sustainable with a low cementitious material ratio. It was constructible, with construction being considered at every step of the design process, while maintaining aesthetic appeal with stains. Finally, our hull design ensured that this canoe was easy to paddle. Thank you all so much for your consideration and for listening. I'll now take questions.
Thank you, Manitoba. Thank you for having us as well. Hosting, always nice. Okay, quality control, reading the rules, RPL, these are very important in the spirit of the competition. Your paper was missing the abstract, which is worth 30 out of 200. How do you explain such an oversight?
Honestly, it was an error formatting the document at the last minute. We were pulling in pages from various different sources, and it was just mistake when merging. It should have been caught, and we really messed up there. There's no explaining that away.
Do you have a position for like academic review, or like some teams have a specific position?
We don't have a specific position for that at the moment, but I could see us having such a position.
Okay.
You reduced the hull thickness from 25 to 18 millimeters,
That is correct.
which saves weight, but your conference strength at 21 days is only 3.33 MPa. How confident are you with this strength margin?
The compressive strength was actually where we had our greatest, we had a greater factor of safety on our compressive strength than we did on our tensile strength. I don't have the exact numbers in front of me, but hull design, it was really dictated by our tensile strength as opposed to our compressive strength. We're confident the canoe is going to be solid in compression through the bending beam analysis that we did.
Yes, starting from there. How did you get 3 MPa with all this cementitious material? Cement, slag, and kaolin?
Yeah.
And your water to cement ratio, I think, is close to 0.5. So you have more than 3 MPa.
I mean, that we just did compressive testing for that, and then we did splitting tensile and the flexural tests, and we just followed what the results we were getting.
So you get 3 MPa.
Yeah, what we tested.
And the question regarding the testing, the split tensile and the flexural, did you use the same standard for both tests?
Flexural was done with a prism across an apparatus following the standard. And then what was the other one, sorry?
I mean, you reported that you use the same standard for both tests, split tensile and flexural.
Splitting tensile was split cylinder, and then flexural was in an apparatus where we put it.
The standard is different.
Yeah,
It's not the same standard for both tests.
like they're different
Different standards.
tests. Yeah.
But in your projects, you didn't say that. You say that you use the same standard for both tests.
Oh, okay.
Yeah, I guess you guys changed your casting angle to 97 degrees, saying it's for to make the layup easier. But was there like any how did you guys determine that angle?
So last year, our canoe essentially terminated at a 90-degree angle, and that made building up the concrete very difficult, especially with the male molds. It would fall right off the mold when we tried to put it on and caused some stress on casting day. This year, we wanted to avoid that, so we did basically when we were doing mix tests, we would build it up the side of the mixing bucket to see that it would build up a 90-degree angle. And then we gave ourselves that 7 degree of leeway for casting day and tested it on the mock-up that you saw on Austin's slide. So that mock-up also had that 7 degree angle consistent with the mold that we.
Okay, so the 7 degrees was added as a bit of
It was to give us leeway to ensure that casting day was as stress-free as possible.
Okay.
You switched from a male mold to a female mold this year, correct?
That is correct.
Based on the finish of your final product, is that, you think it'll that change for next year, or is there going to be reconsideration?
The finish of our final product was not great, I will admit. But I will also say that the outside finish was a lot nicer than the inside finish. If we can figure out what's causing our concrete to sand so poorly, then I think we would consider perhaps going back to a male mold. But until we know exactly what's going wrong with our canoe, we had this problem with bonbon build. We want to make sure that we're going to present a smooth outer finish, as smooth an outer finish as we can.
You said that the mold can be reused 10 times, correct?
That is correct.
Did you actually test it, or it's theoretical?
This is a theoretical. The initial demolding caused very little damage to the mold. Essentially, the glue broke along the seams. This was consistent with what we'd seen in previous years demolding a female mold. Our mold is no longer in the state that it was in during demolding because we had to cut out windows for patching and transport. But we're confident that the mold would hold up for 10 demolds. It is theoretical, but it's based off of previous experience in past years.
you say that you didn't have time to do the abstract, the visual abstract.
We did the abstract. It just never got attached to the final report. So if you went by our canoe on display day, you'd see that we did have our visual abstract displayed. It was a huge oversight, the fact that it did not make it.
Yes, I'm curious to know the sample of your concrete and the air concrete.
Do you have it?
The slump was 0%. I'm unsure on the exact air content, but our mix is very porous.
The zero slump.
0 millimeters.
So I guess, I'm sure you had your difficulties this year, obviously, with what we're seeing, like you said, with some oversights. Do you think, you maybe spread yourself too thin because you change your molding technique? You're trying to change a lot of parameters, and then you're missing out on a lot of things, Would you consider maybe not trying to change so many things? How do you think you took your approach, is what I'm saying? Because there seems to be a lot of oversight, maybe focusing on just recreating the same canoe. Some people reuse molds, some people,
That would be an option. We've always tried to push ourselves to improve. And while our canoe is very different from last year's canoe, I think it bears a lot of resemblance to our 2023 canoe. Winnie the Canoe, which was a project I was also a part of, and it was a project that had a good amount of success even compared to last year's boat. So we were going based off of previous designs, just not so much last year's design.
So you use high grade slay in your report, it's 100. If you look at any other different grades of slay, compare that to 20 or 90, see if that would have a bit.
No, we just kind of stuck with the slag that we used in the past year because it worked for us, and we were getting the better results adding more slag, so we just wanted to stick with the same grade of slag because we were short on times.
Maybe I have time for a quick one. The casting sandwich system relies on uniform 9 millimeters layers.
How do you
Guarantee that your mesh remains properly
parallel since it's specific?
because you have curved area.
So
We used depth gauges, so it was essentially a bamboo skewer with marks at every 10 millimeters. So for the first millimeter, you would cast to the first mark. If you needed to adjust, then you could. And then for the second layer, you would cast to the second mark with full 20 millimeters thickness, with the idea that we were going to send off a millimeter on either side.
While using a cementitious material, so we know the function of some materials will react with some lime of cement, create more CSCE, more of the. So I saw you use fly ash, methacrylate, slag. Do you think that with the amount of cement you have, should have used all these materials?
I mean, we tried to stick to 4 cementatious materials, including cement in our mix, because we didn't want to add in extra cementatious materials, but we could look to next year to changing that up a little bit.
just a quick one here. I understand Kate is your last year this year.
It is.
What are you guys doing kind of looking forward for next year in terms of turnover, in terms of making sure you got a lot of members this year? What's the plan for next year?
We're going to maybe making some meticulous knowledge transfer documents, and the entire team has my phone number if they have questions. But also Cam, my junior captain, he's been shadowing me all year, and he's been picking up a lot of the knowledge. So I'm hoping that just sharing of knowledge throughout the year will also transfer.
Well, that's 7 minutes. Thank you, Manitoba, and thanks for having me.
You're amazing. Kiel, do you know which one are the veg ones? No.
It's all the same one. But at least open the proceed.
Oh, okay. So I think yeah, like the human freckles. S'il n'y a pas d'œuf, c'est à les autres. Aubrey coffee?
The jungle, Earth's heartbeat beneath a canopy of green leaves. This is what inspired Laval's theme for 2025. I'm Kim, and alongside me are my colleagues Amelia and Pierre Alexandre. Today we are proud to present our latest creation, Canopia. Born from a rigorous research and development process, this canoe is specifically designed for mass production with sustainability at its core, featuring a new revolutionary concrete mix that uses almost no cement. We are confident that this product will not only meet but exceeds our clients' expectations.
Building on the team's 28 years of experience, 2 captains and 10 managers were appointed, each responsible for a specific sphere of the project. This functional structure allowed every manager to become an expert in their respective field, enabling us to tackle the project's technical challenges.
To ensure coordination within our large team, weekly meetings and social activities were held. In addition, a detailed schedule was created and key milestones were identified and used as reference point throughout the project to ensure its smooth progress.
Given the tremendous success of Maple Drifter on water, we chose to retain its hull shape, allowing us to reuse the mold. Our vessel features flat bottoms and low riders, ensuring the perfect balance between straight line speed and maneuverability. However, the structural elements were redesigned. 2 additional ribs and a chamfer under the gunwale were added, enhancing the overall strength of our product.
Structural analysis was conducted based on 6 failure modes under 6 load cases, allowing us to determine the strength criteria for the concrete mix. The hull and gunwales were analyzed following the longitudinal analysis, with the main tandem being the governing case for the stresses in the hull. The ribs, on the other hand, were analyzed under transverse bending, with the quadrate generating the bigger stresses. This revealed that the ribs face the most extreme forces, both in tension and compression, directly shaping the specifications for our concrete mix.
This year, our biggest innovation lies in the development of a brand new cementous matrix through extensive research and optimization. Our team has successfully created super sulfated cement with a C/CM ratio of just 2%. But that's not all. These new mixes are 29% stronger than previous versions, while also allowing for vibrant, bright colors. Composed of ground granulated glass, furnace, calcium sulfate filler, and Portland cement, this matrix was paired to our signature aggregate blend, Prover, Perlite, and Norlite, creating a perfectly well-graded particle size distribution. Leveraging our iterative approach, we selected 2 final mixtures, one for structural applications and the other for aesthetics. With a compressive strength of 11.9 MPa, a tensile strength of 3.8 MPa, and a low density, our structural mix is built to withstand the demanding conditions.
Following the success of last year's female mold and formwork construction method, our team perfected and reemployed it for Pinocchio. The mold is precisely cut from foam using a 5-axis CNC machine, while the reusable HDP formwork shapes the structural elements with remarkable accuracy. On casting day, concrete is rolled into thin tiles using a guide system before being placed in the mold. The casting process consists of 2 strictly controlled concrete layers separated by a mesh layer. Once the whole is formed, the formwork is added and then filled with concrete. Its perfect alignment highlights the precision of our technique. Finally, to enhance the natural beauty of our product, CNC cut inserts were used to create Canopia's vine. Recast animals are then added, bringing the final design to life with depth and character.
After casting day, the canoe cures in a humid chamber for 28 days, with humidity monitored using a hygrometer. The mold and formwork are then removed, and the canoe is hand-sanded to a thickness of 9 millimeters, using sandpaper ranging from 40 to 1,000 grit. After that, graphic stain patterns are added, and finally, the canoe is sealed to make it completely waterproof.
After a thorough analysis of the project, our team has streamlined and industrialized every step of the process, following an optimized production sequence. With this refined schedule and our cutting-edge advancement, we are confident in our ability to produce 100 canoes in about 2 years for our clients. Overall, Canopia is the ultimate choice where innovation meets sustainability, delivering unmatched performance
Powered by the jungle.
Ok, thank you.
Des questions en français.
Ok, c'est bon. On se revise un peu. Là. Ok, dans notre analyse structurale, vous appliquez des applications d'un facteur de 1.95. Ensuite, vous designez les ribs. Par contre, après ça, vous dites, once the concrete mix strength was confirmed, the ribs were reduced to their minimum dimensions. Ouais. Donc, on dirait que vous sautez coq à l'âne dans le design. On parle de designing strength, ensuite vous faites un mix et ensuite vous revenez redesigner. C'est quoi qui dit quoi dans le processus?
Ben, à chaque année, dans le fond, on a des guidelines pour nos dimensions de ribs. Puis justement, là, je veux dire, on les dimensionne soit à la sollicitation proche de 100%. Puis on fait le design en début d'année, puis on développe nos mélanges tranquillement à la suite. Puis là, cette année, justement, là, quand on a vu qu'on avait un mélange qui était plus fort, puis justement avec les nouvelles règles pour la dimension de ces éléments-là, ben c'est là qu'on a décidé des dimensions précises, là, sachant la résistance de notre mélange, puis sachant là, pour aller chercher l'optimisation la meilleure possible.
Sauf que vous le faites une fois, je comprends qu'il y a un processus d'optimisation, mais qu'est-ce qui vous fait arrêter d'abord? Qu'est-ce qui vous empêche de continuer à faire
c'est notre timeline. Dans le fond, on a coulé et c'était autour du 20 décembre. Puis ça, c'est certain que ça ne bouge pas. Puis avec notre système de coffrage, on est capable de créer le coffrage là, assez dernière minute. Fait qu'on peut changer là, ces dimensions-là dans un court délai là, avant.
OK, puis vous dites que vous avez des guidelines qui sont basés sur quoi les guidelines des dimensions pelliculaires?
Les anciens canaux, premièrement, ceux qui ont bien fonctionné, moins bien fonctionné. Puis ben, définitivement l'analyse des charges puis de chaque cas de chargement.
Puis vous dites aussi à quelque part que vous utilisez les anciens canaux, justement, vous les testez, vous les utilisez. C'est quoi les tests que vous faites dessus? Puis pourquoi on ne voit pas les données de ces tests-là dans le rapport?
Ben, premièrement, par exemple, à Satot, notre canot d'il y a 2 ans, on l'a scié, puis on a testé des panneaux des panneaux du canot pour voir si la résistance en flexion était la même avant puis après les compétitions. Puis ça, c'est un des tests qu'on fait. Puis pourquoi on n'a pas présenté ces données-là dans notre rapport, justement? C'est parce qu'on ne trouve pas pertinent de sortir du vieux stock pour justifier ce qu'on fait cette année, parce que justement, le mélange n'était pas pareil. On peut avoir une idée de, OK, est-ce que notre canot perd de la résistance avec le temps? Mais je ne crois pas que c'est utile au design du canot actuel.
Dans votre rapport, vous concluez que le transport impose une contrainte de compression qui est plus élevée que la course masculine. Un MPA versus 0,68. Pourquoi vous pensez que ça produit un tel écart? Puis est-ce que vous estimez vraiment que c'est plus critique la course?
Définitivement, c'est le cas où le canot est simplement supporté sur les supports. Puis, oui, la contrainte est plus élevée là, à cause de la position des supports. Puis on utilise aussi le cas le plus critique, là, où nos supports sont complètement distribués, mais en réalité, sont un petit peu plus proches. Puis, sur papier, c'est le cas qui est le plus pénalisant. Mais, à mon avis, là, la course demeure quand même le cas qui est le plus dangereux, étant donné tous les effets dynamiques, toutes les choses qu'on ne contrôle pas durant la course, parce que quand le canot est sur son support, il est en mode statique, puis il y a d'autres qui l'influencent, qui ne sont pas beaucoup.
Si je peux rajouter, lorsqu'on transporte le canot, on le met à l'envers que lorsqu'il est sur l'eau. Donc, l'axe neutre est inversé. Donc, la compression à ce moment-là, contrairement à quand il est dans l'eau, la traction est critique, c'est elle qui guide. Mais là, puisque l'axe neutre est inversé, on transporte à l'envers. Là, ça va être la compression qui va guider à ce moment-là.
Vous avez fait votre analyse structurale après votre coulée. Vous ne voyez pas un problème à faire ça?
Dans le fond, cette année, on n'a plus se permettre de faire ça, étant donné qu'on avait exactement le même cas que l'an dernier. Comme j'ai dit précédemment, là, on a optimisé. Dans le fond, on a changé nos éléments structuraux. Ceux-ci ont été conçus là, avant justement pour s'assurer qu'on tienne. Puis on a pu faire notre analyse structurale après parce que c'était exactement la même chose que l'an passé. On savait, puis on avait un mélange encore plus résistant. Puis on était quand même confiant des calculs qu'on avait fait l'an dernier. Puis on savait qu'avec le béton qu'on avait cette année, le canot tiendrait. Puis on a refait une analyse justement plus poussée à partir de celle de l'an dernier. Puis on a pu faire ça aussi après Noël, après la pluie, parce que c'est une période où on est moins occupé, qu'on a plus de temps pour faire une analyse de qualité.
Une question concernant le body design. Il y a plusieurs types de qualifications de page. Il y a le gypse, le gratte. Quoi vous avez fait
premièrement, dans le fond, on a fait une revue de littérature sur le ciment sur sulfaté. Puis nous, à Québec, on a eu beaucoup de difficultés à se procurer ce produit-là chez nos fournisseurs là, de matériaux cimentaires. Donc vraiment, on a pris ce qu'eux avaient à nous offrir. Puis on est vraiment, je veux dire, notre recherche et développement pour ce béton-là est vraiment un stade embryonnaire. Je veux dire, on a environ 1 mois de test. Puis on a vraiment pris, dans le fond, on voulait avoir le calcium sulfate le plus tôt possible. Donc, on a pris le premier qu'on a trouvé. Puis après ça, on a optimisé. Puis par rapport à la littérature, on a ajusté nos dosages et nos mélanges pour obtenir quelque chose qui fonctionne.
Et je pense que dans votre FPA, vous avez également, vous avez parlé que c'est un filaire, mais ce n'est pas vraiment un filaire. Ça s'appelle Snow White Filler, mais ce n'est pas un filaire. Filaire, c'est un matériau qui remplit les vitres, qui ne réagit pas. Dans votre cas, j'imagine que
C'est le nom du produit. Là. Sur la fiche technique, c'est son numéro de calcium sulfate.
Vous avez dit également que vous avez mesuré la longueur de ciment pour voir s'il y a pas beaucoup d'expansion.
Oui.
Donc, vous avez utilisé quel outil pour voir qu'il y a-
On a utilisé un vernier, dans le fond. On a parlé justement avec les professeurs de notre département. Puis le professeur avec qui j'ai parlé, lui, avait déjà fait des recherches sur le ciment sulfateux, puis il m'a dit que lui, dans ses processus de recherche, il avait instrumenté pour mesurer au micron, puis que les fois où ils ont observé là, du gonflement, on le voyait à l'œil nu, puis c'était flagrant. Fait que dans ce cas-là, justement, on savait qu'on n'avait pas besoin de se doter d'instruments super précis, parce que justement, avec son expérience, on savait que s'il y avait du gonflement, ça serait flagrant.
Vous mentionnez dans votre proposal que vous mettez 2 épaisseurs de 9 mm et puis que ça revient toujours à être plus épais.
On a 2 couches de 4.01 mm.
OK, désolé. Alors, en tout cas, ça dit que l'épaisseur actuelle est toujours plus épaisse que l'épaisseur théorique. Est-ce une hypothèse ou une raison pourquoi que ça serait le cas?
Ben oui, parce que dans le fond, on a un genre de cadre dans lequel on roule notre ciment, notre béton. Puis, il arrive des fois qu'on en met trop, puis que ça dépasse un peu du cadre, bien on essaie d'être précis. Puis, une fois que quand on met nos tuiles dans le canot, ben, il reste toujours un petit joint qu'on doit remplir. Puis, des fois, ben, on met justement plus de béton dans ce petit joint-là, qui fait que l'épaisseur monte progressivement. Puis, après, si on roule avec des petits rouleaux là, pour avoir une surface qui est homogène, puis justement, là, c'est peut-être d'avoir plus de béton dans les joints. Quand on roule, ben, on distribue ce béton-là sur toute la surface, ce qui fait qu'on a finalement un petit surplus.
Si je peux ajouter aussi, on a des coulées de pratique avec une section en modèle réduit. Puis on utilise justement les mêmes plaques à la coulée. Puis c'est vraiment ça là, qu'on a remarqué que c'était constant, par rapport là, à tous nos essais, qu'on avait toujours une petite épaisseur de plus. Donc c'est pour ça là, qu'on on a considéré la petite épaisseur de plus.
C'est lié à la distribution.
Tu mentionnes que vous avez un béton plus fort que d'habitude. Là, vous mentionnez que vous sortez du moule 7 jours pour prévenir le projectile, le shrinkage cracking. Pourquoi de 7 jours? Pourquoi pas plus tôt s'il est plus fort et vous pourriez encore plus réduire le shrinkage? C'est quoi qui dit que ce 7 jours-là?
Encore une fois, selon une revue de littérature, le ciment sur sulfateux cure beaucoup plus lentement que le béton traditionnel. Puis comme on n'avait justement pas d'expérience avec ça, selon nos tests de compression dans flexion en 7 jours, nous ont montré qu'il était assez résistant. En le sortant à 7 jours, on savait qu'il serait assez fort, que le béton aurait développé ses résistances mécaniques. Puis, justement, là, on pouvait limiter les déformations à cause qui continuaient.
Vous aviez des tests, non? Vous avez fait des plus petits temps.
Oui, exactement.
Donc, vous n'avez pas pu démouler plus tôt?
Le vrai canot, les sections de pratique.
Les pratiques, vous n'avez pas révélé le temps. Je sais que c'est arbitraire, cette jour-là. C'est quand même, vous auriez pu pousser ça à 6 fois.
Je pense qu'avec toutes les modifications qu'on avait apportées cette année, on ne voulait pas ajouter une autre variable. Puis on a vu justement sur les sections de pratique, quand démoulant à 7 jours, il n'y avait pas vraiment de fissure. Puis que le fini était bon. Je ne sais pas questionner plus que ça.
Puis aussi, si je peux rajouter encore une fois, on fait souvent là, des mélanges et les coulées de pratique le lundi et le mardi. C'est là que les gens sont disponibles aussi, donc ça revient chaque semaine. Donc pour nous, c'est vraiment plus simple de faire ça dans les plages horaires qui sont prédéterminées là, que d'aller chercher des gens pour démouler. Tout le monde est très occupé, là, donc c'est vraiment plus simple pour nous de faire ça une fois par semaine.
Je me permettre. Donc, est-ce que vous avez utilisé un retardateur?
Oui, un tout petit peu de Massachusetts, étant donné que notre foulée est faite en 2 épaisseurs, on va être sûr de. Justement, ça a été une des choses qu'on a dû travailler beaucoup, nos adjuvants. Puis, étant donné qu'on coule en 2 étapes, on veut minimiser les joints froids. Puis, justement, là, on l'a testé dans tous nos mélanges de pratique pour s'assurer d'avoir le bon dosage de retardant. Puis aussi, c'est encore quelque chose, on est dans l'inconnu, on n'a jamais fait du béton comme ça. Dans nos bétons traditionnels, on utilisait toujours du retardant pour éviter les joints froids. On voulait quand même garder ça pour garder une petite sécurité.
Beaucoup plus dans ce mélange que
Une super moins.
un peu moins que dans un mélange traditionnel.
Oui, définitivement.
Merci, Laurent. Merci.
Hey, is everyone coffee? Do you need coffee?
It's impossible. It's impossible. Well, are you judge after trial there? Need most of you. It's pretty good to me. What do you taste? Oh, that's nice. It's your 500 meters, 10 millimeters thick, constructed with the finest techniques. We made the biggest taco.
Good morning, everyone. As you may have heard, in this 2025 Coffee Canoe competition, we made the biggest taco. It's not only amazing and delicious, but it's also something that Toronto Metropolitan University is very proud to present.
My name is Angela Intong. I'm joined together with Jeremy Winnick and Christian Burita, and today we're presenting Taco MU. Alright, so there's three main reasons why you should choose to invest in Taco MU. The first is that we have a very client-focused design. So our major innovations in our hull design, our mix, and our structural were based on the needs of the buyer, the needs of the users of the canoe, as well as the needs of the manufacturer. Second is that at every single point in the construction and development of our taco canoe, we've tried to minimize our environmental impact. This is by reducing our carbon footprint as well as our waste. And the third final reason is that our canoe, based on its construction methods, is very easy to replicate on a large scale. Now, for the client-focused hull design, we've taken into account the experience of our past paddlers last year. The first is we tried to address maneuverability because that was a great challenge. The way that we did that is we introduced rockers this year by uplifting the ends of the canoe by 69 millimeters. Second is we tried to make our canoe more speedy by making an asymmetrical hull. Having a more narrow entry allows the water to displace around the canoe more efficiently. So we hope that that will do that. And then thirdly, we also flattened and narrowed the cross-section because there were problems with instability. So we hope that having a more flat-bottom hull will give more stability and comfort to our paddlers.
So after doing some further analysis on that hull design, we went through all the structural cases and we determined that the punch and shear analysis was the most critical load. We took a section, 2.5 inches by 2.5 inches, and we considered that to be a paddler's knee. We considered a paddler to be 80 kilos, because that's our end user, the heaviest user that we want a canoe made for. And we made a mock section of our canoe. We tested putting weights on that section until it reached a breaking point, and that was at 140 kilograms. So based on what our goal was, which is a 2x factor of safety of 160 kilos, and the real life existing conditions of actually building that canoe, we felt 140 was very reasonable and we felt confident in our canoe. Our mix design was a crucial innovation this year. This year, we took our geopolymer concrete and we made it lighter. We made it 865 kilograms per cubic meter, which is significant considering last year was over 1,200. This meant that we could actually remove the bulkheads, further reducing the overall weight. And with a 10 millimeter hull thickness, this made our canoe the lightest our team has ever made. At 75.6 kilograms, this is 40% lighter than last year's canoe, which to us felt amazing. We're also very environmentally friendly. We have our geopolymer concrete, which has zero cement. This is an innovation we've worked on for a couple of years, but this year in particular, we optimized it. So we got the lower density, but we also changed the mix design around to make it more focused on being able, the constructability of it. This meant that we used 35% less concrete in our final product. And this was also done using our rolling casting method and our thinner hulls. So all these factors together contributed to that amazing number. We also had a 30% reduction in total foam usage for our mold. This was done using hollow mold design, but it was also done using a new method of putting our sheets together for our CNC, and that transitions to our mass production.
The third and final reason why you should invest in Taco MU is because our canoe can be efficiently mass produced. Firstly, this is because our canoe uses a reusable mold. Our mold can be used a total of 10 different times. Second, our canoe is air cured. The air curing method reduces both energy and cost when mass produced. And finally, our canoe is constructed quickly with our new innovative rolling technique. Our rolling technique is 65% faster than last year's hand padding method. So we are asking our judges for $6.8 million to cast all 100 Taco MU canoes. TMZC built a canoe that is client-driven. It is environmentally friendly, and finally, it is efficiently mass-produced. And for these three reasons, we know the world is eager to take its first bite of Taco MU. Thank you.
Thank you, TMU. I guess it's Taco Friday. Okay. I mean, I'm gonna have to challenge you on this, obviously, because this is an absolute statement. and I quote you guys, the canoe was air cured for 14 days to allow the concrete to reach its full strength. Can you please defend that?
Yeah, so full strength was used in the term of like being able to demold it and then being able to start sanding and aesthetics being. So when we're talking about full strength, we're just talking about like the actual usability.
Okay, and then can you dig into this air curing? Because everyone seems to be using water and you guys don't, so I don't know. What did you discover here?
So we felt that with air curing, although there are the disadvantages, like of course humidity curing reduces cracking and has disadvantages. With air curing and mass production, we felt that the advantages severely outweighed the disadvantages. We had tested our concrete in humidity chamber versus just being out in the open. And although there were differences, we felt that with our strength, meeting all the requirements and us meeting all the requirements that we needed for our canoe to survive in the competition, we felt that it was the right decision.
Okay, and then I'll continue a bit on mixing and things. You guys mentioned that you have an air and training admixture provides hard and more cracking resistance for the aesthetics layer. How would air and training increase cracking resistance?
With the added air, it allows for less cracking, and this was tested based on our prototype canoe, where we tested half our canoe to allow for our casters to get a better sense of the cast of the canoe, and it also allowed for us to get a sense of how our mix would behave. And using that, we knew that the air and trainer would, in fact, help with the shrinkage grounds.
Sorry to jump on that. Do you agree that when you have more air, you reduce the composite strength?
I do believe that. However, this year was all about optimization, and we achieved the necessary strength we needed with our composition.
You don't understand how you reduce the composite strength, yet you increase the ability to not have cracking. How can you?
I'm sorry, can you repeat the question?
I mean, how can you reduce the composite strength by increasing the air content, yet still have better behavior regarding the cracking?
Our mix design was proposed using many different iterations, and we played with a good amount of air and trainer and the compressive strength, and we had lots of tests, and that's how we established that our mix was in fact suitable.
You said that each canoe requires 360 hours to make. Yeah. So how would you meet the RFP demands for 100 canoe in 6 months?
So, if chosen to be mass produced, the first thing we would do would be create a line of balance diagram. We know that the construction of 100 canoes is a very repetitive process, and many different processes can be overlapped. For example, curing can be done at the same time as pre-batching the next mix. Sanding can be done at the same time as pre-batching. Therefore, it will not be one canoe, one canoe, one canoe, one canoe. Many different canoes will be made at the same time. For example, the mold will be CNC'd all 10 of them at the same time.
Okay. You obtained an FOS of 15.9 in bending. Why didn't you optimize the wall thickness or remove structural redundancies to reduce weight or cost?
We felt that with our structural analysis, after considering, of course, the 4-person load in other cases, with our gunnels and ribs, bending, we felt wasn't as much of an issue. Due to our experience in previous years, it was always punching shear that seemed to be our biggest problem. We always focused.
So this year you went with a base natural shape to what consideration was put into the forward map?
We made sure not to make the asymmetrical shape too drastic. We actually did our hull design before the stuff came out about the races, but then we kind of looked back and reworked it afterwards. It was a lot more dramatic, the asymmetrical shape, but then since we saw that, we decided to move the largest part of the canoe a bit closer to the middle, and then not make the biggest part as opposed to the smallest part too drastic there.
In your proposal for project management, you guys say that you used a hybrid model with agile critical path. Did you find that your agile test pushed out critical path tests in actually throughout the year? For defining project management of this year's canoe, there's always going to be critical activities. That, of course, included casting day, because you have to put that in a certain time that allows for proper amount of time for curing, for sanding, and for sealing. And of course, there's also agile activities that can be worked around, and that more consisted of the mix sessions. We only did those if they were necessary. We would only do a mix session if we knew that we could improve on the previous ones done. And this, again, as I said, this improved environmental sustainability, because we never did a mix if we didn't know that it improved on an aspect of a previous mix. So answering your question, did it push out? I don't think so, because there were critical activities, but there were also agile activities, and I made sure to keep those separate.
Another question on the hull shape. You guys introduced a pretty significant rocker this year. Did you guys test that shape at all, the hull shape?
No, we didn't have time or resources to test the hull shape because we wanted to do it before the year started because of the resources available to us.
Yeah.
But this decision was done based on a lot of research into hull shapes.
Right. The reason I ask is that I'm just wondering if it's going to be like a teeter-totter effect where you're going to lose stability in the longitudinal, the long direction, front to back. I guess we'll see.
I believe that this competition is all about engineering and taking risks. We took a risk with the bulkheads. We're willing to take the risk with the rocker too, to push the limits of this competition.
Yeah. In your structural calculation, you reported the elastic modulus of 80 gigapascal, which is very high. For regular concrete, it's around 30 gigapascal. So ultra high performance concrete, you can be around 50 gigapascal. Did you measure this value?
Looking back at this year, we weren't perfect. We had other flaws, and that was definitely in the structural analysis section. And we do acknowledge that there were mistakes in calculations. And that, of course, is one of the ways that we can improve for next year. We're not perfect, and this is definitely a flaw that we had this year.
Did you analyze cold joint formation risks between anti-static and structural lasers since you're casting these apart?
Of course, yeah, that was definitely a major consideration made when developing the schedule of our canoe. However, we did do a mock canoe that consisted of half the canoe, and we did paint on that aesthetic layer mix. It has a 200 slum, so you can see that has a quite low viscosity. And because of that, because of testing, we knew that the joint would be quite strong. And also the structural layer was quite rough. We didn't completely sand it bald. We made sure that there was still a rough surface for the aesthetic layer to bind to. Putting together the rolling method that you guys have made tiles to lay up, you guys say you hand padded all of the joints for that. So you had consistent layers when you made the tiles, but what did you do to control the thickness at all your joints? That's a good question. So this year we had other quality control measures besides just rolling pin strips. We also have toothpicks, and we have 5mm strips that we constantly put on the hull throughout casting day, and that ensured that even with the hand padding, the thickness would always remain constant.
Yeah, and on that note, we have it locked on the same page. You show using toothpicks for your thickness, and then you also have an electron microscope for other things. So do you think that in the future you'll have something maybe more refined than toothpicks to check the thickness?
Yeah, I think that was kind of like the third level. So we had, like Christian had said, we had the rolling and that kept the tile straight. And then we had the quality control strips that we put next to it. The toothpicks were almost like a backup to the back. We wanted to just make sure.
All right, thank you, Tiffany.
If it becomes a problem, we'll get someone to go to the store and start grabbing it. We'll try it out.
You're on a quest to find Excalibur.
You must build a canoe to find the sword.
Hi, my name is Alexandria CL, and this is Patricia Owen and Ainsley. We McMaster Concrete Canoe are so excited to take you on a treacherous journey to forging Excalibur for the World of Concrete Expo 2025. This entails going over the project goals and coordination for such a large-scale project, the hull design and mix design for this prototype, the construction processes, and finally, the production for 100 canoes. As this is the second prototype McMaster has ever made, a lot of focus went into creating a more refined final product by improving the mix design and construction. Our goals were to reduce the Portland cement in the mix design and also reduce casting time. Similar to the inaugural year last year, we wanted to focus on sustainability, growing from environmentally to also financially and socially. Together, these goals ensure that the prototype can meet climate standards and also be easily mass-produced. Starting off, The team leads were designated different aspects of the final project, and a timeline was presented with major milestones emphasized. As such, the project was split into subtasks, and general members were given more agency. This is especially important for the team growth and knowledge transfer, and also meets our social sustainability goal. Lastly, monthly team meetings were organized to ensure constant communication and adjustments were made.
This year, we wanted a client-focused design, focusing on a more slender hull. Using input from our paddlers, our hull had a length of 5.6 meters, low rockers, and a flat bottom. This year, we had an almost 10% decrease in our width, with a width of 0.65 meters. We also have ribs for added structural stability and a keel to strike the balance between maneuverability and effective straight line tracking. This year, we used two main structural analysis softwares, SOLIDWORKS and SAP 2000, creating our initial design in SOLIDWORKS and then using it for multiple simulations. Moving into SAP, we use that to create our loading cases for both paddlers and our stands, creating custom members in the software to get a more accurate representation of our canoe.
When looking at the mix design this year, we had two main goals: lowering the amount of Portland cement and increasing our strength through optimizing the particle packing density. To lower our Portland cement, the team opted to increase our recycled glass powder due to its sustainability benefits and lower density. This resulted in proportions of 20% cement, 20% silica fume, and 20% slag, 40% glass powder, as can be seen in Figure 1. Now, to optimize our strength to increase our strength, we wanted to optimize our particle packing density using an in-house program we made called PULSE. PULSE validates the modified Andreessen and Anderson method. We double-checked this method using compressive tests and X-ray computed tomography, which was done at the Canadian Centre for Electron Microscopy. Essentially, we took X-rays of our cylinder, which showed how much airspace is in each cylinder. We then compared the amount of airspace to the compressive strengths of each cylinder, and we found that the cylinder using PULSE had the highest compressive strength and least air spaces. This resulted in a compressive strength of 17.13 MPa, which is a 29% increase from last year.
To ensure greater accuracy in replicating the hull, a female mold was selected from last year's male mold. This was built by laser cutting cross sections of the hull and attaching it to wooden board recycled from last year's mold. The gaps between these were then bridged with thin wood slats and finally finished with a thin layer of non-stick tape. With a more stable base and improved mix design, the construction process went a lot smoothly this year. The concrete was applied to the mold in two layers of 6 millimeters and 12 millimeters respectively, with a layer of primary reinforcement in between. This application process allowed for a more even, consistent layer. After this, the canoe was then sealed and wet cured for 28 days and then demolded. Finishing off, the hull was then sanded for uniform thickness and finally sealed for waterproofing. The choice of a more slender canoe with decreased flared walls and a more well-defined keel is hopefully going to produce greater agility in the races. The choice of one mix design and a simple two-layer construction method creates ease for mass production. Maneuverability, strength, and sustainability surpasses all of our clients' goals and meets all of our team expectations. Thank you so much for joining us on this noble quest. We hope to see you all on the battlefield with your own Excalibur.
Thanks, Master. Welcome again. Good to see you guys again for a second year. It's nice to see you continuing. I think a pretty obvious question that comes to mind is why do you have a first layer of 6 millimeters and a second one of 12 like that? That's two different things. Most teams just split it in half.
So actually, we wanted this because the hull, we chose a female mold this year, 6 millimeters being on the first layer, and we would say that we wouldn't sound this and would sound the interior more, and so we made the interior layer thicker, especially if we made any mistakes. The interior would be thinner, but I still have structural integrity.
Because I'm thinking in a mass production scale or even on a smaller one, quality control is always easier when you have a repeated process. Whereas now you almost have to get people ready for two different processes.
We didn't find that was a problem during our construction process. We had one table for 6 millimeter tiles and one table for 12 millimeter.
We also did the first layer at once and then the second.
You have a curing period of 42 days. Would it be possible to narrow it down to 28 days with your current mix?
And how come
You used 42 then?
Honestly, we were just better safe than sorry, and we had more time to sand and stain, so we just left it in there just to let it cook a little.
Really high strength, yeah.
Okay.
You say that you optimize your grading using poles?
Yeah.
Poles. Is it based on Andreessen and Andersen?
Yes.
Okay. Cool. Is that packing density only or just grading optimization?
It was optimizing the aggregate grading curve.
Grading curve.
So hopefully optimize also the packing density.
But it's not exactly the same because the packing take into account the shape as well.
Yes, yeah, so it's not
So
packing,
you don't take into account the shape.
On similar notes, so you tested different mixes of gradation there.
Yeah.
So the best results were the one with the 5% of the you did test a mix of particles. So you were seeing improvements in stop.
Mhm.
What was the choice? Why?
Well, the way that Hall works is we put in the sieve analysis of all the aggregates that we're using, and then it uses a solver to match the particle size distribution curve from Anderson, and then that's just the numbers that we used. The one that most closely matched that curve.
But you fix the Q value. So how do you fix that value?
We just researched the Q value and then found the one that was most commonly used. We didn't change the
You didn't check the Q value. You didn't find the Q value which represent your
No, we weren't testing the different Q values, we were just testing different solvents. But that's a really good idea.
And the last one for me, how do you optimize your aggregate? Then in your mix design sheet, you have like a curve saying that you have a target aggregate, you have the actual mix particle size, and the target mix. How do you manage to be close at the same time optimize with the goals?
Well, our optimal was to get as close to the targeted curve.
It's happened to be close to.
Yeah.
Again, a bit on mix design. In your report, you guys say that articles and research papers you followed typically saw a decrease in compressive strength after 20% replacement in hydraulic cement, but you guys saw an increase. Did you guys dig into why you guys saw the opposite?
No.
It was more like a happy accident. Yeah.
Okay. But yeah, I guess, yeah, did you guys double check anything to make
Yeah,
sure?
we did a lot more iterations of the same mix just to make sure it wasn't, because when we did the test, we were like, oh, that's really weird, but it ended up working out.
Okay. And then you guys say you used SolidWorks for simulations as well?
Yes.
Okay, did you guys do any mesh convergence studies for the FEA analysis?
Sorry, mesh conversion studies?
Yeah, to make sure like the mesh you're using in the finite element analysis was correct.
No, we didn't do any mesh conversion studies. We mostly did different case scenarios. We did drop testing, basically testing for the swamp test using forces and acting as a pressure just when the water goes in. So it was more testing along those lines. We didn't do any mesh conversion.
Yeah, I guess, yeah, mesh convergence I meant for generating the finite element analysis model, like the mesh of the model itself.
Oh, the model was more of it was a solid. So yeah. So like it wasn't like converted from like I guess like technically when you put it into a solver simulation, it meshes it out. Like
yeah, I guess not mesh. I meant, did you guys do any study on that to make sure the size of it was correct to not get high concentrations that?
No, yeah. When we actually put it in to do our structural analysis, we made sure that it was accurately representing our hull. It wasn't like super compact and like the points are basically the bow and the stern and not like spread out. We wanted to make sure that it was correct. And it worked out really well this year. I know last year we had struggling with that because we really wanted to do structural analysis of solvers. We couldn't quite figure it out. So this year it was kind of in our favor.
for sustainability, then you have to focus on your. Did you look at the impacts in the
We did look at that. All of our cementitious materials were purchased, all of them were purchased from Hamilton or Toronto. And then the farthest of our materials is Port River, which is a bit more. But everything else is produced in. And also, one of our team leads is the safety and sustainability lead, and that was one of their primary objectives, was to research this.
You reported a value of 8% of air content without using really air training application. Can you explain?
Yeah, that's just what happened. Yeah, we didn't really look at our air content in terms of something that we were going to increase or decrease. It was just sort of a number that we got.
Did you calculate? Do you have a strict mixing time? Like, okay. And did you report different values? Do you ever change that? Did you play around with that?
We did change around our mixing time, but more so for workability than air.
Okay. Was that for sure bigger?
Your maximum design stresses are very low compared to your material strength. Could you have it reduce your hull thickness below 18 millimeters to save weight or without risking failure?
Sure.
Yeah, I think that's definitely an improvement that we could look at for next year.
Okay. And you say that you consulted previous year's report for your design, which is a really good idea for new teams.
Good.
Yeah. What lesson did you learn?
Yeah, so one of our first steps to get general members involved is having a bit of a research assignment where everyone picks a team and they collectively research it. We go through all the reports together in a meeting, basically just picking out design elements that we want to focus on this year. What we learned is kind of like the output of our canoe. We saw a lot of very good performance from a model with lower rockers and flat bottom. That was two of the features that were not on the canoe. And then also consulting, with our paddlers, because they're obviously the clients, they're the people using it. So they're going to have amazing feedback, which they did. One of them was that it was too wide last year. They felt like they were reaching over. And things that we addressed in shrinking the width of our canoe.
Maybe a follow-up question to Ravin's question about the curing period. Do you have a sense for the strength gain between what would have been your theoretical 28-day and what would be as your 42-day, since the canoe was cured for an extra bit there?
I guess technically the cylinders that we submitted yesterday would be a representation of that, since we casted the cylinders on cast.
Okay, so the cylinders would have been cured 42 days as well. So I guess the answer is you're not sure what the strength gain would be between 28 and 42.
No, but we'll find out when we get our compressor strength.
Fair enough.
You mentioned that the display case is the controlling one. The display loading case experiences the highest bending moment and shear force.
Yes.
Isn't it something you could control though?
Yeah, we could control it, because we do build the display. So obviously there is that factor in it. But, with where we wanted to take our display, with the ideas we had, it just kind of worked out that was the.
It also wasn't a concern for us with the strength of the.
Yeah, we had really good numbers this year, so we were pretty comfortable with that being the best one.
Just for future, the display could.
Mm-hmm.
All right. Thank you very much, Matt. We're great to go. Oh.
Your hands, I'm sleeping and your hands like I'm having a beat before. Yeah. Even like don't even if you go too close to it, you'll be out of it. Last presentations before the short break, please people let them present.
Okay. Technical problem. Apologies.
From crossing ancient Olympia's Greek gods to sailing the vast ocean on a shark, this year WEC is excited to take you guys on a brand new adventure in the safari with our most innovative and greatest accomplishment yet, a design made to perfect the manufacturing of a sustainable and a viable canoe. Standing in front of you is Daniel, the construction captain, Tyler, the software captain, and myself, Hirad, the Concord captain, and we are pleased to present to you Giraffe.
At 5.71 meters in length, 0.6 meters in width, and a minimum hull thickness of just 11 millimeters, Giraffe is our absolutely best designed canoe to date. We're proud to introduce a number of new construction features too this year, including a 6mm rebar embedded directly into the gunwales and just one single lightweight layer of mesh wrapped around the entire hull. This year, WECA decided to revamp our entire SolidWorks modeling process workflow so that our design engineers could iterate at a cheetah-fast pace. In addition, we also introduced a computational fluid dynamics modeling system so that we could do dynamic modeling and not just static analysis. And the result, compared to last year's sharkbait, this year's canoe is 2.7 times stiffer, experiences 1.5 times less critical shear, and boasts an impressive factor of safety of 8.6. Now this year, you asked for innovation and WECA delivered. We built from the ground up our very own custom-built Java desktop app to do design analysis that we call Paddle. And I'm pleased to present to you today our most impactful module of that software, which automates the generation of bending moment and shear force diagrams. It's based on real geometry and the actual curves of the hull and not an oversimplified beam model. And how do you actually use the software, you might ask? Well, that's simple. In just a couple of button presses, the user can customize where they would like point loads and uniformly distributed loads across the canoe. The program will automatically deal with the self-weight of the canoe and all the integration. One more button press on our floating solver is going to output the exact waterline and trim angle calculated perfectly in seconds. And then one final button press on the bottom there is going to give you those gorgeous graphs that I showed you on the last slide. What's the outcome of all this software? It's a lighter hull, it tracks better, and it gives us a scalable path from proof of concept to mass production.
A complete overhaul of our canoe was made in order to improve our overall efficiency. A male mold with two different critical components. The first is a core inlay that allows us to easily have a reusable mold, and the second is an exterior profile that gives us these beautiful curves that we're able to use. This allows us to easily assemble and disassemble the mold extremely efficiently without damaging the canoe. During construction process, we ultimately decided to use a film finished plywood table along with a 1-inch film finished plywood strip along the exterior of the mold, allowing us to easily govern our 11mm hull thickness. Additionally, we use a 5 and 7mm rolling tables in order to make sure that every single layer is at adequate thickness. Most importantly, with all these pigments flying around, we wanted to make sure there was no smudging. We used tuck tape around the inlays and the gunwales and ribs in order to make sure that no smudging was occurred, and then be able to peel it off during construction and then cast your next layer, making sure it's extremely efficient. With all this hard work, Giraffe had to take a big nap. The nap was with a 45 degrees Celsius at 100% humidity curing time for only 28 days, reducing our current curing time from our previous up to 14 days, reducing our current curing time from our previous 28 days, improving our overall production time and increasing our overall efficiency. After this, Giraffe was easily taken out and sanded from 40 grit up to 200 grit, giving us that beautiful smooth consistency that we all love. Then, a stencil with a critical stain that was used allowed us to give it the final finishing touches. The sealer was sealed in order to make sure it was watertight and moved smoothly through the water. Moving on to the concrete, seed concrete sand was used to lower degradation and allow for the thin layers of Giraffe. Additionally, adding ground glass pozzoline allowed us to reduce the CCM ratio to 28%,
almost 10% lower than what was shown in Shark Bait, proving to be environmentally friendly design. Additionally, Portland Cement Type 3 was implemented to lower the construction time, allowing us to give you a canoe for when you want to win. Finally, the concrete is at its lowest it's ever been in WECA history, standing at 805 kilograms per meter cubed at a compressive strength of 9.8 MPa, suitable for a fast and safe safari trip. And there you have it. Draft is not just a concrete canoe. It's a concrete example of a feasible, innovative, and sustainable project. So if you want to win, join us and let's win together.
Can you be my girl? 2, 3, 4, 5, 6, 7, 8. I wanna know if you'll be my girl. Let's go, baby.
Thank you, Western. Okay, you guys use air entrainment to deal with the colder Manitoba temperatures and the reduce effects of freeze thaw. Do you think this is relevant?
Well, I'll tell you this. Air entrainment was used to lower the concrete's density. In terms of freeze thaw and adhering for those cracks, air entrainment does help. Now, to further answer your question, air entrainment does reduce the compressive strength of your concrete due to the air voids that it creates inside your concrete. Though, with the concrete that we have, 9.8 MPa is suitable for a safe travel and any of your needs to win the competition.
And what was your air content?
The air content was below the 1% that was in the TDS manual that was implemented. Extremely low, though in terms of the concrete itself, in the report, it is 17.1%.
Yeah, so why is that? Where is that coming from?
No, it is 17.1. I'm just saying in the TDS, it is recommended to use less than like 1% of the total mix design, but the 17.1% is the air content in the, yes.
This was also like a little bit inaccurate because we used the standard like air content machine. And obviously with lightweight concrete, you're not accounting for the voids that are coming from your pore and other beads. So we estimate that we probably need to find a more accurate way to measure air content. That's probably been explained to once it's a feasible way to be able to measure it.
Excuse me, how did you measure the air content? Did you use?
Yes, we use an ASTM compliant air content machine in order to test it. Yes.
That's not the way to do it with the lights.
I know. Chat with one of my advisors, and he said there's a rolling method that you could use to be able to do it. But unfortunately, during the stage of the time when we were testing the air content and trying to get it to the right stage, we didn't have access to equipment.
The rule of thumb for air content is 1% of air content, 5% of compressive strength, reducing.
Yes.
So in your case, what would be the compressive strength?
Yeah, I love that question because I'm ready for it. Guess what? Most of us as concrete guys, we know that the strength comes from the aggregates. Though, when you want to make the concrete strong, it's not just about the aggregates. You want to also look at the chemical composition that's being in the concrete. The CSH process. You want to create more strength for your concrete. Now, we added the ground glass pozzolane, which was great in making the concrete more pozzolanic, adding more strength, and reducing the Portland cement. Now, that could raise a question of, okay, well, if you're reducing your Portland cement, how are you gaining more strength? Well, in that case, we also added an accelerator and a strength enhancing admixture called 312 SE that allowed us to get that compressive strength. So in 7 days, we're hitting 7 MPa. In 28 days, we're hitting 9.8 MPa. And that strength comes from the chemical composition of the concrete and the sieved sand that we use with small rock particles that are inside there.
Additionally, the type 3 cement also gave us higher activity in the beginning, which allowed us to make sure that all of our SCMs are able to react.
Yes, as my friend Daniel said, we actually tested this throughout the week. So we did a 1-day test, a 4-day test, a 7-day test, and a 14-day test. And we found that in the 4 days, we got to up to 60% of our strength. And then in the 14 days, we reached the 9.8 MPa.
But you didn't use the HE cement, you used the HEL cement. I think it's very different.
It's the type 3, it's the finer particle cement.
Type 3 with limestone?
Type 3. Type 3.
And limestone inside.
with yes.
HEL.
It's HE.
Not HE, it's HE.
No, it's HE.
Do you know the difference between both?
One is limestone and
Yes.
one is limestone cement and the other one is just the regular Portland cement grind.
Yes.
Low passage of
Yes.
Thank you.
Yes, of course, thank you.
You test 96 different mixes, which is a lot.
Yes.
How do you justify this from environmental perspective?
Yeah, of course. I mean, that's a great question. Well, if you look at it this way, we want to produce a product that will help the future. So to be innovative and to create something that really is going to make an impact, it's not going to take 10 tests. It's not going to take 20 tests. It's going to take time. And that's the amount of time that we put in because we want the future to be better. So yes, the 96 test, it does produce a quite amount of CO2, which is not for the environment as friendly as we would want it to be. But with our product, in the future, you no longer need 96 tests. You no longer need to produce the amount of CO2. You're getting something that's environmentally friendly along the 20, 50, 100 years that we go.
To pretty much justify, we tried to first attempt to go down for cementitious material with a lot of with going down to about 5% roll of cement. That wasn't efficient with the kind of pozzolans that were used. So we ended up getting an adjustment and then we went over to the aggregates. With all these testings, by the time we went down to the cementitious content that we wanted to go with that, we were already at 45 tests. So by the time we tested the aggregates and the new admixtures to be able to accelerate the process, we reached that 96 test threshold. The best thing is that we've already tested out all the admixtures, so that process has already been done and affected. So the next process is probably going to be adjusting the cementitious to try to even go even lower and probably playing around with the aggregates.
So regarding sustainability, I'll just piggyback on that. You know, you heat it up to 39 Celsius where you declared 45 in the presentation. Is there a net gain really? Because you're expending a tremendous amount of energy to heat it and you're gaining 14 days on that, I understand. But did you not analyze how much was that really worth?
Yeah, we analyzed the energy consumption during the 14 day versus 28 day. The amount of water that we saved versus electricity was very much a 1-to-1. So if we just cured for the 28 days and we're using humidifiers, it would be pretty much the same cost as if we cured for the 14 days. And we only cured for 7 days with humidifiers A and B, and the rest was just air.
And if you extrapolate that to 100 canoes, does that make sense for mass production? I understand for this one time maybe, but how about for 100?
The 100 canoes is actually even more efficient because if you push the type, if you go like type 3 limestone cement, you're able to actually reduce. We could probably reduce 14-day down to even like 8, maybe even 7, all in with like only 4-day wet curing because that's all the SCMs really need, and then the rest could just be air cured, taken all out. So it could have even been more optimized to save more money.
You guys mentioned in the presentation there that the stiffness was 2.7 times higher. How is that a selling feature, and why is that something targeting?
Okay, so with our new like paddle model, we had to like make a lot of adjustments and it was a lot more accurate. That being said, when we compared it to our beam model, which our hand calcs before, we were able to get that 2.7 times stiffness with the same model. So we took the same canoe, hand calcs, and we did it with the software, and we were able to get 2.7 times stiffer. Then also we prepared like also the factor of safety point, which kind of discusses like, hey, like how we're able to get that such high factor of safety with the current stiffness. And the main idea is that when we did our lecture and our shear test in the lab, we were able to compare it with the paddle software. When we look at both, the paddle software is about 4 times more accurate, and you're able to actually get the perfect cross sections. So that's why you're able to get a much higher stiffness compared to your hand calcs that are overestimated.
Okay, so the stiffness is not the concrete; it's the hull shape. Is that what you're saying?
It's the hull shape, yes.
And then why is stiffness something that you're targeting here?
We had last year when we had the year before that, when we had the canoe, there was no ribs or gunnels along the whole edge, and it was a very wider curve. So the biggest issue with that is that you get a lot of flex when you have paddles moving in and out, and that would end up causing a long-term durability issue. So you want to kind of eliminate that with increasing the stiffness of the canoe.
I guess you guys mentioned at the end of your structural analysis that you first saw a very high factor of safety. Did that trigger you guys wanting to optimize something? It could be more weight reduction or anything like that?
So when we ended up getting such a high factor of safety, there's a few components that we looked at. The first is the hull thickness, and we tested out with the laying out process.
But the issue is if we went that thin, it was a lot harder to lay it on the vertical surfaces. So that had to be eliminated due to like not having enough time to efficient that. And then we went to the ribs and gun wells and tried to maybe reduce the thickness of those a little bit. But obviously with our CNC machining process, it would be a lot more intricate to go in these corners. And also we have a 1-inch film finish plywood at the edge that gets back to make sure that we get a thickness. So we'd have to make that a lot thinner in order to fit any concrete in the construction process. So we had to sort of just stay with that factor of safety and just justify that compared to our paddle software and our concrete calculator, our concrete testing in the lab, it would be justifiable for this specific year. In the next few years, we're probably going to reduce the lengths a little bit, and that will reduce the factor of safety.
The exterior finish of the canoe has a large labor. Can you speak to that? The art in mass production.
So the current process is used with stencils. So these stencils are flexible. We had two different types. We had like some sort of plastic stencil already made, and from working in the mass producing industry, like you pretty much just lay them out on what your canoe goes into a painting booth. These are already laid on the side, and they just have to spray across, and this already lays out the paint. So from a mass production standpoint, the aesthetic component is not going to be the hardest part to get. It's a matter of like making sure there's no overlap between the sides and the top of the canoe, which is the issue. A lot of the time that I've seen it is they usually wet the surfaces they don't want to be done, and that's something that we also considered and it was done during the process to make sure there's no overlap between the sides of the canoe and the top of the canoe during the staging.
The final question for you, Western. What do you call a group of giraffes?
Oh no. What do you call it?
A tower.
A tower?
Thank you very much.
It's nice touch.
We take it off.
A lot of reasons why people want to reconnect with nature. To escape the hustle, to find peace, to be inspired. To seek new adventures. To push your limits. To feel like you belong to something larger than yourself. But what is it we all really want? That's trace. Introducing a potent, deeply appreciated tree. Smart speed. There are a lot of reasons why people want.
Just like any great camping trip, you need the right gear, solid teamwork, and a clear plan. So, grab your paddles and we'll be your guides down this river of innovation. I'm Lauren, this is Luca and Mohammed, and we're excited to present to you our canoe prototype, S'more Speed. Our team has values rooted in continuous growth and shared learning. We believe everyone should have equal opportunity to work across disciplines, such as operating CNC machinery or refining concrete mixes. This has not only made us stronger as individuals, but a lot more adaptable and cohesive as a team. We built a canoe. We also built a culture of curiosity, collaboration, and well-rounded engineering. Our team followed an agile-inspired project management plan, prioritizing flexibility, adaptability, and, well, collaboration. Comprised of 2 co-captains, 17 leaders, and over 25 members, we allowed for our workflow to progress in parallel, with those tasks being mold and mix design. Using this structure, paired with flexible scheduling, this gave us some leeway in case any unforeseen circumstances came up. We also successfully doubled our budget from last year through increased university support, giving us the financial flexibility to hit all major project milestones.
S'more Speed was designed from scratch with speed, stability, and easy turning in mind. A length of 5.6 meters was chosen for easier transportation, and the width was reduced to 685 millimeters for improved straight line speed. A smooth, squarish hull section offers stability for paddlers without compromising maneuverability. In addition, S'more Speed is nearly symmetrical, which means that paddlers will have no problem moving forward or in reverse if they need to make a quick escape back to the campsite.
We focused our structural analysis on making sure our canoe performs reliably during races. We ran simulations using MATLAB for punching shear, bending moment, and shear forces, ensuring that our canoe has the right stresses that satisfy the concrete strength limits. We also performed a failure envelope analysis to ensure that our canoe does not crack under different combined loading conditions. Finally, we evaluated transportation using analysis for fatigue, vibration, resonance, ensuring that our canoe would remain structurally sound throughout its three-day trip. These analyses gave us the confidence that our canoe is safe and paddle ready. For our mix, we used 21 different mixes to reach a final formula that is strong, lightweight, sustainable, and easier to handle with. Compared to last year, our mix is 15% lighter, which directly improves its paddle performance and handling. We also used expanded glass aggregates, more silica fume and slag cement than last year, and added BMA, which made our mix more sustainable and easier to cast and cure. We also managed to reduce our cementatious ratio material by to 0.19, which enhanced our durability and lowered our emissions. Finally, to reduce our labor and help our fiber distribution, we built our own custom fiber fluffing machine, which for our PVA reinforcement, which increased our tensile strength and helped reduce our cracking. This gave us a smooth, consistent mix, which delivered both in the lab and in the mold.
To cast S'more Speed, we decided to pivot from last year's wood mold to a foam mold this year. We wanted greater precision with less labor, so foam was the clear choice for us. To construct the mold, we used 2-inch thick foam insulation boards, which were accessible at local hardware stores. The boards were precision cut with a CNC machine and stacked together on square alignment tubes. The result is a canoe with a perfect outer hull shape. Thanks to the mostly automated process, the amount of labor was significantly reduced from last year, and the final product is of a much higher quality as well.
With all the mentioned labor and technology, we are able to deliver 100 canoes, Canadian-made, the reasonable price of $38,000 per canoe, and all within, wait for it, 1 year. In short, S'more Speed is more than just a canoe. It's teamwork, innovation, and sustainability, all casted into one hull. So if you're a happy camper, you'll want some more of that speed.
Thank you, Concordia. Welcome back. You said you used different admixtures to help with the mixture sticking to the mold in order to be sort of lacticized with probably others. Was there any way to quantify that? Like how did you end up? Because it seems like it's a qualitative measure, but you do have to make a mix designs. So can you walk me through how you decided how much superplasticizing was required for this?
We used different tests and based off of qualitative or observation of our test results, we reached the right mix that was more adhesive, and that's how we came up with the right amount.
So you were just changing it progressively until you kind of liked what it was doing without measuring it necessarily?
If I might add, we had a test for each mix. We had like a piece of wood with tape on it to kind of simulate our mold. So every type of concrete that we tested, we put the concrete onto this mold just to make sure it didn't slip. Last year we had a lot of problems with like the canoe sliding down our mold. Yeah. So stickiness was like something that we were looking for.
And do you think there would be a way to quantify this?
You could measure how much it slides down, but I think it was really qualitative.
Yeah. Maybe that's something we'd consider.
A big part of your budget goes toward repaying last year's debt. How did that affect technology or material choices?
Sorry?
How did that affect your decision, your material choice, or?
Yeah, so we knew earlier on with the funding that we got from our school that we were going to get more money than last year. So we were confident that we were going to be able to repay some of our debt and pay for the transportation and the mold this year. So I think it was the timing let us have the confidence to be able to make the choices that we made this year.
Also, if I may add, as mentioned in the report, we were able to increase our funding by more than 2 times, so 4 times, in fact, effectively. Because we also relied heavily on the university funding by proving that we're active after many years of being inactive. So they've seen that, they've seen our work, and they've decided to increase our budget. But we've also had sponsors also give us more money, and also from like fundraiser events like Bachata Night, which was also mentioned in the report.
Why did you choose high density foam rather than wood or the material for you?
Yeah, so this year we decided to do it from last year's wood mold. And we had a lot of meetings early on in the summer to decide what mold we were going to use for this year. So the advantages of the high density foam is really precision. Precision was like a huge thing. So last year it was very handmade. Our canoe was crooked in the end, and it takes a lot of skill to make a wood mold work. So we found that with the CNC machine that we had available to us, we were able to cut a very precise mold, and it was easier than we expected. A lot of automation, so the labor was reduced, and we just had a lot of benefits.
In your structural calculation, when calculating the 2-knee punching shear, why did you consider the same surface area as for one knee?
So you're saying that in the report, the 2 knees, it has the same area as the 1 knee?
Yes.
Okay, then that must be an error.
And, regarding the air content, what did you use to measure?
So we used, as you mentioned, it's a rule of thumb for 1% to 5% compressive strength. But we used the ASTM, the standard air test, air content test. We had a really high air content. We recognized that, 25%. But it's an experimental error, probably caused by miscalibration or improper testing. That's something that we're looking to improve on and looking to other ways of testing our air content for next year.
What was the pH of your mix design?
The pH for the mix design, I don't know.
You don't have it. I had a question because in your engineering book, I saw some pictures of people dealing with concrete without gloves.
So yeah, the photos that we used in our engineering notebook are actually photos from the casting day last year. Because of the timing of our casting day and the due date of the report, we weren't able to include photographs from this year. But this year, if you saw our display, we used lots of PPE, we made all the precautions, and we really improved our safety from this year to last year.
That means that last year the minister, the pH were around 7?
Not sure.
I'm sure.
We hope, right? Because otherwise, I hope so.
Thank you.
In your report, you introduced a slight asymmetrical rocker to your people this year. Is there any hydrodynamic analysis driving that decision?
So the test that we did in terms of like hydrodynamic tests was when we were designing prototypes, we had like a water canal in River City. We did tests with small 3D printed models, but really what drove the design of this mold was like the philosophy that more wetted surface could increase drag underwater. So we wanted to improve maneuverability, and we knew that the person who steers in our canoe is near the back of the canoe. So we add a little bit more, the bottom of the canoe is lower inside the water near the stern, create a little bit more drag to help the paddler steer the canoe from the back. So it kind of, we did some tests, but we also used like principles of drag underwater, just yeah.
And was the amount of rocker a bit of a compromise for the forward backwards race?
Yeah, exactly. So we didn't want to make it too extreme. So the difference between the front and the back is only 2 centimeters. It's very small. So we wanted to make sure that it was symmetrical, but we also know that since most of the races are going forward anyways, it might help to have a little bit of asymmetry to help with our turning. Maneuverability was a big consideration.
What drove the selection of having steel rebar here versus ATF or other material considered for that?
We considered the materials like fiberglass rebar, but in the end, it was really just 2 things. It's the availability of the material. It's sometimes a little bit hard to get different kinds of rebar, and also the workability. With the steel rebar, we were able to bend the metal very easily. And what we did was we bent 2 pieces of rebar and just welded them together. So it was very easy to make that work for us.
In the production section of your report, you mentioned that you're essentially dictated the duration of your production is dictated by the curing period. You have a 28-day curing period. The canoe is in the mold for 28 days. Do you have enough strength to strip it earlier and cure it separately? And is that something you could use to maybe accelerate your production, or use less molds?
It's definitely a possibility. We did do our tests on 7-day concrete, and they were quite strong. So it's something that we could consider. But in our report, we did do the 28 days for each of our canoes. So it's something we could look into.
plus I add to that, in production time terms, we are pretty efficient in, as mentioned, so like in 1 year, we are doing.
Your analysis includes vibration behavior in the trailer during transportation. How did you determine that no dangerous resonance would occur?
Yeah, so we calculated what the vibrations of the motor engine, the road, and potholes would be. So we looked at how often the resonance would be for each of those three things, and we found that there was no waves that would be overlapping, and so we saw that there wouldn't be resonance.
How did you measure your own air content and what did you obtain as a value? Air content.
I just mentioned that in the measurement, the ASTM test measurement, which yielded 25% is air content.
Because that's quite high, right?
That is.
Do you think that's accurate?
No, that is not. That is as a cause of miscalibration, as I said, it's improper testing. That's something we want to improve for next year, though. I would say the conventional air content, you correct me on this, is between 4% to 8% from my research. We want to reach to that optimal air content.
Because I'm looking at your compressor strength, right? And, would you expect, so then do you trust your compressor strength measurement?
Yes.
And how many cylinders did you test to obtain these values?
So we used cubes to test our concrete, and I believe for each mix we used 3 cubes.
This comment is for you and other teams. In your references, you didn't put any SCM used to determine the property. So when you say that I use the SCM, there is no record in it.
Yes.
So next time you should put all the SCM including for purpose.
We definitely should. The thing is, we want to fine tune our report as well for next year. It's just with the time restraint that we had, we couldn't have done that. But that's something we want to do.
EFA was on another podcast.
Yes.
Could you just, so looking at it, it seems like you consider Rebecca as space like a space, not necessarily dependent on size. This community honors.
Well, the light case was based off of the female case, and the EFA, the heavy case was based off the male adult case. This was made, our design of the mold the design of the whole canoe was to fit these certain paddlers with different sizes. So we did a decision matrix, and based off the scores in that decision matrix, we reached that these results that would be optimal for that design. And
a question regarding your visual abstract. You say for about 2 millimeter, particle size 3.8 millimeter. For about 0.51 millimeter, particle size 2.7. So I thought that's for about 2 millimeter, it's particle in from 1 to 2 millimeter. When you report particle size 3.8.
We did
2.7.
Yeah, that's odd. We did have some trouble with our receive analysis.
Yeah.
I don't know if it could be
Can you speak loud?
We did have some trouble with our receive analysis. We might have made a mistake there, so I'm not sure.
We did mention that there's an error with the sieve analysis because there's a misunderstanding. We took all the aggregates together and it gave us the overall gradation. And instead of doing it for separate aggregates. And so that may have gave us those errors and result.
Because when they sell the aggregate, they say 1 to 2 millimeter.
Right.
Yeah.
Should have 90% of Someone who wrote 2.8, something like that.
Yes.
Okay, Victoria, good to have you back. Thank you.
For millennia, icebergs and glaciers stood the test of time. Meet Sub-Zero, the University of British Columbia's 2025 concrete canoe, inspired by icebergs, engineered for performance. From concept to casting ability, every inch of our canoe reflects our passion for engineering, our commitment to sustainability, and our drive to win. And yes, it floats.
All right, thank you so much for coming here today. We're so excited to present to you on UBC's concrete canoe, Sub-Zero. As you can see, our project stages follow this general timeline, with iteration to earlier stages an essential part of any design process. We begin with classroom-style learning, and then we transition into design and construction in preparation for casting day. All along the way, we're tracking our progress and deliverables in preparation for CNCCC. And with all our new members this year, we're so excited to present all our new ideas.
Now, moving on to the hull design. For this year's goal, our main goal is to maintain what we had achieved for last year in terms of speed, by also improving the stability for incoming new paddlers. Now, we're achieving this by having a more rounded hull design in the midship and transition to more bladed keel profile up front at the bow and also at the stern. Now, on top of this, the rounded shape is also in goal for us creating something that is a bit more easy to place the concrete on top of. We're reducing the sliding and also reducing the voids. Now, and finally, our main goal is to reduce the capacity of last year's canoe. due to the fact that we do have heavier paddlers, and now we're expecting this by extending the length of the canoe from 5.53 meters last year to 5.7 meters. As previously mentioned, here is the profile of our canoe, having a more rounded profile in midship and more bladed keel profile near bow and stern. Now, on top of this, let's move on to the caper analysis for the resistance. Even though we created a longer canoe, we still maintain a lower or somewhat similar profile in terms of resistance due to the fact our ability to reduce the residual resistance from the hull shape itself, while still maintaining that increased capacity. Now, on top of that, due to the more rounded midship profile, we also create something that is a bit more, that has more riding angle at around 20-degree heel angle, and it drops more gradually than last year's profile, allowing a better confidence when maneuvering the canoe when the position is slightly tilted. Now, after conducting the CFD analysis, we have concluded that our canoe is 5.8% less in terms of sway force, and also 11.72% less when calculating the amount of yaw moment created at 45, 90-degree, and also 135-degree angle.
Moving into the structural analysis, we made sure to account for all the expected load cases this year, and instead of subjecting our model to a single average load, we subdivided the model into 20 individual sections to reduce redundant reinforcement and optimize the structural design process. From our SolidWorks, we were able to pull the essential information, such as the centroid, volume, moment of inertia, and waterline. And from that analysis, we were able to use beam theory to analyze the shear, flexure, and punching shear stresses for all the different load cases, and taking the most extreme values, we were able to create design guidelines shown above. On the right, you'll see a green circle that sits between the center axis of the calculated min and max tensile and compressive forces we found during our design, and as illustrated, Sub-Zero falls within this failure envelope.
This year, our team worked to create a mix that was sustainable and efficient, strong and durable, and most importantly, waterproof. Our continued use of EPS as a recycled aggregate from previous year's B-Mills mold are a sustainable practice and also decreases the density of our mix. We also invested in a stand mixer, replacing our previous hand drills, which increased consistency between mixes and decreased our wait time on casting day. Previously, we had issues with cracking and durability with SSPO. The team identified a direct correlation between the amount of tensile strength and fiber in our mix. We increased the amount of fiber by 233%, which resulted in an increase in tensile strength by 144%. Exceeding this increased the risks of weak spots and clumping of fiber. We also increased the amount of cementitious material and used stronger aggregates such as Udolite, which gave us a 78% increase in compressive strength. This slide goes over our overall final mix of Sub-Zero. As I previously mentioned, our aggregates are Udolite, Forever, and EPS beads. I want to highlight our liquid admixtures of Super P, strength enhancer, and viscosity modifier. Most unique to us, we use Kryton crystal internal membrane, which gives us superior waterproofing properties compared to any stain or seal solution we tried in the past.
To wrap things up for construction innovation this year, we focus on mainly 4 things. The first one being the demolding process itself. Now, we have improved the demolding process to reduce the amount of cracking due to this process. And on top of that, we also improve on the ergonomics of the construction process itself by creating a more elevated work platform to allow us to place better concrete at a less strenuous angle. And on top of that, we also try to cut down the cost of bulkhead manufacturing by using a spray-on foam. And finally, in an attempt to create a better finished product, we had initially casted the gunnel at a slightly lower point with the reinforcement extending up top, where we then trim it and then cap it after the fact. And therefore, it's something that we want to try to improve on for next year.
Thank you. We'll now take questions.
Thank you, UBC. One of your slogans that you finish your video with is "Yes, it floats."
Yeah.
Can you explain why you failed this one?
Yeah, our belief in why we failed the swamp test is a combination of factors. Our mix is incredibly porous, and the 2 coats of sealant failed to fully seal the bulkheads of the canoe. You could easily see air escaping the bow bulkhead when it was submerged in the water, which probably reduced our buoyancy there. In addition, we didn't properly account for the weight of the bulkhead material itself, over top of the bulkhead. which resulted in the valve bulkhead fail.
And to add on to that, the distribution of buoyancy within our two bulkheads, from our bow is a lot smaller and from our stern is a lot wider. So when in our buoyancy calculation, we didn't really account for that. We just calculated an overall volume of bulkhead material needed. We didn't account for the distribution on how that would balance on the canoe. So that's something we could work on in the future.
Yeah, and then can you apply maybe more safety on that? Because you know your density, or you measure it out, so you're putting a very fine line in here, right? Like, you see some things that are very big bulkheads and way more styrofoam than needed, but you're better be on the safe side, I would say, right?
Yep.
Okay, your aesthetic mix is significantly stronger than your structural mix. Why not just use the aesthetic mix?
So our aesthetic mix does not use EPS beads. So the EPS itself is a lighter aggregate. So our structural mix with EPS has a lower density.
But not by much.
Not by much, yes. But we do want to keep on using EPS because we value sustainability. We don't just want to throw away our old EPS female molds. We were talking in the future, so maybe instead of just recycling our EPS as an aggregate, we can utilize it in other aspects. This year, we use it as part of our visual display. So the display you guys saw was actually pieces of last year's female mold. So we could explore options like that. We could even ground up the EPS beads to have it as packing material as we had transport issues with the cracking. So those are alternatives that we can explore and set goals in the future. So at the beginning of the year, if we don't want to use EPS, we can make that decision.
With the use of the EPS, how do you control for application?
So when we use from our full female molds, obviously the outside has been exposed to the elements from transport. We make sure to cut that layer out and only shred the EPS that's been protected from the elements. So that's how we minimize contamination.
And during the shredding process, it is a worry of contaminants possibly coming in because it's a lot of very light aggregate floating around. So this year we constructed kind of a makeshift cone that covered the meat grinder that we used to grind up our EPS to try to contain both the EPS from going into the environment and any contaminants from coming in.
To add on to that, you're projecting mold that can last only 3 uses. What exact failure mode do you limit?
Limits it, actually. Yeah, so that estimate was made based on the damage that's done to the mold during demolding. In previous years, we fully glued the mold together, and that's caused major damage. When we demold, in the last year, we tried a tension wood frame, which was more of a headache than it was worth. So this year, we tried a bit of a compromise. But we find both during the demolding process as the mold rips, but also it's a bit of a lesson foam mold. So as people are kneeling and working on it and placing on it, it slowly deforms over time. So we went with a more conservative 3-use case to ensure that we produce a high quality product. And what could be done?
To extend this for 5+ uses.
To extend the uses, we could certainly add protection to the top of the mold as we're placing to stop the weight of people, deforming the mold as we're placing and moving around it. We could also explore a higher density foam. This bit more resilience.
And to add on top of that as well, with regards to the way we adhere the mold itself to all the molds together, we're currently using a PLA glue. The reason why we're using that for this year is because the lack of time of us trying to manufacture something that has dowel connection points, but it's an option for us to explore in the future. Maybe having a mechanical bond on the inside in terms of doweling the foam pieces together, and then maybe ratchet strapping or having an enclosure outside.
For your structural analysis, you guys say you divided it up into 20 beam sections, I believe. I remember. What drove the decision on the number of sections to split it up into?
At the very beginning, we try to balance qualitatively in terms of like how many analysis points. Then it becomes too strenuous in terms of conducting the analysis, and with the time restriction itself, us trying to have to push the structural portion of the design done sometime, I believe, before mix is completed, because we're trying to set that as our limiting factor towards what the mix should be for the limitation. Therefore, we're trying to balance time and also try to balance the accuracy with the result. But to summarize the answer to that is somewhat arbitrarily with the restriction on time.
do you think that I have blame fairness for 1 cent salmon came from the greening of tanker or calcium carbonate?
We would have to do more research into that.
Sorry, could you repeat the question?
I mean, you say that I have blame for 1 cent salmon. That's make that your hydration is more rapid than usual salmon. So, is that come from the tanker greening or the calcium carbonate?
The exact source of why the finance is higher, I'm unsure. That's simply the manufacturer with good relationship. That's the material with it.
So that generally you use in concept.
Yeah.
You know, the crystal membrane provided by the water.
Yeah, so we actually used this admixture last year, but because we didn't specify in the competition deliverables that it was type S, we got some, it was kind of deducted. So this year we made sure to do our due diligence and contact with the manufacturer to make sure we got that CSTM C494 type S requirement. And how we decided that it was waterproof, we would just, so we had a lot of trial casts to also help our new hull members place concrete on our mix. So once we finalized that, we would we'd make sure that the mix itself contained the KIM, and we'd also have another mix with our old stain and seal, and we directly compare those under tap water just to see if it's permeable or not. And as to why that doesn't really reflect in our overall canoe, so as we previously mentioned, we increased the amount of fibers to try to increase the tensile strength, but there could be some agglomeration and clumping of our fibers, which actually creates voids because the KIM creates a crystal membrane within the concrete structure itself, but it can't cover any cracks, right? So that's something that there's a lot of different aspects on how we can make our concrete more waterproof, but in regards to the crystal structure itself, we're very confident in its stability.
On table 1 in the report, you reported the stress demand, that's the capacity. So the flexurer, sometimes you say you need a kilonewton meter, which is like the moment. Sometimes you report megapascal. Can you explain with that?
Yeah, that sounds like an error in our report in the unit analysis. Sometimes when we prepare documents for CSCE, sometimes the conversions can get messed up or caught up. No, so it's clearly an error.
Just a question about the design philosophy for the bulkheads. See that they're above the gunnels. What was the rationale for that?
Yeah, so when as we previously mentioned, we calculated based on buoyancy and our mix density, the total volume of needed. The last time we used bulkheads was 2 years ago, and we thought that back then the horizontal limiter was actually a little bit longer, and I think they reduced it within the last 2 years to 75 centimeters. So we were limited horizontally, but we also wanted to build up to make sure we had enough volume. So in regards to that, it was just based on our buoyancy and what we needed to achieve.
So you reported the absorption of forever with the lines. Do you know the kinetic of absorption of those aggregates?
We would have to do more research.
My question is, if you are mixing your material, you need to know if all the water you put surplus are going to go into the aggregate or remain in the mix. So I don't think that's a research.
Yeah. The amount of hydration or materials or water that those materials would absorb were for the most part calculated based on our communications with manufacturers and what they expected the materials to absorb. Specific testing of how much water they absorbed was not.
We would have to experiment those ourselves and maybe run based on what our mix Excel water amount gives us and what we're actually using in.
Thank you, UBC.
Salle Gronde, tous les projecteurs sont pointés vers la scène finale de la tournée. Hubert, Alexis et moi-même, Élodie, sommes fiers de représenter l'Université de Sherbrooke. Nous sommes sur scène aujourd'hui pour vous montrer en quoi la tournée du Sherry Tour a permis de créer le meilleur prototype de canoë de béton viable pour la production de masse.
Afin d'offrir un spectacle mémorable, notre équipe a pris soin d'innover et de perfectionner chaque étape du trajet menant au produit fini. Cette année particulièrement, nous sommes fiers d'offrir un produit qui est léger, durable et créatif.
Une tournée d'une telle envergure demande beaucoup de préparation et c'est une gestion de projet exemplaire. Le poste de directeur compétition a fait son grand retour parmi l'équipe exécutive, permettant ainsi une meilleure logistique pour le spectacle de Winnipeg. Ensuite, des rencontres bimensuelles ont permis d'impliquer activement les nouveaux membres et ce, dès le début du projet.
Avant de commencer son travail, Sherry Tour a longuement réfléchi à la conception de la coque. 2 types d'analyses ont été réalisées afin d'évaluer les impacts économiques et environnementaux des diverses solutions possibles. Les résultats ont montré qu'il serait justifié de réutiliser notre moule femelle jusqu'à 10 ans, et ce, sans altérer la qualité du canot. D'ailleurs, en analysant les courses de l'édition 2025, il était préférable d'opter pour une coque symétrique. C'est pourquoi nous avons choisi Sherbrooke Tour avec le même moule femelle quasi symétrique des éditions précédentes.
Une autre étape était primordiale de représentation sur scène, l'analyse structurelle. Premièrement, cette année, nous avons décidé de mettre 4 renforts dans Sherbrooke Tour afin d'assurer une répartition homogène des contraintes dans la coque. Plusieurs options de dimension renfort ont été considérées afin d'optimiser le ratio masse-déformation de la coque. C'est finalement 4 renforts de 32 par 25 mm qui ont été choisis. De plus, pour minimiser encore plus la masse du canoë, nous avons réduit les dimensions des plafonds. Suite à l'analyse structurelle SolidWorks, nous avons aussi pu retirer les bords d'armature de la structure du canoë, celle-ci étant superflue à l'intégrité de la structure.
Cette année, Sherbrooke souhaite obtenir un béton léger et durable. Après 43 tentatives, Sherbrooke Tour est finalement parvenu à une recette à une harmonie parfaite entre ces ingrédients. Le mélange officiel possède une bonne résistance en compression de 10,4 MPa et une densité de 837 kg par mètre cube, soit 11% plus légère que la 5 précédente. D'ailleurs, cette composition a également permis de maintenir nos exigences élevées en matière d'écologie. En effet, nous avons réussi à remplacer 90% de ciment Portland par des ajustements verts. Et ça nous a permis d'économiser environ 29 kg d'émissions de CO2 par le de l'eau.
Le travail en liste maintenant complété, cette équipe s'est mise sur la route pour la tournée du Sherry Tour. Ayant à cœur l'esprit d'équipe bien connu de Sherbrooke, nous avons décidé d'apporter 24 membres à la compétition. Cet objectif peut être réalisé grâce à une somme amassée par l'équipe cette année.
Toujours dans une optique d'efficacité, nous avons construit un nouveau bassin de cure démontable. Cet ajout à l'inventaire de Sherbrooke permet d'optimiser l'inventaire de l'entrepôt, car il permet de monter et de démonter rapidement ce bassin de cure lors des périodes d'utilisation.
En vue de la grande finale, nous avons continué d'innover nos techniques de construction. De nombreux types de gabarits temporaires ont été utilisés pour réaliser les éléments artistiques du camion. Une fois de plus, nous avons utilisé nos moules en caoutchouc pour pouvoir créer des formes précises sur les courbes des parois. Aussi, il y avait des gabarits en bois qui ont été utilisés pour créer des détails minutieux allant jusqu'à 4 mm, tout en créant une séparation claire et nette entre les différentes couleurs. Cette année, de nouveaux moules en polymère ont fait leur apparition en scène, permettant de créer des formes précises dans les courbes. Puis, en cas de nouveau défi, nous avons décidé d'ajouter des détails 3D sur les plabords pour permettre une harmonie parfaite entre la créativité et l'efficacité.
Donc, tous ces éléments ont permis de rehausser le niveau esthétique du canoë, mais ce n'est pas tout. Comme élément ciblé d'amélioration, la décision d'effectuer des recherches supplémentaires pour retirer le paravert de 4 mm du mélange de béton. Le retrait a permis à l'équipe de points blancs de plus grande dimension sur la coque. Cette innovation rend donc les couleurs plus uniformes et éclatantes, étant ainsi Sherbrooke au même niveau que ses compétiteurs.
Nous sommes maintenant prêts pour le spectacle final Sherbrooke Tour et sommes fiers du prototype que nous présentons. Les nombreux détails artistiques et améliorations techniques montrent que notre équipe est toujours en quête d'amélioration constante afin d'atteindre les plus hauts standards de qualité de l'industrie.
Comme dernière vérification technique, nos bagailleurs sont entraînés plus de 75 heures dans les semaines précédant la scène de Winnipeg. Soyez prêts, Sherbrooke vous dévoile un prototype des plus performants, durables et créatifs. Un choix judicieux pour la production de masse de camions de béton. Instruments accordés, moins réchauffés.
Que le spectacle commence!
Merci Sherby. Dans votre analyse structurelle, vous parlez d'un déplacement maximal de la structure lors de la déformation.
Oui.
Comment est-ce que vous avez calculé la déformation ou c'est une hypothèse?
C'est dans le fond, avec les analyses qu'on peut faire sur SolidWorks, des FEA, on a une valeur de microdéformation qui est sortie. Puis en optimisant, là, est-ce que vous parlez des renforts ou de la coque en général? C'est les dimensions de renfort, c'est ça?
Vous parlez carrément, option du choix de renfort,
c'est ça, OK. On a fait itérer chaque incrément de dimension qui est facile à fabriquer pour la largeur et pour l'épaisseur. Puis après ça, on a sorti des valeurs d'information et de contraintes pour chaque 10 renforts. Puis après ça, on a pu sélectionner le meilleur choix, qui était le plus léger, et 2 qui avait la plus petite valeur de déformation qui était sortie dans l'analyse.
Puis, par quel mécanisme la déformation est livrée, mettons, en compétition?
Je ne suis pas sûr de comprendre.
Vous assumez qu'il va y avoir une déformation, mais ça, c'est en coursant, en déplaçant, c'est-tu un effet dynamique?
En gros, c'est au cas de chargement maximal, ça serait une micro-déformation dont on parle peut-être d'un dixième, d'un centième de minute. On a essayé d'optimiser la résistance de notre coque tout en optimisant la masse.
Charge maximale.
Avec la charge maximale.
Et votre cas maximal, c'était lequel?
Avec les 4 pagayeurs.
Non, oui, c'est ça.
Bien sûr. Ouais.
Oui.
Vous avez encore décidé de garder votre moule, expliquer? J'ai comme deux questions par rapport à ça, parce que nécessairement, vous ne prenez pas de risque.
Par rapport à d'autres équipes.
C'est nécessairement le fait de garder votre moule, qui est comme, selon ce que vous dites, correct et même optimisé.
Comment nous, on
peut vous donner des nouveaux points pour des nouvelles idées ou la prise de risque ou vous avez.
On a un peu
la question, ouais.
Mais c'est vrai que la prise de risque, on parle de moule n'est pas là parce qu'on ne la refait pas. On essaie justement, cette année, on a pris des risques, je pense, dans d'autres différentes sphères. Puis, vu qu'on met pas notre énergie là-dessus, mais notre moule, il est encore bon. Il est là, puis ça vaut pas la peine de le changer.
Est-ce qu'il est optimisé?
Est-ce qu'il est optimisé? Pas à 100%, puis on est conscient de ça. Je crois qu'il pourrait toujours être plus optimisé, puis on est juste, on trouve ça acceptable avec le moule qu'on a.
Avec la modélisation actuelle, on aussi, c'est
oui.
À l'avant, à l'arrière. On s'est rendu compte que pour le prix d'un nouveau moule, on n'avait pas une amélioration plus suffisante, mettons, pour la petite partie du prix.
Le pourcentage de différence, on l'a analysé, puis le pourcentage, ça vaut vraiment pas la peine de changer.
Parce qu'effectivement, il y a l'aspect monétaire, l'aspect environnemental, mais il y a aussi l'aspect des courses.
Puis dans les dernières
années, vous n'avez
pas gagné des courses.
Oui, on en a gagné.
Ben, vous avez gagné, mais...
Vous avez déjà, tu sais...
L'année passée, ça a été une année difficile. On avait des nouveaux rameurs. Cette année, on va essayer d'être présent. On va essayer de vous démontrer que justement, le moule, il est encore bon, malgré tout. Il y a 2 ans, on a gagné plusieurs courses. Ça nous a prouvé qu'il était bon. Il y a même 3 ans aussi, on a prouvé qu'il était bon aussi.
OK. Vraiment une question par des l'année passée.
L'année passée, oui, 100%.
Votre snack visuel, vous avez donné des références de ce que vous avez fait, des voix. Une petite question, l'affaissement, vous avez dit que vous avez terminé ça avec la SMC 138.
131.
Oui.
Ben, ASTM 131.
Oui, c'est 31.
Pour l'affaissement, c'est 31.
Pas pour l'affaissement.
Mais ici, vous avez marqué affaissement C138 et puis R C140. Est-ce que vous êtes sûr de ça?
Je ne pourrais pas vous donner exactement le numéro du code pour l'affaissement.
Je l'ai devant moi.
Mais en gros, notre affaissement, elle était inférieure à 25 mm. Donc, ben, elle était ici de 0.
C'est juste le connu.
Il y a peut-être une coquille au-dessus.
Mais non, il n'y a pas les bonnes.
OK. Bon, oui, on a peut-être fait une inscrit. Mais ils ont été respectés
comme supposé.
Comme supposé.
OK. Je vais renchérir sur votre utilisation. On dit que vous avez optimisé en Weller Thompson. Oui. Parce que vous n'avez pas donné, par exemple, basé sur quoi? Est-ce que vous avez plutôt pris le solver sur Excel, vous avez mis les valeurs ou vous savez qu'est-ce que ça représente?
Ben, en fait, on a travaillé, moi avec un professeur de l'Université de Sherbrooke, avec son solver sur Excel. Puis pour la granulométrie, on a mis un facteur de 0,45, ce qui est dans le fond que c'est 45% des particules fines du sol. Puis on est parti avec ça.
Qu'est-ce qui était recommandé par le professeur, justement?
OK. Le modèle de Thompson, normalement, il ne prend pas beaucoup en compte les particules fines. Parce que c'est que utiliser un facteur plus inférieur ou un autre modèle, c'est mieux pour votre cas.
Possiblement. Je crois qu'il y a toujours l'option à aller voir ailleurs pour essayer de trouver des meilleures solutions. Mais nous, c'était quelque chose qui était satisfaisant pour nous.
Donc, moi, je une suggestion, peut-être dans votre référence, vous en avez parlé un peu, ça serait mieux d'écrire un peu. Ça fait quelque chose que c'est quand même la base de votre.
D'expliquer un peu plus le pourquoi.
Que vous comprenez au moins ce que vous faites.
Ouais.
Si vous avez regardé la résistance au retrait, à la carbonatation ou la perméabilité de votre béton, vu que vous avez réduit drastiquement la quantité de ciment.
Je ne peux pas évaluer.
Non.
Non. Puis, vous avez un facteur de
sécurité de 1,25, ce qui est conforme.
mais vous
obtenez un pic de 0,5 LPE en traction.
C'est quoi qui reste?
Ça marche comme un défaut local ou une micro-fissure qui pourrait apparaître dans cette zone-là.
Je pourrais pas vous revenir.
Qu'est-ce que vous avez fait pour confirmer la précision des résultats de votre analyse des éléments finis?
Mais on a utilisé un maillage très fin puis on a répété l'analyse à 3 reprises.
OK. Mais comme pas, vous avez confirmé avec une section
des tests physiques.
Avec les tests physiques.
C'est ça que c'est.
Non, vous avez des tests physiques.
Oui, ça va.
que utiliser le ciment GEF, le ciment GU, c'est plus un choix ou un impératif
C'est peut-être proposé ce choix-là par notre fournisseur de ciment. Il nous a vendu l'idée en nous disant que c'était comme le nouveau ciment plus écologique qui appelait dans le marché et qui était remplacé. Donc, nous avons décidé d'y aller avec celui-là. Nous avons fait nos tests. On n'a pas vraiment de différence entre les deux ciments.
Vous avez construit 10, vous avez décidé de construire 10 bassins de cure pour faire les dessins.
Oui, pour faire les samples.
C'est ça, exact. Mais on s'entend que ça va quand même augmenter considérablement l'espace puis le coût. Parce que c'est cher.
Excusez-moi.
C'est juste un système qui est plus réutilisable, plus modulaire.
100%, mais je pense que le principe des 10 bassins, ça serait justement d'en refaire un autre. Attendez, oui, répétez votre question, s'il vous plaît.
En fait, c'est juste que c'est beaucoup d'îles bassins. Faire 5 à moitié.
Oui.
Donc, je me demande juste, est-ce que vous avez une façon d'optimiser, d'en avoir moins, de quelque chose de plus modulable, quelque chose qui est plus réutilisable?
Oui, 100%, c'est sûr que c'est possible d'en avoir un qui est réutilisable. Juste qu'on est allé avec ce que nous, on avait cette année. On a perdu notre espace d'entrepôt, puis nous, il fallait faire un bassin, justement, qui était démontable en bois pour le ranger dans la section. C'était notre contrainte de cette année. Qu'est-ce qu'on a utilisé, justement, pour la production des 100 canoës? C'est justement le bassin qu'on a actuellement. Qui est qu'on le fait, on le démonte, puis on le fait. C'est plus sûr.
Pourquoi utiliser la chaude en mode?
Dans le fond, la chaux, ça contient de l'oxyde de calcium. Environ, notre chaux possède 50% de l'oxyde de calcium. Puis, pour remplacer l'hydratation du ciment, puis on n'a pas de ciment, on ajoute de l'oxyde de calcium. Ce qui va faire la réaction cristalline qui est là.
Oui. Parce qu'on l'avait pas sinon. C'est ce qui nous permettait d'avoir la réaction.
Mais dans le fond, nous, on a juste voulu trouver un matériau qui avait de l'oxyde de calcium à l'intérieur. Faire de là.
Vous utilisez 7 liants et plusieurs adjuvants dans votre mélange, comme Biscopé, Canton, Inès, Vicstrol. Est-ce que vous avez réalisé des essais de compatibilité croisée pour éviter les interactions négatives entre ces produits?
Pour être très honnête, non. Ça sera un défi pour l'année prochaine. On juge qu'ils sont efficaces parce que les résultats démontrent ça. On a une belle cohésion dans le mélange, dans le mélange, tout ça. Mais par contre, probablement qu'il y a peut-être des petites contraintes chimiques. On va se revoir ça.
Julie, merci pour le spectacle.
Cause it's a heave-ho, hi-ho, coming down the lanes, steaming wheat, barley, and all the other grains. It's the ho, hey, hi, hey, farmer, party, or can you be the town, rocker, rocker, giant, play shore.
C'est a little quiet here.
It's a ho, hey, hi, hey, farmer, party, or can you see the town, rocker, rocker, giant, play shore.
Hello everyone, we are the USAS Concrete Canoe team and we're here to tell you about the Cabin 6 Canoe. I'm Maddie and this is Lily and we are the team captains of the University of Saskatchewan Concrete Canoe team. Established in 2024, the USAS Concrete Canoe team is the newest civil engineering design team at USAS. We're made up of 10 exec members to deal with the design and construction competition aspects of the canoe, as well as 13 additional general members to aid in construction. Since everyone had the same RFP, we were most concerned with the constraints that made us unique from other teams, including our budget, material acquisition, and the transportation dynamic analysis. Everything, all in all, just came down to our inexperience as a team. So for this year, the Canadian National Concrete Canoe Competition theme was to get students to mass produce 100 canoes. And so since we're such a new team, our main goal was really just to have a canoe to bring here, learn as much as we possibly could, and have fun. So as such, we made our theme summer camp because all of our exec members had to be filled with childlike enthusiasm to even get this idea off the ground. So to pay homage to Treaty 6 territory where Saskatoon is situated, we are Cabin 6 and this is our canoe.
With it being our first year, we had a lot of different choices that we could choose for an enhanced focus area. However, in the end, we ended up selecting hydrodynamic analysis to give us insight into what different hull design shapes can give us during the race performances. So we 3D printed 7 different types of mold shapes with various features that have been tweaked slightly. These were placed inside our hydrotech lab in the big channel plumes. And then once we completed that, we weighted them on a weighted matrices, which have buoyancy, stability, constructability, aerodynamics, and material quantity as their features. In the end, we ended up selecting the flat asymmetrical hull, just to really prioritize stability with our inexperience in paddling this year. For our mix design goals, we had 3. The first was to create a well-graded aggregate mix. So we used an aggregate range from 0.1 to 4 millimeters. Kind of associated with that was to establish a baseline based on various industry concrete mixes. This would allow future teams to just tweak small features of the mix rather than starting from scratch every single year. Lastly, we wanted to really toe the line on low density and high strength. So we used Forever, similar to all the rest of you. We also used 2 different admixtures, a strength enhancing and a hydration controlling. And lastly, we used polypropylene microfibers. Wow, what a mouthful, to help with our tensile properties. For our construction design, or for our mold, we wanted to create an accurate and precise mold that we could fit concrete onto the contours of. Additionally, we wanted to make sure that the mold was reusable, both for the mass production and also to ensure sustainability. Lastly, we wanted to make sure that it was a cost-effective mold. So we used plywood and polystyrene foam that you use in like installation flooring. Additionally, we also used wood glue and sheeting tape to keep it together. We utilized a reusable nail mold, which we placed concrete on in 3 layers with 2 layers of mesh in between. Additionally, our molds featured an outer framework, which allowed us to create the ribs and gunnels of the canoe.
We then threw the final canoe design into S-Frame 2022 for a structural analysis, and through some simplifications and weighted averages, we treated the canoe as a simply supported beam with a uniform cross-section, a uniformly distributed load acting down for the weight, and a uniformly distributed load acting upward for the buoyancy. We found that our worst case was the 4-person sprint, so we treated each racer as a point load acting downward, and we found that our maximum shear was near the ends where the racers were sitting at about 750 kilonewtons, and the maximum moment was near the middle at about 850 kilonewton meters, but we found that our concrete strength was enough to accommodate for this. We also did a dynamic analysis in SolidWorks. So we sped up the canoe from 0 to highway speeds to 110 kilometers per hour in 8 seconds, and then decelerated back down to 0 in oscillation to mimic the absolute worst case scenario for transportation. And we found that our canoe was able to withstand cyclic loading, even with all the stress concentrated at those bird areas. We then threw the whole thing into a detailed fee estimate, and we found that one canoe would cost around $85,000. And once we made 100, it would be just under $8 million. You can see that the canoe materials, they actually come from the lowest possible unit that we could purchase. So with mass production, it's just extremely scaled down, since any leftover materials from one canoe can be used to create the next one. The bulk of our cost came from the construction labor itself, but we didn't actually account for our team's efficiency increasing as we got better at constructing the canoes, just because we didn't have a proper metric to calculate this. So we were conservative and just multiplied by 100. Thank you all for listening to our presentation.
Welcome to Saskatchewan.
Thank you.
So yeah, if you're going with the canoe, you get a bit better than that, I'll tell you that. You do have gunnels and ribs in your canoe. You notice that some teams have some don't. What was your process? What was your design for that? Did you calculate the need for that? Did you just do it because you saw your teams had some?
Okay. Our main purpose with the gunnels and the ribs were partially to help with our racers, like to make sure that they had something to kind of like put their little toes on. But additionally, it was also to help with a little bit of those like tensile and like compressive forces. We were really nervous about our concrete mix just being like so heavy, but also crumbly. So we wanted to introduce as many different reinforcing properties as we could without introducing rebar specifically. That's why we went with ribs and gunnels. Additionally, I wish I put a photo of that in here. Our ribs and gunnels also have like small bits of mesh inside to kind of increase those tensile properties as well. So that was the thought process there.
Okay. Do you think that maybe, did you analyze like doing a thicker concrete canoe and replacing it that way through instead of ribs and gunnels, or did you, because it's complicated making ribs and gunnels, right?
Yeah, we did, but it kind of was just, we were a little bit nervous about our weight. Like our canoe's already pretty heavy enough. We didn't really want to keep going with that. So that was our thought process there.
Okay.
Your 100 unit production cost exceed 7.9 million. What's that? Could you realistically reduce the labor or
the labor burden?
I mean, on construction day, we had everyone there the whole time. So that's how we calculated our overall labor. I think if we sectioned it off into different groups doing different things at different times, we would greatly reduce the amount of labor cost. And just over time, we would get more efficient and build the thing faster.
Additionally, obviously being a new team, we had insane research and development costs. And so I'm sure in future years, the costs will go down, especially with this.
said one of the main goals for this year was knowledge transfer. Can you just elaborate on that, what is going to be the key focus for making sure next year's going to be able?
For sure. So I have a little bit of experience running execs like these already. I'm the president of our student team section. So I've already experienced the issue with transferring knowledge. One of the best ways to do this is just to get your general members involved right away. So what we've done is we've created a shadow member position, which directly shadows each of our executives and helps out with smaller tasks either. Sometimes they'll help with more proposal writing. Sometimes they'll help with calculations. Additionally, we plan for next year, especially because we'll have a lot of people graduating on our team. We plan to have our general members, even non-shadow positions, just way more involved. Lastly, we plan to create a transfer document, which will include key knowledge areas to focus on for future members.
After after you read
The past year's reports, what lesson did you learn and what was the most valuable element?
I think the most valuable element was it just seemed like every team, every single year was always trying something new. So I think being very open to change and innovation and all that. But then additionally, I think the biggest thing we learned was how to create budget for this. That was so important. Thank you so much for having so much information about your budgets out there, guys. That was so helpful, especially just starting a new team. You kind of look at this and you're like, okay, we build a concrete canoe. What expenses are there even? So that was the biggest thing, just financials, and then also being open to learning and making sure we have that type of spirit on our team.
I saw some discrepancies on reporting air contents in your Excel sheet, design sheet, and in the abstract. Can you explain why?
Yeah, the visual abstract was completed before the mix design sheets, and I think that was just an oversight. There's also some errors in the cost, which is because we had our proposal finished for March 17th, and then after we created the technical presentation, we got some of our faculty and our sponsors to watch our presentation and ask questions. So we kind of had to adjust some things from there, but we just thought it would be better to have a more accurate numbers in the later documents than the old outdated proposal ones.
You mentioned your transportation load case. You looked at, I guess, deceleration is your worst case. Did you say 8 seconds from 100 to 0?
Yes, that's from the TAC guide. It's the worst case scenario, the fastest that they can accelerate to 110 and then decelerate. So we just chose that 8 seconds.
Okay.
Did you measure or estimate drying shrinkage within the mix as a high porosity and a low cement metrics?
No, we didn't. That was mostly just because we were learning so much other stuff that something like that we didn't even think of until we're sitting here listening to you guys' presentations now.
You tested quite a few 3D printed different hull designs. What drove, how did you start with your initial base and then what drove the first design?
So we were pretty lucky in that we got to partner with the Saskatoon Racing Canoe Club. They gave us a lot of insight into how racing canoes are designed. So we actually didn't really look we based our design not really too much on other teams, but rather on actual racing canoes, and that's where we started. From there, we asked what different we work with this one guy's named Rob Sleeth, and he's a really big national level racing coach. So he's seen as many racing canoes as one could possibly see. So we asked him, what do different features do and what could we tweak to make changes? And he gave us insight into bolt shape and also the asymmetry and such.
With the model, can you assess it?
Unfortunately, no. We completed our hydrodynamic testing before the RFP was released. However, we kind of decided that although technically an asymmetric canoe going backwards will be less aerodynamic, it just offers us so much maneuverability, which is great when you're a new team with people who barely paddled.
In your structure calculation, you use directly the measure the composite strength, making your calculation, which awkward because this value, you're not sure to get this value every time you test your concrete. That's why maybe it's better using a characteristic value, and from that you add some security value, then fix your mix design parameters. So this is maybe the best way to do it. I can give you a reference. You can go and documents in ACI and read and see how you can use values, specific specified values and
Perfect. Mila, did you get that? We'll come talk to you after.
For your mixes, you say you do 15 kilogram batches.
Yes. Yeah. We have a huge concrete mix for food steps.
Can you do it smaller? That's a lot.
Yeah, we could. The issue is purchasing new equipment. Most of the batches that we do in like research testing are the main focus isn't really the initial mix design. It's typically after it's been hardened and what like corrosion looks like on that. So they're typically doing these huge mixes. For us, a big focus of next year will be acquiring our own team's equipment rather than utilizing ours, just because of situations like that. It doesn't really lead well to like quality assurance, obviously doing huge mixes like that for something where you want a precise mix. So
Yeah, and if it's a bad mix, you just wasted 15 kilograms.
exactly, which was definitely not
It's
very
expensive, but it's worth it to get a KitchenAid.
Yeah, but we had a pretty tight budget.
No, I know.
Admittedly.
What are your plans with your current team after the competition?
Well, I gotta talk to the USAS PR lady first to see if she's got any plans for it. But afterwards, we'll probably try and race it, assuming that it floats and it's okay after this competition, just to get new members used to the feeling of racing with this canoe. Additionally, we'd like to just keep it as like a little symbol of pride for USAS.
What drove the scale choice, like the 150 scale for all of your test models?
That was mainly based on our channel flume size. We really wanted to ensure that wall effects weren't in like doing anything to it. And I can't remember off the top of our head the exact width for channel flume, but that width just seemed to avoid those wall effects the best.
Well, welcome and enjoy the races tomorrow.
Makes sense.
Thank you so much.
everybody. We are Windsor Concrete Canoe. I am the co-captain, and this is my co-captain, Nor and Jack. We'd like to present to you the Rock and Run. So this year, we are aiming for a lightweight, budget-friendly, high-quality, and mass-producible concrete canoe. So features of our design to make this possible are a reusable mold and frame, so we can manufacture easily. We have low man hours from our female mold as well as our casting technique, and high early strength. So we can remove our canoe in 5 days to cycle in, so we have a low turnover rate. We have a simplified mix with minimal different types of materials to minimize overhead storage costs, as well as the odds that we have a bad batch come through. So this year, we're stronger. We have a high compressive strength. We have our 28 base strength is 22.5 MPa, as well as we have a very reduced hydraulic cement. We took out 2/3. So now we replaced it with slag and metacomb. From that, we were able to obtain better crack resistance and durability with our mesh and our PVA fibers.
So this year, we wanted to make our design process a lot sleeker. We decided to go with a shallow arch hull cross-section. And to do so, we used a female mold that we CNC'd in-house to save on time and budget. We incorporated smaller ribs that we incorporated them for unexpected scenarios, and they also minimize on weight. We also increased the rocker and decreased the length of the keel to aid in maneuverability while racing. Another huge thing that we wanted to do this year is make our canoes bolder, i.e. focusing on aesthetics. So we really did an in-depth sanding, staining, and inlay process. We also designed and incorporated decals. This year we went for flames to resemble our theme. We also wanted to ensure consistency throughout layers. So we used toothpicks and physically measured the depth of our concrete in each layer to ensure uniformity throughout our hull. And we also redid our stand design to ensure better aesthetics in our display.
This year, we're giving you guys a cost-effective prototype. Our one canoe costs around $2,678. But when looking at mass manufacturing 100 canoes, just the material costs, mix and finishing materials, is around $60,000, and the total cost, which includes labor hours, research, and development, is around $326,000. This year, our canoe is very sustainable. We've used 123 liters of water and 188 kilowatt hours of energy throughout the manufacturing process. There was also 3,500 kilograms of CO2 emitted, mainly throughout the transportation process. We used lab shroud mixes, which contributed to the low amounts of water. We used locally sourced materials, which was either from local companies or faculty donations. We have repurposed previous canoes, so some of them are currently planters in a garden. And finally, we used slag, which is an industrial byproduct, and metacolin, which has lower calcination temperatures. So both of these things essentially lowered our CO2 emissions. Finally, we engineered a canoe that focuses on strength, speed, sustainability, creativity, and manufacturability. I want to thank you all for taking the time to listen to us today, and we are opening questions to the judging panel. Thank you so much.
Thank you, Windsor. How did you model, for the structural analysis, what were your assumptions and how did you model the?
Okay, so typically, like throughout past reports, people took the canoe as a simply supported beam. However, when I tried to do the structural, like the shear moment diagrams, I couldn't really get what people were getting, so I took it as a cantilever beam. So essentially, the canoe is a cantilever beam, and then we have people on it for each load case. So instead of having people on it, I took them as pin connections and then kind of flipped the whole thing over. So your pin connections at the bottom are the people, and the beam is your canoe. So essentially, the reaction forces that we're getting is the weight, and then that's how we got our shear moment diagrams.
So you have one end that's a fixed connection?
No. Pin.
The pin for the paddler?
Yes. So the paddlers themselves say.
But a cantilever has a fixed end, no?
Well.
Or it's just pin floating?
Like two-ended. So
Okay.
it just pins. It's your two ends, got your go in there. So it kind of.
And that generated results that look more consistent.
Yes. Yes.
So how would you explain to yourself that some people, like other teams like the canteen review the analysis, but you're getting?
I don't even know. I tried to do it on my own using Simply Supported, and I got the shear multiple diagrams are kind of like this, whereas what we're supposed to usually typically get are kind of like zigzag up and down. So that's what I got from cantilever.
And your worst case was?
Our worst case was, I believe, 4%.
To add on to this, your bunching shear load is based on a shear diagram value of 13.45 kilonewtons.
We acknowledged that it was a mistake. We forgot to correct it. But we realized that a little too late.
Okay.
Yes.
Good for the unit, but how this value was calculated?
So we took like the punching area of each knee, and then we incorporated that through our shear punching shear calculations. We also used the code book to kind of use what was stated in there for our punching shear calculations, and we did the calc checks. We saw that based on our calculations, it passes. So that's pretty much how we did it.
Okay. Your estimated labor cost is just over $115,000 per canoe, but you have 3,600 hours for finishing. What assumptions were made for this figure, and how can it be reduced for all the canoes?
Well, we based our wages off of technicians, like a lower level technician salary. And when we were working with that, we minimized the number of people. So instead of having like 36 hours displayed over many people, we'd only have 36 hours displayed over maybe 2 people finishing. And then we did the similar process for all the other processes for construction and research.
Table 5, we reported the 28-day shear testing result. I'm curious to know which standard you used to.
With our technicians, we casted cubes and did the shear testing in our lab with the AST. I don't recall the actual standard, but we tested them with the shear cubes.
Shear cubes?
Yep.
I'm not familiar with that, but I'm curious. We'll talk about that.
Okay.
And also, you reported the price of your material in cubic meter.
Yes.
And I know that most manufacturers sell their products in metric tons.
Yes.
How did you manage?
So we had the densities, converted them, and it was much easier in our mixed design sheet to go by cubic meter because we knew our volume, 100 canoes, and we knew the volume of each material. So it was much easier to go that way for our calculation.
Rather cubic meter and
yes. Yes.
ETLA for 7 days.
Yes.
What was the choice to go with 7-day versus?
So as we should have stated earlier, we want early strength, right? So in manufacturing process, we wanted early strength so we could pull our boat out as early as possible, as well as it helps with shrinking cracking. So if we pull the canoe out and can start curing it, it has room to expand and contract. It'll reduce our shrinking crackings.
You guys had calculated an ideal weight that you used for your structural analysis, but then also had a projected weight that was higher than that. Right?
Yes.
Just wondering why you didn't use the projected weight for some of the structural analysis.
So our calculations would perform a theoretical weight because our canoe had not been casted yet by the time we had the structural calculations completed. So we used those, and then we double checked after we submitted the report that everything was good to go.
Right, so you did run again with
Yeah, but we had already submitted our report.
In the EFA, you focused on using a hydrated lime solution for curing.
Yes.
Just wondering how you justify using that when the compressive strengths are like almost all the same, regardless of the curing method.
So if you could see in the one chart, there is a clear site for the hydrated lime. It has the similar alkalinity as concrete, so it's more ideal for curing. It stops It stops the alkaline leach from occurring.
Right. So your graph is clipped at the top of what would be a regularly presented graph.
Yep.
So you're looking at 1% or less difference, which is not a lot.
Yeah.
At all.
Yeah, we were looking just for anything we could get at this point. It's a performance, right? We want to take what we can get.
Right, but if you consider the cost of using this method and maybe some of the risks with a product that has a pH of 12, which is very basic.
Yes.
I don't see the advantage of using that as opposed to just regular wet cure with the results you presented.
Okay.
And just consider that next. If it's not conclusive, don't say that it's conclusive. It's,
okay.
There could be advantages, but I think the test results that you're presenting are it's not definitive.
Okay, thank you.
Jumping on that, then on your graphic, you didn't start at 0. So you start at 15 to solve that difference.
Yeah.
I would like that you put maybe standard deviation of each bar.
Yeah.
And maybe perform an ANOVA analysis and show that those values are really deep.
Okay.
Again, for structural analysis, you say you use a consistent paddler weight of 85 kilograms. Do you apply any dynamic effect on that? Like when you're paddling, you're pushing down, right?
Yeah.
So did you just put 85 or is there any increase?
No, we took 85 as consistently throughout. This was like our worst or heaviest weight. So we just used that as like consistent as possible just to make sure that the maximum weights that we could apply would also pass. Or just to calculate for the maximum weights that could be applied.
Because you understand that there are dynamic effects, right?
Yes.
Like when you're paddling, you are pushing them.
Yes.
You know, some delays in your production.
So our schedule did get pushed back a little bit. Yes, the CNC had people, they were using it. So we pushed that back, but we just worked a lot of hard hours later to make up for the schedule delay. So the sanding was done a lot, with a lot of us through the night, and we made up for it.
You should say that using cementitious materials will help concrete with chemical attacks. Do you expect any chemical attacks these days?
Never be too safe.
Not gonna answer your question. Thank you, Windsor.
Thank you.
Gotta go. Stand the line.
Everything was fine.
You're not even a problem there. Hey, Ryan, if I were you, you're a danger to public safety. Thanks, David. Any last words, Bart? The canoe is fine.
Howdy, and good afternoon. My name is Jason Wade, co-captain, and with me today is Aryan Timsari, mixed design lead, and Emma Glassberg, all design lead. This year, Concrete Canoe at York University traveled to the Wild West to present to you our response to CSCC's bid, Most Wanted. Measuring at 5.5 meters with a concrete density of 1.07 and a total weight of 160 kilograms, it's wanted for a price of $210,000. In our sights today is the hull design, mix design, and construction techniques that we use to build this prototype. And I'll pass it to Emma.
We took a user-friendly approach to our blueprint work this year. One of our focus areas will be hydrodynamics, so creating a more sleek and symmetrical design of the canoe, which is suitable for all races, including the backwards and forwards race. From last year's feedback, we decided to go with a flat bottom canoe with a slight rocker on the end for easy paddling and improved comfort and speed. In order to pass the swamp test, we calculated the total amount of foam required for the bulkheads to achieve an overall density of under 1 gram per centimeter cubed. And for the structural analysis, we considered various load cases, with flexural being the most critical. And I'll head on to Arden.
Thank you, Emma. For the mix design, this year our main focuses were creating a lighter mix that's also more efficient and easy to replicate, so we won't have any problem in the casting. VMA admixtures and well-graded pour-wear distribution were used to ensure that the mix is cohesive, and it has a great workability, so it can stick to the walls of the mold with no problem. For the sustainability aspect of it, we used only 28% cement component for our cementitious material, and we use other cementitious materials that have zero carbon footprint, like silica fume, blast furnace slag, and fly ash. To create a lightweight mix, we took advantage of the pour-over lightweight aggregate and the lighter cementitious materials, such as mentioned before, and we managed to reduce the total density of our mix to be close to water density at only 1.06 gram per centimeter cube. We also cut out all of the unnecessary admixtures and processes, such as pre-wetting of the pour-over aggregate to cut down the mixing time and bring it to about 15 minutes for each batch of. Now I'll pass it back to Jason.
All right. So this year for our construction, we made a pretty big change and went with a new mold in 2 respects. In one way, we did a female mold rather than a male mold. Another, we used wood rather than foam. We chose female because it's easy to cast, to demold, and it provides a smooth finish on the outside of our canoe. We chose wood because it's easy to work with and cost effective, allowing us to make most of the mold in-house. Together, the female and wooden mold creates a durable and reusable mold that, if needed, can be used to make 100 canoes with only 1 reuse, albeit with some repairs. For casting day, we focused on a simplified process that was meticulously planned, allowing for our team, which consisted of novice concrete casters, to finish in only 6 hours. For the construction of the canoe, the ends were foamed to allow for the steep curves to be accurately described. And for the middle section, it was 26 cross sections, according to our 3D drawings, connected with thin veneers. This was separated into 3 sections. When we decast, we did one end and then the other and lifted the canoe. Thank you for listening. Thank you for listening to our bid.
Thank you, and welcome back. Okay, so you use like 3 parameters for getting to your mix design. You have a target of 50 MT for compressive strain, a target of 1.5 P for flexural, and then you wanted 1,100 kilogram for the density per meter cube. Where'd you get those numbers from? And did you try to get all 3? You're trying to juggle 3 things, right? So that's for sure a big task to try to get all of that together. What was your thought process?
Yes, it is. So we were in close contact with the whole design team, and we got those numbers based on the calculations that all design team gave it to us based on all of the loading scenarios that they tested. We used basically the last year's mix. It had a really great results in compressive and the functional strengths, and we changed the forward aggregates that we used last year to try and make it less dense and slightly reducing the other strengths, but still being in the range that it would be safe to use.
And why would you target higher than the density of water? Why wouldn't you aim to have it float by itself?
Because we were also considering the foams in the bulkhead, so it was really difficult for us to bring it to density less than water while maintaining the strengths that we need.
With the 28% Portland cement content, your mix isn't as low carbon as other teams. What's your plan to reduce that ratio in future years?
So my plan, if I would be the mix and zero, even if I'm not, I would recommend bring it down even further and considering other admixtures for like other cementation materials that would still give the early strength that we need to be able to demold it in a reasonable way.
And what's your target?
Target, I would say like 10%, I think.
And you state in your presentation that your mold is assumed to last for 100 canoes, which is quite impressive. Did you test anything to support that claim?
Well, we brought it here in the mold, and it survived. But as far as reusing it, we haven't tested it. But like I said, what we used is the strips we used are quite thin in some parts. And I'm confident that if something were to happen with the mold, which would be the limiting factor, we could easily repair it.
There's scheduled able to very good gaps to provide base here. So I was talking about really big gaps
for sure.
And maybe what is
So I think the reason why that happens is we are a second-year team, and even though we did have a year last year to kind of set a precedent, there was a strike at our university last year, so things weren't normal. So this was the first year where there was labs, there was people using, like, TAs using the labs, and we had to work around that, and finding time and working with our lab technician, we did. So we aimed for those dates before we had kind of set the groundwork of when we were going to be using the lab and all those logistics. So it caused some delays. Yeah.
You guys say you kept the canoe in the mold for the entire curing process. Did you guys have any concerns on getting moisture to the outside of the canoe in the mold?
Yeah, definitely. So we decided to do that because we were concerned about decasting the canoe and the stresses that would cause on it. So we prioritized keeping it in there. I realized that by not decasting it, we could risk getting cracks on the outside, which reduced the strength. However, we also, our mix was quite porous, and we implemented something a bit unorthodox. We left a pool of water in the canoe to let it cure. We were hoping that the water would seep through the other side. It's not. It also should be mentioned that I know you said that we use a large amount of cement, but the other cementatious materials that take longer, hopefully we're still curing after we cast it.
What the type of fly ash do you use? Because in your engineering book, you provide kind of brochures.
I think we use type 1.
Type?
Fly ash type F1.
F1?
Yes.
You have a pretty thick canoe hull with 25 millimeters, but you only use one layer of mesh.
Probably won't smell. Do you think it could have benefit
with 2 layers of mesh?
If so, in what field?
Originally, it was going to end with layers of concrete, but we were concerned about the logistics of placing the mesh in during casting. So we added a little bit more thickness to the concrete in order to ensure that the mesh wasn't sticking out of the concrete because we're having an issue with bending it. So we just made it a little bit thicker, and it would have been more difficult if we would have had to make it quite thick if we wanted 2 layers.
On your estimates, since you had a couple of minutes, what target were you aiming for to determine what was the decibel?
That's a great question. So we used basically 2 main methods. One was the old reliable slump test. We were hoping that the low slump would also mean that it would be easier to place. Like the method we used was placing it by hand and then rolling it. And the other one, yes, we had a test mold that we started testing all of our mixes on to see how it would stick to the walls and how easy it is to work around with. So like one was based on feeling, like how it's going when we're trying to place it, and the other one was just using the smartness.
In your visual abstracts, you provide the value of extra strength. I think the units is wrong. You say it's in kilonewton meter. It's not true. The units, the flexural, provide, you say that it's a kilonewton meter. This is for moments.
Oh, yes. It was at combined flexural strength. Does it say combined?
This is my first question. The unit, maybe it's not true, not right. The second, is this the composites flexural?
Yes, exactly, yeah. So I think there was a mistake there. It was the combined flexural strength.
With a measure.
Yes, exactly, yes. So that was a theoretical value that was calculated just using first principle. And yes, that was the component.
Thank you, Jörg.
Hello, everyone. We are at Carleton University. My name is Dylan. I'm one of the co-captains this year. And this is Nathan, our mix design lead. And this is Kanazoa. Here's what we'll be covering today. Here is our executive team breakdown. And here's our team demographics. We pride ourselves on maintaining a diverse spread of disciplines.
So we have 3 main goals this year, and it was to build upon last year's design. So our first main goal was to, so in previous years, the canoe was difficult this year, mainly due to the hull shape. So to improve on this, we designed a shallow V to increase maneuverability while still allowing tracking. Secondly, last year's canoe also weighed over 550 pounds. So this year we reduced the density of our mix and designed thinner canoe walls, decreasing our weight to 339.2 pounds. We also maintained sufficient strength while increasing weight. And lastly, we aim to innovate through testing and iteration using a female mold as opposed to a male mold, and creating frames to maintain a uniform thickness throughout the. And another goal for us was sustainability, and it was a key consideration throughout the entire design. To reduce waste, we repurposed burlap bags, which were used for both construction and support, and this helped us avoid single-use materials. And we also reused our mold and construction supports from previous years, minimizing material waste and making fabrication more efficient. The molds were used to form the cross-section and for transportation of the canoe. And from the start, the canoe was also designed to be durable and long-lasting, helping reduce the need for replacements and further conserving resources. And at end of life, the canoe is not simply discarded, it can be broken down and used as aggregate in local construction projects, giving it a second life and contributing to circular materials.
So our challenges this year, one of our biggest considerations was project management. This year, our main challenges stems from how we managed our time and our ability to access resources like the new female mold. For example, due to unexpected issues with the mold dimensions and communication with our CNC company, the mold was only completed in March, thus pushing our casting date to April, early April. This caused a snowball effect on the following deliverables being rushed or partially completed. Even with these challenges, we believe we were able to work around our limited time and resources to deliver a fully constructed and structurally sound canoe. Emphasize constructability throughout the design process, ensuring all decisions support efficient fabrication and assembly within project limitations. Transportation was also a large consideration due to the business. To avoid any serious failures during transportation, new considerations were made. A covered trailer was deemed essential as it provided protection from the elements and gave peace of mind. With the use of the female mold, we wanted to be able to reuse parts of it to provide additional support along the trip. Being able to provide these considerations required a considerable amount of our allocated budget to complete the trip safely. Since transportation was foreseen as our biggest challenge, we ensured that all the funds were budgeted around the transportation requirements. Okay, so for lessons learned, working with the new female mold. When casting, we had some issues with slump when the concrete would slide down on the walls during casting, causing increased mass at the bottom and mesh clumping throughout the bottom of the canoe and inconsistent mesh layer and depth. A solution to this in the future would be to phase layers and increasing casting time frame. Including time for curing between the layers could allow for strength between layers and less slump buildup at the bottom. Next year, we will look at returning to using a male mold and use what we learned from the female mold to help keep our weight down that we achieved this year. For hull strength, due to demolding and transportation stresses on the canoe, some fractures had developed. To increase the hull strength, different length fibers to increase tensile strength could help to avoid these failures. Longer fibers would help to avoid any wider cracks. So for curing, we noticed while watering the female mold, it was difficult for the gunwales to retain moisture with water pooling at the bottom, causing the finished canoe to chip and fracture more easily and increase saturation on the floor. In future attempts, research into more efficient curing methods shall be adopted. So additional lessons learned. For aesthetics, this year we tried staining a design on the inside of the canoe. Unfortunately, it did not come out as expected. So to improve this year, next year, we will complete stain testing on concrete samples to achieve our desired results and increase sanding for next year.
Thank you. How many mixes did you perform?
I prepared 3 different versions.
So that's quite little compared to many other teams. Is this just the lack of time, or like did you find a mix that was sufficient after 3 only?
Just lack of time and resources. We didn't get materials until later on in one of the semesters, until the first semester, and then we also just didn't have enough time as well to try versions.
Okay, and did you selected mix 3 after all, or which one did you select?
Mix 3 to final mix.
Okay, and did you pre-plan the mixes? Or did you adjust every time after the next one? You had a game plan for the 7?
We would do one mix and then adjust based on that one. So our first mix was based off of last year's mix.
And you tested it after how many days?
We tested the first 2 like after 28 days, but then we doing the last mix after I believe 14 days.
And I mean, because that's very long, right? Waiting 28 days to get a result. You could probably test it after how many days, you think?
Probably like 7, 14.
Yeah, because if you're waiting a month between your tests, that's what did you do in between those times? You just calculated stuff. You know what I mean? Right? Yeah. So quite often it's a better.
Why did you start training for the races so late?
Sorry.
Why did you start training for your races so late?
Due to communication errors with our CNC company, because we newly started with the female mold, we wanted to get a good mold. They had some difficulties understanding our requirements for it. So we ended up getting it at the end of March. We picked it up end of March, and then we did our cast beginning of April.
No, I'm not talking about that. About the races, training for the races.
Paddlers. Oh, paddlers. Yeah.
Because usually teams starting in the tournament.
I mean, we're still kind of working on our race development. We're still a small team. We still have a hard time getting people to show up and getting big numbers. So that's probably I think to look forward to for next year.
Your factor of safety is close to 1. It's roughly 0.9. Do you consider this acceptable, or did you add any additional reinforcement?
I would maybe I wouldn't consider it acceptable because it's obviously like isn't like a typical like complete mix, but I would for safety. But for reinforcements, sorry, what was that?
I mean, yeah, exactly.
Yeah.
Do you add anything to cope with that?
Well, we added fibers afterwards for the last minute.
Yeah, well, I think our biggest consideration was just decreasing weight. So we're still learning, so we wanted to do that, and now we see that there's some structural problems with that. So now next year we're going to take that and then also add some.
What was your main driving factor for changing to a female mode this year?
Just to try something new. I mean, it's only our year, but the first 2 years we did do normal. And also with our weight problem, we want to see if maybe that could make a difference, which it turned out it did.
And then hull design, is that also just a kind of based on historic canoes, or was there any analysis done?
Yeah, so last year we had a keel, and that proved very difficult in turning, especially with the weight. So this year we wanted to add a flatter bottom, so it's easier to turn for our racers.
But was there any like fluid analysis done on the design?
It was mostly based off previous years.
Go and having members show up with what are the actions for next year to try to set.
Yeah, I mean, just going more events, creating more events, making more, I guess, a bigger group at Carleton, but it's still very small compared to other ones. So trying to make it seem like more of an experience to join our team as opposed to others, maybe, and just make it a bigger name for us.
In your visual abstracts, you provide composite strength at 14 and 28 days. The value at 28 days, was it an extrapolated value?
Sorry.
So 28 days composite strength.
Yeah, that was extrapolated.
Extrapolated.
Yeah.
Then find out that value being the same.
We didn't check the 28 days and do insurance.
You extrapolated based on which relationship?
Just the relationship between like for example, in general, like 7 days, after 7 days coverage is like 65%.
How many, sorry?
So 7. After 7 days, like it'd be like 60. It'd be at 65%. It's strength, and then 14 days would be like 90, and then after 28 days it'd be around 99%. It's yeah, that's much.
Well, for me, those two values are quite similar.
Yeah.
And see how you report values which are similar at different dates. I think the idea behind providing composite strength at different dates is to understand the behavior of it.
Yeah.
Maybe you should have considered other dates, 2 days, 3 days.
Yeah, that will be something to consider.
What measures did you take to manage shrinkage and prevent cracking?
We used mixtures for that, so to prevent shrinking, especially like early age, like cracking. We used an admixture, Secret Control 75.
it wasn't with our new mold and our practices trying to drop weight. It wasn't necessarily like at the top of our list, and that's something super important.
Talk about creep in your IFA. How creep will affect on a male mode more than female mode? Can you explain a bit?
Sorry, like the difference?
Yes.
Oh, so for this year, I think it was more difficult in casting for the female mold with the slump and trying to build up the walls, and then our last minute decision to add fiber to strengthen that. So there's different considerations, but I think next year we're going to go back to the male mold and use parts of what we learned this year, and then try and decrease our weight and achieve better strength.
Asking a question because creep, most of the time, you must have creep for long-term period, very long-term period. Right. I don't know if that's really applied in this case, specific case. Légalement.
The question about the design of your bulkheads, just compared to some of the other teams we've seen, most of them have the bulkheads flush with the gunnels. Did you do any, or I guess, is there a rationale for that design that you guys chose?
Based on our density, we realized we didn't need a lot, but we also want to consider that there might be a change from our calculations to the actual canoe.
Okay.
So we used broken up pieces from last year's canoe, place those inside, just what we thought would feel right. And did a big sum.
So it's pieces of concrete in the bulkhead?
Pieces of foam from last year.
Gotcha.
That's right.
Okay. Which dictates kind of the shape.
Yeah. And the heights.
Yeah. Okay.
There you go.
Thank you.
Pretty nice. For me, it was the best. Each criteria. Actually, that's
Hello everyone, we are Alexis, Julien, and Henri, and on behalf of the ETS Concrete Canoe team, we are thrilled to present the SCC, a prototype which reflects our team's legacy and the desire for innovative approaches created over the past 3 decades. This fulfillment is embodied by a tree of life whose roots grow ever deeper to keep its branches flourishing. In response to the community's call to identify the premier design for potential manufacturing and display at the World of Concrete Expo 2025, the ETS team offers a new construction process using a creative mold design, a resource-efficient build, and a narrow, high-performance hull, which culminates into the final prototype, Florence.
To provide the means for the client to manufacture an efficient prototype, ETS committed to a strict production schedule where designers and technicians collaborated closely to bring innovations to life. By choosing to use a large-scale 3D printer, the machining of a new modular premium mold enables the FCC to streamline its production while offering a scalable solution to easily transition to a higher production volume. Florence's mold not only offers 100% reusability, but can also be easily adapted by substituting the mold modules for future mold design, making it a practical and forward-thinking solution. In 2025, adhesive wax mold were reintroduced to create intricate inlays, allowing for precise and detailed designs on the hole's outer surface. By using 5 mm thick cutout wax pieces, the placement team ensured that the thickness aligned seamlessly with the first layer of concrete, achieving a smooth and consistent result. This approach not only enhances the design's complexity, but also contributes to the overall precision and quality of the prototype. Switching to a female mold brought new challenges that would turn into opportunities for precision. By leveraging 3-axis CNC machining, we achieved a seamless integration of extrusion with the secondary concrete layer. This prototype was brought to life in a newly redesigned workshop, optimized for every step of the production process. By strategically placing the concrete lab, we enhanced communication, improved material quality, and strengthened communication between our teams. This new, more efficient prototype, optimized for every step of the production, was brought to life.
For the second consecutive year, a full life cycle analysis was carried out to measure the carbon emissions released by the project. By sourcing materials locally, reducing cement content, and most importantly, switching to an HDPE plastic mold instead of the traditional foam one, we remarkably reduced our long-term environmental impact. Finally, the team developed a cutting-edge, lightweight, and aerodynamic design optimized for peak racing performance. The hull's thickness has been optimized to target the prototype's critical areas, and a concrete reinforcement layer has been added to the bottom of the canoe to increase its puncture resistance. Additionally, the hull's profile has been narrowed to decrease drag, and when paired with the concrete low weight, allows for much greater speed. The second phase of the design process focused on the concrete mix, which is developed to ensure excellent casting behavior, as well as minimizing the amount of sanding required to guarantee an optimal finish. To achieve this, the formulation favors fine particle sizes and precise dosage of admixtures to improve the concrete's workability and adhesion. These choices not only reduces the amount of sanding required, but also ensures compliance with essential performance criteria such as mechanical resistance and innate aesthetics. Every element of Florence were intentionally crafted, from custom pigments to intricately designed inlays, allowing for a more cohesive and visually striking result.
With the design finalized, structural reinforcements were integrated to ensure durability under high-intensity conditions. Steel rods and thwarts help maintain shape integrity, while a fiberglass mesh placed between the 2 concrete layers enhances tensile strength. Additional fiberglass rods placed along the gunnels reduce flex and prevent cracking, and when paired with a compressive strength of 15 megapascals, these features deliver a resilient and race-ready prototype, built for peak performance. Florence reflects 30 years of accumulated knowledge, craftsmanship, and engineering growth. Every aspect, from material selection to the design process, was guided by experience and a commitment to performance. The result is an uncompromising product built with precision, optimized for racing, and designed for manufacturability. Florence stands as a confident step forward, ready to carry our team's legacy into the future. Thank you.
Thank you, Andreas. English or French? OK, votre air content qui est votre air content qui est proche de 28%. Vous avez utilisé un air trainer, puis vous déclarez que ça crée des bulles stables, contrôlées, qui enhance le overall workability and comparative strength. On a posé une question similaire à une autre équipe. Donc, tu sais, des bulles d'air, ça augmente le compressive strength, ou ce que vous dites enhance. Est-ce que vous pouvez commenter là-dessus?
Donc, la valeur de 27 pour commencer, la valeur de 27 est calculée théoriquement dans les feuilles de design. Selon nous, on pense que ce n'est pas réalistement la vraie valeur. En fonction dans le fond, il y a des pourcentages d'absorption du polymère. On pense que ce n'est pas exactement les vraies valeurs qui absorbent pendant la curve. Donc, cette valeur-là, on n'est pas certain qu'elle est réelle, mais elle est calculée selon les calculs théoriques. Donc, pour déterminer la vraie valeur d'air, il faudrait utiliser une méthode ASTM qui fonctionne pour notre mélange. Au niveau de la maniabilité, en faisant les tests, on a essayé de retirer l'entraîneur d'air. On s'est rendu compte que le mélange était beaucoup trop sec. Donc, en ajoutant l'entraîneur, ça aidait à placer. Et le réseau de bulles d'air aussi était plus uniforme dans les mélanges qu'il y avait d'entraîneur.
Parce que vous dites que le gain, c'est juste... Il est minime le gain sur la densité. C'est que vous utilisez la densité, mais c'est slightly reduced density. De ce que je comprends, ça vient aider un peu avec le workability, mais sur d'autres produits, vous utilisez l'entraîneur comme je ne sais pas en direct.
Oui, on peut le dire comme ça. Surtout avec la fibre qu'on rajoute dans notre mélange. C'est vraiment en mettant la fibre, l'entraîneur d'air, que cette année, notre mélange fonctionnait très bien de même, comme ça. Là, on n'a pas eu de problème au niveau de la résistance. Là. Notre valeur de résistance était bien en haut des valeurs. Est-ce que ça répond à la question?
Ouais. Comment expliquez-vous un gain si faible dans votre résultat de compression à 14 versus 28 jours? Vous avez 0,7 MPa de gain.
Oui. C'est les... je vais vous répéter la question.
Pourquoi c'est si peu?
Je crois... En fait, c'est les vraies valeurs. C'est des valeurs qui ont été réalisées sur plusieurs cylindres. Selon moi, la cure est déjà arrivée à ce moment-là. Mais pour vrai, au niveau de cette raison-là, je n'ai pas plus d'informations.
Vous avez choisi d'éliminer le laitier dans votre mix parce que vous dites, puis je vais citer, en fait, c'est une traduction libre, une augmentation de la densité sans gain notable de résistance.
Oui.
Mais normalement, le laitier, il y a une densité généralement moins élevée que le ciment. Peux-tu élaborer là-dessus?
Oui, absolument. C'est vrai qu'il y a une densité moins élevée que le ciment, mais il y avait une densité plus élevée que tous les autres ajouts cimentaires qu'on a mis dans notre mélange. Donc, c'est cet angle-là qu'on voulait l'expliquer. Puis aussi, le laitier a été retiré pour laisser la place au métacarolin qui a pris la grande partie de notre focus cette année-là au niveau du mélange.
Puis, pourquoi vous n'avez pas essayé justement de le combiner pour moduler la densité puis améliorer, mettons, la durabilité?
On l'a essayé en mélange, mais ça n'a pas donné des résultats concluants. Donc, on a décidé de mettre tous nos efforts dans adapter le métacarolin comme il faut au mélange. Puis aussi, on avait 4 ajouts cimentaires. Pour le peu de temps qu'on avait pour développer, c'est mieux pour nous, pour nos objectifs, de mettre le plus d'énergie possible dans des trucs qu'on peut optimiser facilement et efficacement qu'en mettant trop d'ajouts cimentaires. Voilà.
Pour votre mix design, à la page 9, vous avez dit, vous avez m'excuser pour l'accent, largement votre aluminum oxide present to metagalin causes the rapid formation of calcium aluminates. Right. This reaction is exacerbated when you reduce the cement content. Je suis pas très d'accord avec cette assertion. Parce que quand on réduit le ciment normalement, on a moins de choses, oui. On a moins de lime.
Oui, c'est une...
Donc on peut pas former. C'est pas vrai.
Oui, ça c'est une erreur de notre part. C'était le contraire.
C'était le contraire.
Oui.
Dans les plats bois, vous avez utilisé, pour tenir votre renforcement, vous avez utilisé des clips. C'est ça?
Oui.
Vous avez marqué que c'est soluble. Comment s'assurer que ça ne va pas se dissoudre dans le béton?
En fait, on a pu le remarquer directement au démoulage que ça a vraiment créé des trous parfaits lorsque ça dissolvait par la fluide humide. Donc, ce qu'on a fait dans notre étape un peu de réparation, c'est de rajouter du béton comme ajout d'extra, en fait, pour vraiment venir combler ces trous-là. Mais il n'y avait aucun plastique vraiment qui paraissait vraiment lorsqu'on vient de canne.
Mais pourquoi utiliser quelque chose de solide pour commencer?
C'est sûr, en fait, en utilisant la tige de pipe de verre, ça nous permet d'être flexible lorsqu'on la place directement dans le canot. Ça ne peut jamais être parfait. Fait qu'on a utilisé des clips vraiment pour la tenir en place au centre de nos plates-barres. Fait qu'on a décidé d'utiliser quelque chose qui allait être dans le béton et dissolvable.
Le but d'utiliser des clips qui sont solubles dans l'eau, c'est pour rapidifier le processus de construction. Puis aussi, ça permet qu'on n'ait pas un élément à enlever du canot après. Dans le fond, la clip tient la route de clip de verre. Puis si on enlève le plat-barre, là, il y a une clip dans le mélange, ça pourrait créer des problèmes plus tard en créant des fissures au retrait, etc. Donc, si elles font par l'eau d'humidité ambiante, mais il n'y a aucune contrainte physique à ce niveau-là, donc ça a un avantage au niveau de la construction du canot.
OK, mais ça serait-tu mélangé dans le béton à ce point-là?
On a, dans le fond, pour répondre à cette question-là, l'année passée, on avait utilisé ce plastique-là pour créer toutes les formes à l'extérieur d'un canot. Là, on l'a utilisé en plus petite quantité pour ça. Et au niveau aussi, au niveau de l'eau, si ça peut se dissoudre dans l'eau du canot. Selon nous, non, parce qu'il reste plus. Notre béton, il est très sec. Donc, on ne pense pas que l'eau du béton là, va attaquer ça.
Vous avez fait
26 mix de.
mais
je ne suis plus sûr de ma note, là. Je ne sais pas combien la quantité.
26 mix, ça fait 2,8 litres par mélange.
C'est ça. Ouais. Sans fait, de béton perdu.
C'est même. Vous avez fait en canot complet, là. Comment vous justifiez?
En fait, c'est. En fait, les 26 mix nous ont permis vraiment de développer le béton qu'on voulait atteindre. C'est vrai que c'est un béton, c'est un canot, presque un canot complet jeté, mais on peut le voir d'une autre façon. Si on veut, dans un scénario qu'on veut construire une centaine de canaux, c'est mieux, ou une grande quantité de canaux, c'est mieux d'avoir un mélange qui est optimal au début et de ne pas devoir en refaire au fur et à mesure, d'autres tests au fur et à mesure. Donc, oui, c'est un canot de perdu au début, mais dans le but d'en faire des centaines, je crois que c'est quand même réfléchi comme nombre. C'est raisonnable pour nous.
Dans votre livre de l'ingénieur, vous avez donné un TDS du ciment blanc, en fait, le Federal White, qui date de 2023.
Oui.
Vous avez dit que vous avez utilisé un ciment GU qui correspond à la norme ISTM 750. D'après les informations que j'ai, le Federal White, c'est beaucoup plus ciment GU depuis plus d'une année.
Non,
enfin, GUL, en fait.
Oui. Tu veux voir la question?
Oh, oui, allez-y.
Oui. Oui, c'est vrai, en effet. Puis cette année, dans le fond, c'est tout simplement que notre fournisseur de ciment avait encore un stock de ce ciment-là. Donc, quand on est allé le chercher, c'était exactement le même ciment. Donc, c'est pour ça que c'est la même fiche technique de 2023. C'est le même exactement ciment qu'on utilisait. Mais oui, on est au courant que cette année, Federal Light utilise et qu'on font du GUL. Et l'année prochaine, notre objectif, c'est justement transitionner vers un ciment qui est justement GUL ou plus vers que le GU normal.
Et donc, le stock, vous l'avez gardé au moins pendant une année?
Ça, on ne peut pas vérifier ça malheureusement, donc je ne peux pas dire de grosses informations. Mais peut-être que la production était. Je ne sais pas exactement la date qu'ils ont terminé, donc il faudrait avoir plus d'informations au niveau de ça.
Par rapport à dans votre IFA, vous avez fait une bonne analyse pour votre safety factor. J'apprécie ça. Il y avait 3 paramètres que vous avez testés. Est-ce que les chiffres que vous avez eus de ces tests-là c'est quelque chose que vous pouvez réutiliser ou est-ce qu'il faut répéter le test chaque année? Mais est-ce que c'est de la valeur ou est-ce que c'est quelque chose qu'il faudrait refaire chaque fois?
Dans le fond, ce qu'on a fait dans l'IFA, c'est simplement mesurer la variabilité de nos pratiques de coulée. Dans le fond, comment est-ce que la densité, la puissance en compression va varier à travers le mix. C'est difficile à dire si on peut réutiliser cette même variabilité-là d'aller en année. Surtout si nos méthodes peut-être vont s'améliorer, peut-être que la variabilité va descendre, les quantités vont changer. C'est sûr que la méthode pour laquelle, là, c'est sûr que cette année, c'est une phase d'apprentissage. On a appris les mathématiques derrière, comment faire les tests, tout ça. Mais c'est sûr que si on souhaiterait le refaire l'année prochaine pour recréer des nouveaux safety factors qui sont plus en lien avec notre projet, ça serait un processus qui serait plus efficace. Puis je pense que ce serait même pertinent de le faire, surtout que ça serait plus rapide la deuxième fois, puis on sait qu'est-ce qu'on fait.
Bon, Mercedes, belle nostalgie.
Okay, so hi everyone. We are Team Jelly Bean with Modern Concrete Canoe. So for anyone that doesn't know, that is in Newfoundland. So before we start, we'll just introduce our team leads.
Hello everyone, I'm Raz Ahmed. I'm a co-captain of Modern Concrete Canoe.
I'm Aylin. I'm the other co-captain.
I'm Alex Earl. I'm the concrete design lead, and Sufikar is our host.
So, our company, we have a diversity of expertise. We have both civil and ocean naval architecture engineering knowledge that we bring to the design process, and this gives us a unique perspective on the design techniques. In terms of our location, we are on the Atlantic Ocean, so we're the most easterly point in Canada, so we're able to ship, if we do a large-scale production, we're able to ship to both Europe and across North America.
For our product, Meet the Jelly Bean. This is the 2025 state-of-the-art concrete canoe all the way from the most eastern point of North America. So the Jelly Bean was designed and inspired by the Jelly Bean row houses in St. John's, and we are bright, bold, and built to race. And we are here from the road to the races. And for our product, our canoe overall length is 6 meters. It is to optimize its performance, and our hull design thickness is 12 millimeter. It's engineered for strength and durability, and the overall weight of the canoe is approximately 135 kilograms. Next, for the hull design, it was a very important part of our hull design to select the hull type. So we have here 3 different hull types, and we did analysis of. We compare all of them, and our criteria was to compare the stability, speed, and performance. And after all the evaluation, we ended up selecting the round bottom hull, which was a complete good balance of speed and stability. Another enhancement we did this year was to introduce the gunnels and rib in our hull design, which really helped us. The reason we introduced the gunnels and hull design was to increase the structural stability and overall stiffness of the canoe.
Now, speaking about our concrete mix design, our team performed several mix design iterations before coming up with our final product. We used 4-over lightweight aggregate as our primary aggregate source to keep a lightweight and floatable canoe while maintaining our concrete strength. We finished with a measured density of 1138 kilograms per meter cubed. We used Portland and slag cement as our primary cementitious material and used an even distribution of graded 4-over aggregates, which we soaked before our final test mixtures. We also used 4 admixtures for performance. We wanted to maintain good workability and content while we were placing on our male mold, as well as avoid any shrinkage, cracking, or damage during transportation. And finally, we used alkali-resistant glass fibers to avoid any cracking or clumping, which is an issue we had with some of our PVA fibers early on. This final mix design helped us attain results that we were happy with. We ended up with 17 MPa nearly compressive strength at 14 days, along with 2.5 MPa tensile strength and 5 MPa flexural strength, as you can see here. To maintain this quality on the actual body of our canoe, our team constructed a custom wooden curing chamber from scratch to keep the optimal concrete quality and keep our maximum potential strength for our actual race day.
Now, in terms of logistics, for the budget, if we were to do a mass-produced product for what we designed, we found that the labor cost would be the largest expense, and that would mainly be laborers and technicians during the construction phase. Our second biggest expense would be the materials. However, we had a few local partnerships with companies in our area, which helped reduce the construction costs of that. Those included donations of styrofoam, the Portland cement powder, and various admixtures. So overall, the unit cost to construct the jelly bean would be a little over $6,000. And for transportation, that's something that we prioritize. Being based out of a remote community, or remote in terms of location with the rest of Canada, that's something we had to implement a buffer period in our project schedule. And this ensured a timely delivery of our product. So we were able to get it, as an example, we were able to get it even early to So thank you for listening.
Okay, let me see one instance here you mentioned for the design, where you have in the construction portion, you say the canoe is designed to withstand impact loads during races. Can you walk me through that? Because in the structural design portion, I didn't see where you had that. How much percentage did you allow for impact?
This is our reference slide. So we did the structural analysis, and these are the like stress points, and we use this analysis to position our ribs to distribute the force, and it's also account for punching here. That's why we have like each paddler would be sitting between two ribs to divide the load. So based on that, based on this analysis, we design our concrete based on this.
But how much impact load do you, like, by what factor do you increase? I'm guessing you're saying impact load is the dynamic effect of the paddler?
Right, for the waves, yeah.
On the waves, yeah.
Goes off the top of our head, thinking about the number. We don't have our designer here with us at competition, so I apologize for that. But, yeah, we use like a finite analysis to account for dynamic loads and stresses.
Yeah, so make sure you declare things like that, like put the graph or something so it's self-explanatory, because it's.
Right.
Yeah. We'll do that next year. Thank you.
Can you please explain me in your FEA you talk about the yield stress of your material? I thought that concrete was a brittle material. How did you determine the yield stress of concrete?
The yield stress, we mentioned the flexural stress and tensile strength and compressive strength. So what do you mean by that?
I'm asking you, what's the yield stress of concrete? You mentioned yield stress in your EFA.
Yeah.
Yes, but I don't know how to determine the yield stress of concrete. Would you use as tool?
Yeah, again, I believe that was the whole.
Okay, let me put in context. I did rheology 3, so some field have reached yield stress.
Right.
I'm asking myself how concrete has yield stress. Metal, yes. If you take a metal, it has yield stress.
I think that.
So I don't understand with concrete. Can you please explain to me?
That would likely be a type of.
Yes.
Perhaps it's speaking.
You're right, yeah, we couldn't have a yield stress for concrete since it's a brittle material. We definitely have that for the fiber store. For the fiber or any iron or anything. We'll correct that for next year.
Your cross-sectional analysis assumes a uniform semicircle.
Yes.
Did you consider any stress concentration at ribs, bulkhead, bow, where geometry deviates from this assumption?
So what we did is we used a semicircle considered as a single beam, and then we applied the load, and we placed the ribs on the most concentrated stress points. That's what we did, and we didn't actually separately analyze the ribs or ribs individually. We did it integrated into the full canoes.
Okay. How many test mixes did you report in your audit?
We did 4 prior to casting. The fourth one we tested on a miniature model as well. It was pretty similar to what we used for casting. I believe the only change were slight tweaks with different aggregates, and we changed the fibers for the casting to glass fibers. But aside from so it was generally 4 mixes, and once we reached the 4, we were happy with our test results.
If you had time to, would it be done more, and what would you focus on?
Yeah, I would have liked to probably have done more. We doing roughly 1 month leading up, and then we had a slate break once we started classes before we casting. I think it would probably be to just keep trying to get the density down. I think that would be something we could continue to work on for next year. We have a pretty good baseline to continue now with start the next competition. So I think that would be.
You chose to go with 2-layer concrete that has different thicknesses, so one 4 millimeter, 1 9 millimeter. Chose to expand on that choice, and then again, another team in terms of context and mass reduction. slow as we can, why to go fast versus?
I'll take that. Yeah, that is an excellent question. So what we did is we consider is we use first layer since we use the nail mode. We apply the 9 mm layer, and then we apply. Then we place our reinforcement since we consider it as a beam. So if you consider the canoe as a beam like this, so when it spans, so the bottom part is under tension. That's why we place our reinforcement right near the bottom, 3 mm, 4 mm actually near the from the bottom. So that was the rationale behind it. So we did like 2 layers because first layer was concrete, second layer was our mesh. That's why we have another layer of concrete on top of that. And to add on that, to avoid the roll joint, we use the retarder to increase the set time of the concrete. And we also use the cold water to bring down the initial set of the concrete.
You have in your hull design that you mentioned that based on your estimates, you'll have a very low freeboard, around 11 centimeters. Do you guys do any particular like extra training or something to try and mitigate tipping a little bit, so getting some water in? Or what was the plan to kind of manage, or what's the confidence level with that low freeboard?
Yeah, that was a tough choice because this is having only like 11 centimeter of freeboard. That's why we have like we use the maximum size of bulkhead to have like more like to achieve the maximum freeboard, I would say. And then the choice that we use to have the less, so we have like lighter concrete. That was like overall goal to reduce the like depth of the concrete from last year.
And just to touch on that, you do have bulkheads, right?
Yeah, we do have.
Okay. They're not shown on your drawings anywhere, or mentioned in the report at all.
Yeah, but there's pictures. Yeah, we don't worry about that. We don't have
So was it added after the fact? Because your density is, I mean, like heavier than water, right? So was it added after the fact?
Yeah. So what we did is we use, since I told like we use mail mode. So during the demolding process, what we did is we left the bulkhead and we cut out all the like the rest of the styrofoam. We took it out and we made it we used like maximum bulkhead length, and then we encased it in the concrete.
Yeah, the ADVA 600 is a super plasticide. ADVA 600, it's a super plasticide.
Yeah, that is the high volume using the super plasticide.
In your page 10 in the report, you mentioned that it's the ADVA 600 gave you the opportunity to increase the water content and cement ratio ultimately improve the compressive strength. So you meant the opposite.
I think, yeah, because it's definitely, we use like super plasticizer to increase the water content and vice versa, like it will definitely increase our compressive strength.
That's what you mentioned.
That's type again. So sorry about like 2 times. Yeah, we'll definitely improve that next year.
Thank you, Memorial.
Okay.
Yes, come to me.
Êtes-vous fatigué des canaux gris et dépassés? Oui! Eh bien, nous aussi. Découvrez notre modèle durable, ultra performant et au design qui fait rêver. Vous pouvez oublier le passé et faire place au futur. Vous pouvez dire adieu à la concurrence car on a ce qu'il vous faut. Dans notre domaine, il est connu que les connaissances du passé sont essentielles pour bâtir le futur. Et c'est en s'inspirant de cette philosophie que nous avons conçu Canosaurus, un tout nouveau prototype de canot qui fusionne les techniques traditionnelles avec l'innovation moderne. À première vue, Canosaurus attire l'attention par son thème unique inspiré des dinosaures, mais ce qui le rend réellement exceptionnel, c'est sa capacité à allier performance, esthétique et durabilité. Derrière ce design original se cache un travail approfondi en recherche et développement où des matériaux de qualité et des procédés novateurs ont été mis à l'épreuve afin de vous offrir un produit solide et élégant. Ce projet est aussi le fruit d'un effort collectif soutenu par une éthique de travail rigoureuse et d'une passion commune pour l'excellence. Il est aussi le résultat de 21 ans d'engagement continu. Depuis 2004, Polytechnique Montréal est une présence constante sur la scène des compétitions, accumulant expérience, expertise et reconnaissance. Et c'est avec une détermination inébranlable que notre équipe a su gravir le classement pour atteindre la 4e place de la compétition canadienne de 2024, une véritable preuve de notre résilience et de notre esprit d'équipe. En plus de notre résilience, notre équipe est aussi connue pour sa capacité à construire des produits extrêmement durables, comme par exemple notre canot Sobeil qui est encore en utilisation 10 ans après sa construction.
On vous propose un produit haut de gamme, autant en termes de durabilité que d'esthétisme, permettant de personnaliser 3 sections distinctes de votre famille. La forme des clavards est ajustée grâce à une impression 3D et les gravures internes sont préparées minutieusement dans le moule grâce à un outil rotatif. Les calculs de résistance sont effectués en tenant compte des 2 premières couches de béton de 5 mm. On est donc en mesure d'en ajouter une 3e qui nous permet de personnaliser l'extérieur de la coque avec des designs faits entièrement de béton extrêmement malléable, de couleurs soigneusement choisies. Cette année, nous avons réussi à réduire la quantité de ciment Portland de 17%, et tout en maintenant une résistance du béton de 7,1 MPa. Cette année, l'équipe a décidé d'investir dans les compétences de ses membres en faisant l'acquisition d'une nouvelle machine CNC à fil chaud à axe rotatif. Le nouveau processus de production a permis d'améliorer globalement la précision et la rapidité de la découpe initiale du moule. Particulièrement, l'automatisation de la découpe a permis de réduire de 40% le temps de production des pointes et d'éliminer complètement les tables de sortage. Notre regard est toujours posé sur l'avenir. C'est pourquoi l'avenue du développement d'un moule réutilisable a été explorée pour poursuivre notre processus d'innovation en continu. Notre objectif est de réduire la quantité de matériaux et de main-d'œuvre utilisés pour la production du moule. Le moule en 5 sections imaginées permet un démoulage aisé et rapide grâce aux aimants qui maintiennent les éléments ensemble et évidemment ce qui fait de notre canot un produit d'exception, sa qualité artistique personnalisable et maintenue en utilisant des plaques gravées interchangeables. L'optimisation de la conception de Canosaurus est basée sur une collaboration étroite avec nos pagayeurs.
Grâce à notre collaboration, la coque de Canosaurus a été largement optimisée avec les apprentissages tirés des modèles précédents. Avec une largeur réduite de 10% sur l'ensemble du profil, la hauteur métacentrique transversale diminue de 6,8%. Également, à cause de le nombre d'entrées a également diminué de 13,7%. Ce qui a fait en sorte que la distance qu'on a gagné de l'hydrodynamisme aussi et la vitesse de l'accélération sur de 8,5%. La chose qui est vraiment importante pour notre canot, c'est vraiment la marque de signature qui est vraiment l'esthétique et aussi ce qui va vraiment bénéficier sur votre compagnie si vous décidez de travailler avec nous. Puisque nous, on est vraiment capable d'avoir un moule qui est capable de facilement interchanger les différents modèles et aussi les différents dessins qu'on est capable d'aller sur le canot. Canosaurus est la solution pour avoir un canot à votre image et à votre signature. Pour conclure, Canosaurus est la fusion parfaite entre l'historique du passé, l'innovation tournée vers l'avenir, un canot intemporel fait pour aujourd'hui et pour demain. Merci beaucoup.
C'est pas en français, j'imagine. Peux-tu retourner à la 8e diapositive sur la graphique? Ouais. Ce n'est pas que je vois une mention de vitesse. Donc, nous, dans le rapport aussi, on a une chose ici qui dit donc, vous videz une vitesse pour votre design. Et ensuite, vous associez une dimension de résistance avec ça. C'est quoi exactement le raisonnement avec la vitesse et le pourcentage de résistance?
Grosso modo, pour moi, la vitesse et la résistance, c'est vraiment le contact, un peu la résistance de l'eau avec le contact du canot. Pour nous, la coque, c'est vraiment quelque chose qui va permettre d'être plus fluide dans l'eau, ça va beaucoup plus aérodynamique. Je n'ai pas réussi à dire ça en implantation parce que j'ai vu un temps de mais grosso modo, c'est vraiment plus que ce qui arrive là.
Puis cette vitesse visée-là, tu l'as mesurée, c'est comment vous arrivez à. C'est une performance moyenne, c'est quoi le.
Absolument, on y va plus avec le feedback, plus pour le feeling en tant que tel. Au début d'année, avec notre responsable de conception, on a fait un sondage généralisé avec tous nos pagayeurs pour s'assurer de voir c'est quoi leur feeling pendant qu'ils pagaient, c'est quoi qu'ils aimaient plus sur le canot, qu'est-ce qu'ils aimaient moins, puis qu'est-ce qui est vraiment ressorti. Ils trouvaient que notre ancien canot, qui était Calypso, qui était vraiment plus stable, mais qui était un petit peu moins rapide. Alors, on a décidé de travailler un petit peu sur la vitesse, justement, en diminuant un petit peu plus la stabilité.
Parce que pour moi, la vitesse, c'est plus, tu sais, quand on dit, tu as que c'est la forme de la coque ou la vitesse, c'est directement proportionnel à la résistance? Oui, les autres paramètres, je veux dire, quand même, il y a la friction, il y a la finition, il y a la forme du coque.
D'accord qu'on a vraiment simplifié un peu plus pour la résistance et la vitesse. C'est vraiment plus une approche qu'on a été avec un petit peu plus intuitive. Mais je suis d'accord que rajouter plus de paramètres là-dessus peut nous aider à avoir une meilleure idée sur la conception.
Vous avez diminué votre ratio ciment-CM à 25%. Comment vous assurez que la prise initiale est suffisante pour éviter que votre démoulage soit fragile prématurément?
Alors, pour la division du 100.9, juste pour savoir que ça soit plus en maniabilité, je pense qu'on a plus été avec. Je ne suis pas 100% sûr, je ne vais pas vous dire n'importe quoi, juste parce que le VP Conception, VP Béton n'est pas en avant ici pour poser une question, alors j'aimerais mieux juste pas vous dire exactement pourquoi.
OK, on va d'ailleurs. Vous avez un coût pour acheter
pour 100 canaux qui est vraiment très élevé. Je pense que vous êtes même les plus chers à autour de 10 millions.
Est-ce que vous avez évalué
une approche qui est plus industrialisée pour diminuer ces coûts-là? Si oui.
Grosso modo, je pense que nous, le plus gros problème avec notre méthode plus de conception, c'est pour le prix plutôt, ça serait vraiment plus une certaine main-d'œuvre, puis surtout pour comparer à cette année. Cette année, on a vraiment eu beaucoup de nouvelles personnes qui sont beaucoup moins expérimentées. Fait que ça a nécessairement rajouté plus de temps sur la création du canot. c'est sûr que si on fait vraiment quelque chose de vraiment plus standardisé sur, mettons, la manufacturier sans canot, c'est sûr qu'on serait capable d'optimiser mettons, ce montant-là. Mais par contre, c'est vraiment en ce moment juste un problème au début, quand on a fait la conception, on était avec ces chiffres-là, qui n'est pas nécessairement, mettons, le personnel qui est le plus optimisé pour l'instant pour la création de 5 ans.
Sur les 21% d'air que vous avez, pensez que c'est quelle proportion se trouve dans la pâte, c'est-à-dire dans l'eau plus toute magnétique.
Je dirais sûrement plus.
Vous avez reporté une valeur de 21%.
Oui.
Donc moi, je me demandais, sur ces 21%, ça ferait combien qui serait dans la pâte, en fait. Quand je parle de pâte, c'est de l'eau, un solvant, matériaux cimentaires, sinon.
Je dirais sûrement une grande partie, je ne peux pas vous donner une proportion.
Approximativement.
Je dirais. En vrai, je ne vais pas vous dire un chiffre parce que j'ai l'impression que c'est quelque chose.
Ça rapport. Parce que je vous demande la question, parce que en total, vous avez 30% de pâte, donc 300 litres. Donc si je calcule, 21% d'air, c'est 210 litres. Si tout se trouve dans la pâte, il vous reste 90 litres au fait. Donc vous ne pouvez pas avoir des résistances que vous avez. Donc ce que je suggérerais, peut-être ça serait de déterminer quelle partie est dans la pâte et quelle partie est dans le convecteur. Certains qui en ont dans le convecteur. Ça serait quelque chose que vous pourrez innover, par exemple, l'année prochaine.
Je suis d'accord. On va travailler là-dessus. Dans votre analyse structurelle, vous avez regardé pour un genou, 85 kg. Est-ce que vous avez considéré les forces ajoutées comme pendant que quelqu'un pagaille? Oui, ça, on a fait une analyse sur tous les cas de masculin, féminin, masculin pour le transport, sportif.
Tu pousses là-dessus le facteur de sécurité de 1,21 en traction. C'est ce que vous avez déterminé. Est-ce que vous considérez que c'est suffisant dans le cas qu'une charge dynamique accidentelle pour arriver?
Je pense que relativement pour les normes de la compétition, je pense que ça vaut la peine. Je pense que force de même, ça peut être un peu plus, ça peut arriver, mais je pense que le 1,21, c'est assez suffisant pour les termes de la compétition.
Okay. Votre densité théorique est présentée comme, je vois ici 1270, et puis votre densité chauffée est à peu près 300 kg par mètre cube de moins. As-tu une explication pourquoi ça serait tant que ça, la différence?
Je voulais savoir c'est quoi les paramètres d'entrée des équations de la CSA pour déterminer le moment de fission. Le plus important, vous allez déterminer le moment de fission.
C'est pas ça. Pas sa réponse là-dessus pour
je regarde votre. Dans les contraintes, vous avez mentionné que la grève de Post Canada avait entraîné des retards de livraison. Écoute, vous êtes la seule équipe qui l'a mentionné, là, toutes les autres équipes aussi viennent du Canada. Donc, à quel point ça vous a affecté, puis c'est quoi votre plan B, comment vous avez.
Ben pour nous, c'était absolument on avait un échéancier qui était prévu comme si la compétition ça s'est déroulée un petit peu plus tôt, comme d'habitude, mettons le 8-9 mai. Donc, on avait quand même un assez grand jeu là-dessus. Notre enjeu avec le Canada, c'était vraiment les pigments. On avait un problème avec la livraison des pigments pour le béton et on a décidé en équipe de retarder la coulée d'environ une semaine pour être sûr d'avoir les bonnes couleurs, le bon rendement sur l'esthétique de celui-ci, puisque vraiment employer c'est une spécialité, puis on ne voulait pas faire un compromis là-dedans. Alors, puisqu'on avait déjà vraiment un assez grand jeu, c'était pour ça que
si vous ne l'aviez pas reçu après une semaine, mettons, y avait-il une limite Puis après, il y avait un plan B ou c'était vraiment, on attendait?
Le plan B, c'était juste de diluer peut-être un peu plus la couleur, mais puisqu'on assaisonnait à peu près une semaine et demie, 2 semaines, un gros maximum. Puis si, mettons, ça n'avait pas fonctionné, on aurait avec le plan B qui était un rendu un petit peu moins coloré, mais pour nous, c'est vraiment important de prendre la chance qu'elle arrive.
Vous n'avez pas mentionné que vous avez fait appel à un chercheur externe pour votre recherche et développement, c'est le cas?
Cette année, on a vraiment un petit problème avec. On a eu un transfert de professeurs à Polytechnique pour ceux qui s'occupent de notre. Du canon en tant que tel. Pendant l'année, il fallait qu'on cherche avec un nouveau professeur qui allait nous être attitré avec ça. Alors, malheureusement, on n'a pas eu d'échange de feedback directement de lui. Fait que c'est un peu plus. On avait pas eu de.
Qu'est-ce que tu n'en avais pas?
OK.
Dans le dernier commentaire, dans votre cahier d'ingénierie, vous avez dit que Master Matrix IMA, c'est un super classifiant, mais je pense que c'est un seul. Est-ce que c'est un agent modificateur de ça?
Oui, c'est juste un website.
On a quelque chose de plus léger. Qu'est-ce que vous voulez améliorer pour l'an prochain?
L'année prochaine, on a eu une couple de contraintes qui a fait que notre canon n'a pas eu, mettons, un résultat excentré. Comme une des affaires qu'on a eues, c'était notre géogris. Notre géogris est vraiment quelque chose qui est relativement stiff, qui est quand même dur à placer. L'année prochaine, on a réussi à faire ça. On voudrait vraiment implémenter le concept du moule réutilisable, parce que pour nous, c'est vraiment quelque chose de vraiment très pertinent. Puis c'est quelque chose qui va être éco-friendly, puis c'est vraiment quelque chose qui va pouvoir nous supporter à la moule. Pour un peu ressembler, avoir les avantages du moule femelle, mais aussi avoir les avantages du moule mâle, parce qu'on veut vraiment pas perdre tout ce qui était notre esthétique. Donc nous, c'est vraiment ça qu'on va améliorer pour l'année prochaine. Merci.
I know I was fixing the computer and then like being started, so.
It wasn't working at all. You had to switch the computer.
Yeah, it stopped working. It wouldn't connect, and then the.
You're invited. Right, wait. Oh dear, we shall be late. Welcome to the magazine party. The University of Waterloo presents Her Majesty.
Good afternoon, judges and fellow teams. The University of Waterloo is proud to present Her Majesty. My name is Zach, and alongside my colleagues Sophia and Keelan, we'll be presenting why Her Majesty should be selected as a successful design proponent.
Her Majesty is a 5.75 meter long sprint style canoe. It has 2 layers of concrete making up a total of 10 millimeters long, 10 millimeters in hull thickness, with 1 layer of fiber reinforced mesh. It is also 77.5 kilograms, coming at a light and maneuverable weight. Additionally, the total cost for mass manufacturing of 100 canoes comes into a total cost of $780,000. So the dry density of this year's mix is 945 kilograms per meter cubed. The compressive strength 28 days is 13.8 MPa and a tensile strength of 1.7 MPa. Our tensile strength represents 12% of that of our compressive, marking an improvement in our tensile to compressive strength ratio, as well as an improvement overall, meeting the goals of our tensile strength for this year. Additionally, we made an increase in our dosage of Delvo. This helped with our quality control overall. This admixture helps with our consistency as well as predictability throughout the mix, improving also our workability, making this a great addition to the mass manufacturing of 100 canoes.
Environmental sustainability was a major area of improvement for our team this year. Her Majesty boasts a 36% reduction in total emissions. This was achieved through halving the hull thickness, utilizing a wooden form, and reducing the amount of Portland cement in the mix, all of which reduced our environmental footprint. The team implemented a new approach this season by selecting a wooden female form as a foundation of our design. The wooden form lowered material costs and required less CNC machining, cutting labor expenses as well. Less reliance on CNC availability, simplified scheduling, and gave the team more control over the final product timeline. The wooden form's reusability also provided massive reductions in the emissions for 100 canoes. With the switch to a female form, the production of interior design details, such as gunnels, proved to be a novel design challenge. A design was formulated where guides produced from waste foam from previous canoes were suspended from wooden braces running across the width of the form. This design succeeded in being strong enough to withstand concrete placement and consolidation, while being precise to the shape of the hull and quick to install during casting.
Our thematic 4-color design was achieved through simultaneously cast inlays. The simultaneous casting reduced the risk of construction joints, but allowed for a single cure, which helped us maintain our optimal schedule. The inlay process followed the creation of stencils that were cut and reassembled against our canoe form. We placed the concrete up to the stencil, then it was removed, exposing a new area for concrete to be placed in the next color. Additionally, we notified our mix team 10 minutes in advance of the next color being needed, so we had the correct color at the correct time. We utilized pull planning to achieve the optimal schedule, as well as identifying key performance indicators that established milestones and several critical path streams over the course of the project. These milestones created a granular breakdown of activities, all pulling in the same direction to achieve that optimal schedule. Pull planning was also used to help with our micro-sequencing and micro-phasing of the project, and followed our can, do, check, adjust process to further enhance the quality and the quality of our overall deliverables. This methodology will be used in mass manufacturing to help us ensure our quality and optimal schedule. We also utilize the last planner system as it generates and improves workflows and sort of simulates conversations between all of our sub-teams in order to identify potential issues and resolve them before that issue would actually occur. Some benefits of using Last Planner were the increased communication, collaboration, and respect between team members, the elimination of waste time and material through rehearsal of construction techniques and project execution, the improved workflow through careful planning and discussion,
the continuous improvement through equal contribution from every single sub-team. Budget was verified through every design iteration and potential value add item. And we had overall higher quality as we had improvements with each canoe that we created or cross-section, as well as optimization. So this will have a higher quality and overall better manufacturing process. Waterloo Concrete Canoe can deliver the superior concrete canoe due to our proven design and workflows. Thank you very much.
Thank you, Waterloo. Okay, in the design section, you mentioned that you used thicker fibers this year. However, you have a thinner canoe. Any issues there? How would you mitigate this potential, I don't want to say contradiction, but you could make it work.
So our main thing was making sure that our fibers were sort of running as longitudinal as we can. We were trying to avoid having them stick up. So even in our thinner layers, we were hand placing the first layer. So we were able to sort of not have everything go completely crazy and sticking out. The bigger issue we had was the inside layer. But because we rolled our tiles and then also sort of compressed them with our hand, we were able to sort of get them to lay flatter than if it was just a loose placement.
Did you have like a lot of clumping or things like that, or it went very smoothly?
If anything, I think our clumping was reduced because of the large fibers, that the clumping would be not as big or like not as small, and it would be bigger portions of anything with compared to smaller microfibers.
So you only use one type of fiber, right?
Yes.
Did you consider making maybe a mix of a thicker one and a smaller one, or you really wanted to just keep it?
We considered that, but because we experienced a lot of clumping with microfibers, we thought, and we saw a great improvement in tensile strength with the macrofibers, we thought to stick with the larger ones as a better option.
And how do you mix it exactly?
It is tossed in similarly to the microfibers. There isn't really any big differences.
We have a rotating drum mixer, so we have some challenges with that, with getting small fibers dispersed, just with the nature of our mixer. So.
Regarding your structural analysis, you narrowly passed sponge and shear safety.
I mean, it was 0.001 MPa difference.
Yeah.
How
confident are you that your construction variability won't reduce this margin?
So our initial layer thickness of concrete is actually 9 millimeters. So we reduced that for punching shear to 8 so that we could be more conservative if there was any variability. But our actual canoe is thicker than what we did in our punch and shear analysis. So we're not concerned in that respect. So we took that as more of the factor of safety, as well as our paddler weights. We used the heaviest 2 paddlers for all of the cases and didn't have any issues there.
In your construction, your outer layer is only 1 millimeter over the mesh after sanding.
Yes.
How did you control that? Because you initially casted 3 millimeters, sanded down to 1. Like, how did you control that while sanding to avoid or getting that accurate?
We mostly targeted in sanding the areas that were most raised. Since we used the female form and the exterior finish was quite smooth to begin with, we also felt very confident in our thickness control during casting for the first layer in particular. So the majority of the sanding and the majority of the external inconsistencies were in the interior of the canoe. So
with addressing that everything was consistent on the outside to 1 millimeter, everything was done with extremely long passes so that everything stayed consistent. And then areas that had a bit of variation from form seams, those were dressed more heavily to make sure that they followed the consistency of the rest of the canoe. Since we have done sort of these forms and similar sanding before, it's sort of to judge in practice like how long it took sort of to get to another stage.
How do you explain the difference between your mixes for 28 days retention strength among the 3 mix design? That's not appearing on the compression and construction. We don't see the difference.
So for what we did this year is essentially the only thing that changed between our mixes was the pigment dosage. And it was slightly unclear to us in the rules, like whether that would classify as being different mixes or not. So we were decided to play it safe and consider them as different mixes. We also know that sometimes pigments with their own makeup can react slightly differently with the concrete. So that's really the only difference. If there's different metals or things in them, that's what we sort of experienced, was just difference in pigment and how much pigment we had to add to achieve the desired.
And just to add on to that, in general, we didn't see any large changes to our string, both compressive and tensile. After adding the pigments, we had a couple mixes when we got the pigments and had them arrive, so that's why we didn't differentiate there.
And for your structure calculation, you use the split tensile strength.
Yeah.
You know that the split tensile is very different from the tensile strength.
Yes.
It can be maybe 80%. The tensile is 80%, roughly.
Yeah.
Did you consider that in your calculation?
Initially, no, but we still think there's enough of a safety factor with all the other calculations that it shouldn't be too much of an issue for us.
You managed to reach 13 MPa compressive strength and 1,000-ish
Density with the
0.2 C or CM ratio.
but
You track long-term shrinkage or moisture loss due to high carbon content because you have up to 28%.
So we weren't concerned about shrinkage through the fact that we used a female form. In our past experience, it's actually shrunk away from the form, and we haven't seen significant cracking compared to when we did a male style of form. So that wasn't something that was a big concern for us. We didn't worry about it so much.
In general, we were actually able to have a humidity chamber earlier on during our test casting, as well as the general curing of our canoe after we were done during casting day. So I'm sure in that sense, it's not a concern.
You utilize the last practices of how many Facebooks did you put?
So we had basically for all of our casting, like each individual segment, so our design, test mix, casting, those all had like a pull coming back from them. So those each had sessions, and we would go back and review that because we met every 2 weeks as an entire team, but then the individual sub-teams would have their own discussion of how much dates to pull back to that. So I would say there was at least sort of 8 that were solidly defined for different activities on the schedule as a whole, but there was a lot of like weekly planning or bi-weekly sort of smaller pulls of sort of the tiny, if that answers your question.
We held like 8 separate Facebooks.
So we had sessions to set to schedule a preliminary schedule was probably 2, but we went back and revisited to make sure that everything was on track and what could potentially be optimized if something had been running.
What was your average?
I'd say 80 to 90% of activities did meet their deliverables. The only thing that we struggled with was getting our marketing teaser trailer and then a delay in shipping of the pigment.
It's like construction matching for first stripes. Not sure if you have a copy of it. But for what were the, say, top 3 risks?
So our first risk was actually switching to a wooden form because it was a completely new technology for us. So when we built our cross section, we had a slightly different methodology that we used. And our biggest concern or risk with that was achieving the tip of the canoe because that was a very hard shape to bend out of wood. So we ended up mitigating that by switching to a CNC foam end piece specifically. The next one I would say would be the inlay casting because that was another new thing for us this year. So we held 4 or so practice sessions of how to actually do the inlays, testing different materials. So we ended up finding material that matched the thickness of our actual first cast layer. So we could also use that as a quality thickness gauge to make sure that we weren't having inconsistencies due to those joints. And then the sort of final risk I would say is we had to switch our casting location with about 2 weeks notice. So we went through and did full site visits, asked them, checked temperature, the temperature was staying stable, could still set up our original tent system and had sensors that were monitoring at all times. So those would be the 3 largest risks that we had to our project this year.
You say that you cast your specimen following the CSCE 31, which is making and curing some of the film. Is there any reason why you do that? What are the usual ones?
Because the space we're usually given to cast doesn't meet as much lab conditions, and there's variability in where we do our casting locations, and this we don't have control over those environments, so we do it in field because it's the sort of best option for us with the spaces we have available. Sometimes it is outdoors; it's not necessarily an indoor environment.
Thank you for the tea party.
Thank you.
Alright. When we first found out there was a concrete canoe competition, we were blown away. Concrete doesn't float. This rationale was overshadowed by our team's love for concrete and canoes, so we knew we had to rise to the challenge and take this on. My name's Keenan Hewland. I'm the Buddha Glider captain. We're from Lakehead, a small town university in Thunder Bay, Ontario. We have a lot of parks, lakes, scenery, and we have the most outdoor hockey rinks per capita. Our team of 8 took on this project with less people, less resources, less time, and competitors. But on our first try, we still got it done. Oh, doesn't look like it's so. Our mission was to establish a foundation for future concrete canoeing teams in Lakehead. Our focus was to also create a functioning, stable concrete canoe built for versatility. We did exactly that. We all know cheese makes everything better, so we thought it would be a good idea to bring concrete canoes and cheese together in a Buddha Glider. Our team might be cheesy, but we're cut above the rest. To reflect our great theme, we knew we had to back it up with the quality ingredients in our mix design.
Hello, my name is Connor Dixon, and I was the lead mix design for Lakehead University this year. Our density is pretty high, sitting at 1450 kilograms per meter cubed. We got a compressive strength of 27 MPa and a tensile strength of 9 MPa. We built an absolute battleship this year. Due to our location and funding, we're committed to a very select material. But we use basically everything we could get our hands on. We use Forber, which is pretty common in this competition. We also drove to Indianapolis to grab expanded clay and shale. The expanded clay was used primarily for its permeability properties, and then expanded shale was used as mainly a filler. It also helped break up the clay, which tended to ball up during the mixing process. I won't get into all the advantages and disadvantages of our mineral admixtures, but I will say the main reasoning for the use of fly ash and the blast furnace slag was to lower the heat of hydration to combat cracking. Silica fume was used to increase strength, although one of the disadvantages is the increase in shrinkage cracking. We also used PVA fibers and 19 gauge half-inch steel mesh, also known as chicken wire. Although we weren't really concerned about our tensile strength. Back over to Keenan here.
Our Gouda glider delivers a new, unique shape to the competition. A lot of the other canoes look sort of similar. Our canoe is strong and durable. It can handle the rough conditions in and out of the water. The Gouda glider features a very wide beam. This provides a trade-off of speed for superior capacity, stability, and passenger comfort. This helps support our rookie paddlers to keep us above the water. As a new team, our design was started from scratch. We began with trial and error using hand drawings. We evolved into AutoCAD and eventually used the FreeShit software, which helped refine our design, make it look more canoe-like, and it also backed up our buoyancy calculations, proving that our canoe was going to float. Sorry, guys. And of course, we thoroughly went through all the structural analysis required to ensure our canoe could handle all of the loads. Our canoe strength completely exceeds the compressive tensile flexural requirements. Our canoe is completely handcrafted with intricate woodworking, formwork that require hands-on expertise. Other competitors tend to stand back and let the CNC machine do everything. While we're out here putting our heart into every component of the Gouda glider. Our construction method uses both lumber and foam. Lumber was used to reduce the cost, while foam was used on the ends to help make the point nice, give us the horn on our boat. We drew every foam section by hand and cut them out individually, gluing them together. To reflect LU's versatility, thank you everyone for your time and support.
That was a brilliant presentation. Welcome again. Okay, so in research and development, you guys say that books were your main main source of research from the library. Did you actually manage to build a concrete canoe from books?
So, yes and no. No, in the sense that like you can't really use a textbook to get the density that you're like gonna look for. So we did use that for our water cement ratio for our desired slump, which was between 25 and 50 millimeters, and then obviously we took it closer to 25 millimeters. But then the answer to your question is no, we didn't use books and manuals.
Because you didn't have access to the other reports, we didn't know where to find.
We did, but we wanted to try to be a little bit original and do it ourselves for the first year anyway, and then come here, learn from our mistakes, and then apply that for next year.
There's fluid mechanic textbooks we use to help us understand buoyancy principles and stability, which we used in our enhanced focus area. Also, we did try to do a mixed design based on the absolute method in the beginning, and then we had to use that competition spreadsheet completely. So, yeah.
Okay, like you said, you have an absolute time, but like you have a lot of leeway, right? Because with the amount of you can see the other compressive strengths and other tensile strengths, like you can
There's a lot to play.
have that and get a weight lift against some.
Yeah, so if you actually look in our proposal there, you'll see our mix 5 actually is like 16 MPa, and the density was like 1150 kilograms per meter cubed. But then we ran out of materials, so we couldn't actually apply that. But
well, you're starting point for next
year. Yeah, we're starting point next year.
Well, first time I sick guy walking in school while wearing Crocs and buckets.
As a new team, which part of that competition was the hardest to achieve?
Or fair.
The hardest part to achieve? Definitely just starting relations with companies and getting all these materials. Up in Thunder Bay, the nearest city is Winnipeg. And we did have to drive up here to get some materials. We can ship from faraway places, but we're really trying to keep that on a minimum to keep costs down.
In your schedule, you have a line item to order a truck durations for 2 days, so just add upon.
Yeah. That's more so flow time. Is like we have to do it somewhere within this range. Maybe we could have done that better in our past schedule, but it was something that we were concerned about because our original plan was to get a U-Haul, and I know it's really difficult to deal with them sometimes, but luckily we ended up using a trailer from our school, and it worked out.
Thank you very much for the presentation and the conversation for the first attendance and the reduced senior. You say that you prefer to use geosummer due to its balanced property. Can you explain a little bit what are those balanced properties?
Sorry, could you just repeat that?
You said that you prefer to use geosummers.
Generally use cement. Yeah, just because it's most common from Home Depot.
To balance. We say for its balanced property.
Yeah,
what's
like the heat of hydration? It's a balanced heat of hydration, considered like LH or MH, low heat of hydration, moderate heat of hydration. So just for cost, and we weren't really concerned about the heat of hydration when we added the fly ash and the blast furnace side. So we chose that Portland cement, that type. Yeah, it was widely accessible.
Type GU cement's definitely the first place to start for any team, right?
Second question for me to be for your more cycle drawing. I have the impression you use that double the resistance you have. Is there any reason why you did that?
Double resistance.
Yes, didn't use the compressive strength you have. You use the double the resistance.
Emotions. No, that must have been a huge oversight. We should have been on that for quality. But even double, our Morse circle is way bigger than the struts of both on the boat, which turned out to be a P. Yeah.
Maybe you know about silica fume typically increase water
demand for concretes.
Why didn't you choose to use that high range water reducer or another admixture to avoid that?
We wanted to use a super blastizer.
Yeah.
To reduce the watering. And then we kind of just ran out of time. It seems like we had to get it poured. I think we spent 2 weeks in the lab and I think we started our pouring process at 1 in the morning to get it done. So yeah, we just ran out of time. We're going to use a super plasticizer next year.
That's some stuff to do for next year.
Oh yeah. We're going to be helping out the next group. Yeah. Sure.
I guess, being a new team and planning for next year, you guys have any documentation plans or what's your knowledge transfer plan for moving forward?
We gave them everything, every piece of notes that we have. We're going to be helping them next fall, make sure everything's going well. We're starting to open a website for our team. So it's going to be like a shared access club sort of thing. So they have everything to move forward, and a lot of us are actually going to be back next fall. So we'll be there to pass on the knowledge.
That question regarding your split consumption, it's almost 30% of your 100%.
Yes.
That's very high.
Yes, we added quite a few PVA fibers, and what the test results showed. Hopefully we can keep that ratio going and we can lower the compressive strength.
Guys,
We didn't have a lot of extra concrete. We made like 3 of them. We with our trial backs, maybe 4, yeah.
Our last one was extremely light though.
Yeah.
I don't know if everybody else is here, but yeah.
Again, this competition is in Winnipeg this year, but historically it has been kind of way more east, so Ontario and Quebec. Would you be able to manage the competition like that much further, like with the budget you have and the resources you have, or is that going to be a huge challenge?
Yeah, we'd have to find an increase in our budget somewhere through more sponsors or just family members, like donating. Yes, we have, like, all of us are pretty much from Southern Ontario, so like we have houses to stay at along the way. Yeah, it would be manageable.
Our team's working on fundraising right now already. They're gonna have a lot of a head start to us. I think they're gonna have no problems making it anywhere you throw. We do have the trailer too, so if schedule lines up with our SAE team, that's a huge expense saved. Like just renting a truck and taking it that far is like $3,000 maybe. They might have to rent their own Ford F-150 to get the job done. That's about right.
Thank you and welcome again.
It's fucking Peter. It just ran out.
Yeah. I'll go back out. Take a whole lot.
It's with my great pleasure to say that taxi has finally arrived. Here, me, Michael, James, and Lucas from the University of Toronto Concord Canoe are here to hopefully present to you why our product satisfies all of the requirements of the request for proposal and would make a great selection for the concrete canoe committee. This year, we adopted some novel project management strategies that differed from previous years in order for us to produce a skilled workforce that can prepare the very best concrete canoes. So first, and a major change was that we started having weekly meetings. This year, we had a almost completely new executive team, meaning that there was almost no knowledge transfer given to us due to a complete dearth in transition documents provided. And so these meetings help us foster a greater sense of community, work more efficiently, and have novel sub-team collaborations lead to great innovation on product. And these also really help at bringing in new members. Other project management strategies we adopted was improving our documentation, both for standard operation procedures, knowledge acquisition and transfer, as well as for our finances, really cleaning up our books. This produced a canoe with these associated costs. The first cost is of $29,000, whereas the mass production cost is about $10,500. And while this cost is higher than previous years, we believe this translates to a much higher quality final product on our end.
So driving along to the hull design and construction aspect of our proposal, using pattern feedback from previous years, 2 points of improvement that we identified were maneuverability and removing toe blocks from previous canoes. In terms of maneuverability, we went for a canoe that had less weight and also moved the deepest point closer to the stern of our hull. In addition, with toe block removal, the toe blocks caused discomfort to paddlers, and it was difficult to add enough toe blocks to account for all the different locations paddlers could be, so we decided to remove them. Looking into reducing excess concrete that we use during casting, a couple of methods were used to help reduce our overall weight by over 55 kilograms from the previous year. This was done through more rigorous thickness gauging with belts of foam pre-measured to our layer thickness across our hull. And in addition to that, individual thickness gauges for all of our casters to use to ensure a consistent thickness. In addition, we managed our concrete volume by only producing enough mix that we projected to be using on each layer and only providing extra when needed. In terms of improving our construction quality and efficiency, we did this mainly through the reduction in time spent casting with a 25% reduction from last year. And in addition to improve the smoothness of our product, we significantly improved sanding with 29% of post-casting weight being sanded off our canoe. And in addition, this being due to way more hours being spent sanding with the team, and we also finished with a much higher grit at 800 compared to 50 in previous years.
For this year's mix design, we had a large focus on sustainability. We did this primarily through using a mix that did not use any Portland cement. This greatly decreased the carbon footprint and provided for a more sustainable canoe. We based it off of the 2022 University of Toronto canoe, Fenrir. This was a canoe that also used no Portland cement. However, we changed our primary focus was to change the aggregates. So the first major change we made was we switched from Norlite into pour over 2 to 4 millimeter Norlite microspheres. This was done because we were not able to get a steady supply of Norlite anymore. The other change we made was we ran tests basing on the small aggregate size. So this is the gradation of each of the small pour-overs. We did multiple tests and we found that the best one was the 40-30-20-10 split. This was the one we used for our primary goal when making the canoe was to have a low density while still maintaining the strength required for working the canoe. We were able to achieve this by We were able to achieve this. We had a low density similar to our 2022 canoe. However, we were not able to totally achieve the 2024 Portland cement strength, but it was still well above what we needed for that.
Okay, thank you. We hope that this and the question and answer period will help show why we have a very good
I think you're one of the later teams to cast your canoe, though. You mentioned you cast it on March 16th.
Yeah.
Was that planned? Was that like?
That was not planned. There was a lot of back and forth between me, the team captain, and the civil and mineral engineering faculty at the University of Toronto. Our schedule is very much one that is dependent on the schedule of grad students within the space, as well as the rate at which my emails get responded to. And I had to camp outside of the civil and mineral department's front entrance until I was able to hammer in a casting day date with them. And so it's very much a fun little back and forth to hammer out exactly when things can happen.
So this is not your first year though. Like, does every year is the same problem?
Last year we did have a very similar problem. However, they were able to more effectively handle this moving into this space last year because it was our first time in the area, and so they were already in pretty constant communication with us. This year, a lot of other things came up on their side with health and safety inspections around the time we were trying to coordinate this. And so while we had initial acceptance of proposed dates, those then never had follow-up from their end, which wouldn't allow me to set up and have our wonderful team set up our casting stand and get our mold ready in the space. And so it was really...
Unfortunately, it's a problem that a lot of universities have the grad state.
And so, yeah, this is only our second year in this new space, which is why we're still working out the kinks and the communications.
So do you have plans for next year? Like, do you have, I mean, you can't be hold accountable, I guess, but like...
Yes. We are aiming for a lot earlier of a timeline next year. This year, unfortunately, as was mentioned, we are a very new exec team. I myself, as the captain, this is only second year on the team. And I was out sick with a lung infection until pretty much the end of October, which rendered me basically unable to organize anything. And that really hurt our timeline coming into this year. And so we're hoping that with captains in good health and good spirits, going into next year, we are able to organize things throughout the summer. Yeah.
You just told us that you sent to 800 grid?
Yes.
But you said 1,000 grid in your report. So which one is the good?
It was 800. Unfortunately, we just didn't quite have time.
What advantage did you get by sending at 800 grid?
We sanded up to 600 and then tested with 800. We found that there was a noticeable increase in smoothness after that point, and so we continued sanding with the 800. However, the change that on a small test location with 1,000, we weighed the decision and decided it just wasn't worth the time investment to sand the 1,000 after having already sanded to the 800 and felt the smoothness change and then seeing lack of change.
Good. How did you choose the number of cross-section elements?
In turn, the number of like slices that we used.
Yeah.
Yeah. That was mostly based on how previous years approached the problem. We figured that having 20 slices was sufficient for the length of the canoe, as the length didn't vary too much from the previous year. We figured having 20 slices and then analyzing each individually still gave a pretty good picture for how for the longitudinal analysis of everything.
I just wanted to touch on the sanding again. I think I noticed you guys sanded about 29% of the weight of the canoe.
Yes. While we did implement a lot stricter of casting controls this year, limiting ourselves to 105 total liters of concrete casted onto the canoe, which was a 35-liter reduction on our previous year for a canoe that was longer than the previous years. Most of that excess weight was found on the outer layer. We had just really struggled on the outer layer to keep it to our desired thickness. And so that's something we're going to look into working on next year, is how we can avoid having to sand down all that way to our target thickness when the thickness controls worked so much better on the first and second layers. On the second layer, we were within 10 liters of the forecasted amount of concrete, which is, for all the members on this exec team, the best we have ever done it. And so that's something we are working on. We sanded off all that excess weight so that we could be at our target.
Yeah, 2 layers of mesh. What in your structural analysis for that decision?
In terms of having 2 layers of mesh, we've had this design, the 2 layers of mesh implemented for a very long time. I can't list the exact year, but in a year pretty dated back, they did do some structural analysis testing and determined a noticeable difference with having 2 versus 1. And we've kept that up consistently because we've found it to have no issues in terms of our hull design. We found the 4 millimeter reinforcement, 4 millimeter reinforcement, 4 millimeter sort of configuration of our layering to have worked very well. So we maintain.
It also has a practical application for casting, where all the 3 layers that are casted are of the same depth, allowing for the reuse of our leveling blocks and our leveling ribbings to just improve the efficiency and speed at which we do our casted levels.
I think there's opportunity to that overall process. 1 layer of mesh.
That's a call that we are going to have to make in the future. It's not something I can comment on at this moment. So.
Can you please show me again your grading curve? Does that include all the raw materials, including silica fumes?
This is only the smaller pour-overs. So these 4 numbers represent the different types of pour-overs. So we have the 1 to 2 millimeter, 0.5 to 1 millimeter, 0.25 to 0.5 millimeter, and then 0.1 to 0.5 millimeter, or 0.1 to 0.4 millimeter. These are the pour-over grades that we are given. And then the graphs are used. It's just an estimation. This has not been tested, but this was just the estimation that we used for the representation. And it assumes a straight line distribution of each.
Cylinders were cast radiation curves.
So we would cast anywhere from 2 to 3 per, and then we ran 6 total because we tested both perlite and 4/2 as our large aggregate. Since we could no longer use Norlite, we were trying to figure out what the better larger aggregate would be, like the Norlite replacement. So we were testing perlite, we were testing that. So 2 to 3 times 6, like somewhere around 18.
Your mock failure envelope suggests a high safety margin. Could you have reduced your hull thickness to lower material costs?
Sorry, could you repeat that?
Your mark failure envelope suggests a high safety margin.
So
could you have reduced your hull thickness?
That's something I think we're going to look into. We sort of kept the hull thickness relatively similar to previous years due to its success that we've had with it. So we've tried to maintain that because we haven't had any issues with it. It's performed pretty well. But that is something.
It's also worth noting that with our current aggregate gradations, with the inclusion of 2 to 4 millimeter pour-over inside of our concrete mixtures, with the selection of a 2 mesh layer, we are at the minimum thickness that we can cast to. Otherwise, we would have pour-over interfering with the placement of the meshing.
Okay. Thank you.
In your profile, you provided different proportions of your canoe and concrete. Where you didn't provide the mass.
That was a oversight on our part. we had meant to include that. It just slipped through the cracks.
Have to go through your calculations. 81.
Yeah, it was buried in an appendix, and we just forgotten to also paste it in a table.
All right, thank you, UFT.
Good afternoon, everyone. We are here, my name is Joe Lyons, and we are here to proudly represent St. Clair College with their first canoe since 2018. We are here to represent our canoe Spitfire. I'm going to pass it on to our structural lead, Ruben Weber, and our club president, John Papia. So our team started out with a general level of lack. We had a lack of information from previous teams, a lack of experience. We didn't have any returning students, and we had a lack of resources with no recent successes to back up our community image. So we started out with very, very little interest in the club, very little funding from the community, and very little returning knowledge to help us forward. However, with our hard work and dedication, we were able to overcome those challenges and build a wonderful prototype, and we're proud to be here today and present it to you.
So we have three main objectives with our mix. For our first time back, we said to ourselves, we needed to have a mix that was strong, light, and it's got to be smooth. Now, these were the goals for every team here, but I think we did this a little bit differently than others. Using 4 aggregates and 6 different gradations, we have developed a mix that is strong and light enough that we can make a super thin hull. I think everyone's seen it. We're about 1/4 of an inch or less. We do this because the 6 aggregates that we use, the 6 gradations, allow us to have a very tight particle packing density. So we can get the strength we want. And of course, with the strength in a lot smaller size, we're lighter. And this current product that we have is a really good symbolism of what we have and what we don't have. We have a mold from 2018. We have nothing else with it. So it leaves us in an awkward position because what do we do with it? We can't slap any concrete on it in order to get what we want. So through 48 trial mixtures, we have developed a concrete that we can use to get the results we want, and we needed a way as well to make up for our experience. So using a tried and true patty method, we made an assembly line system that can make up for a lack of knowledge or lack of experience and give you the great canoe Spitfire.
So showcased here, we have some of the drawings that we used, that were used to design the mold originally. And this is an area that we're really interested in looking to expanding in future years, really modeling and designing the hull for our own personal use and for what the competition is asking for. Money talks. At the end of the day, that's what matters most, right? You want a quality product for a good price. Our man hours in the development phase came out to around 300 hours spent in lab between various trial mixes and around 50 hours in planning. Using the rates that were provided, that came out to around $14,000 as a development cost. Materials, our prototype, all of our materials were donated. However, using the calculated cost, we came out to $103.19 in terms of materials. The biggest thing is the labor. We had a really long casting day, and that's reflected in this pie chart here. Moving forward, we would want to develop a reusable mold. We project that to cost somewhere in the range of $5,000. And altogether, that brings us to a total cost of approximately $334,000 to produce 100 canoes.
That is all for us, but we just want to say thank you to everyone here, to a nice and warm welcome back to the competition. Thank you for all the teams here and all the judges. Thank you.
Welcome back, Caesar. Thank you. So you said, you have the mold still. You also say that most materials were also in possession, like you didn't have to acquire.
We had a lot of the aggregates, but cement materials were not in stock. That actually made one of the reasons why we needed 48 trials, because we just couldn't get anything other than Portland up until like trial 20. So we figured we needed to learn at that point and incorporate the cementitious materials aggregates.
Yeah, where I'm going with this question is, how old were the materials you used?
No clue, sir.
Yeah. So the two of them have a potential expiry date, can you stand by them performing the way it's supposed to?
We had no issues with the flavor except for the fact that it had a 0% moisture content. But we can bring it back to SSD and we haven't noticed anything. When you have to go buy new flavor, just the only difference was moisture.
So it's only aggregates you had, you used.
Yes.
There was
No cementitious.
Okay.
How many grading of aggregate do you?
Six. We have we have a aggregate called True Light, which occupies a larger space, a larger grain size. That with 2 to 4 is about the highest we go. Then to get the lowest amount, we use a K&E non-silica sand along with Porter 0.1 to 0.4. And the middle aggregate size is taken up by Porter 0.25 to 0.5 millimeters.
This is not available in your reports.
I'm sorry?
It is not available in your mix design reports.
That's an oversight. That's something else.
It's on the mix design sheet.
So moving forward into future years, that's something we noticed this year is we really have to work on our documentation so that we're not missing anything, we're not losing track of where we are, what we've done. So
because I'm looking at the mix design here in the reports. I don't see all the aggregates.
Yeah, thank you.
What plans do you have for your reusing or repurposing your canoe after the competition?
That's the canoe.
Yeah.
We're hoping that it stays in one piece and that we can take it back to the college. And we'll probably use it as a display for future students to try and bring them into the club to build our team a little bit. We had a total team of 15 people at most, and of those, only 7 were able to come. So we started out with a relatively small team, puts a lot of work hours on individuals. That really pushed back our timeline with stress and just school is the primary focus, right? So canoe as an extra really put a heavy load on.
You achieved 1,211 kilos in density, in dry density actually, which is significantly higher than most competitors. Do you have any targets yet for next year or?
Sub 1,000.
Sub 1,000? Okay. Would be great.
Yeah, and on that point, did you mention that you had a target, a 70 goal of 10 MPA was chosen? Okay, so you ended up getting like 14, 15 MPA.
We kind of changed our goal to that because at the beginning we said to ourselves, this is a good target strength to ensure that a canoe doesn't break. But then afterwards we decided that in order to get a smooth finish, it was just very hard to not get the force low.
But that came at the expense of density. Though.
Yes.
If you had a target of 10, then you reach 14, like that's a good thing, but then your density is so much higher. So there's going to be an exchange there. Your 20-day compressive. So here's another thing though. You go from 7-day 14 MPA to 28-day 20.
That was the mix we decided on for the cast.
That's a huge, like, I wouldn't expect something to increase that much. Right? The way a concrete curve works at 7 days. But like, how much do you expect it to gain? If you get 14 MP at 7 days, at 28 days, how much would you expect?
Around under, well, because the high content slide we have, we're really close to 65%. Again, with the 14, 15 was the second goal, but the mix that we finally decided on, because we were running out of time, reached 21 days of strength. And again, it was smooth, it was light enough, and we just wanted to ensure we had a canoe that wouldn't break.
And I'm asking this because you had 48 mixes, so did you start, like when you started shooting acceptable mixes, or was it really near the end only?
Really by mix 31, 32. It took that much time to just learn about it, because as a college, we also don't go super in depth to different types of structural concrete. We stick true to what we use in the field, and it's up to us as new students to do our research.
Speaking of that, see that you've got bottom ash in some of the mixes. Did that make it to the final mix?
Yes.
What was the rationale for using that? I'm assuming there was some research behind it.
We love it. It took a nice area in our gradation spread. We noticed that every time we use it in a mix, our strength goes up dramatically. So bottom ash is not cementitious, but I believe that some of the particles do actually hydrate. So the noticeable increase is just, it's too good to leave out.
And then at what point would that increase happen in the hydration process? Something that would be, you know, a later, yeah.
We definitely notice differences past the 7 day strain, because again, it's lower at 7 days because the high content of slide we're using. But then afterwards, we notice an increase.
The salt fibers that were used in the mix, were those leftover material or source?
We source those this year.
What was the choice to use those over
So the choice for the
process?
We ended up hand mixing most of our mixes because we didn't have an available mixer. So PVA fiber is very clumpy, very hard to mix with. But the basalt fiber, we chose the size of 35 millimeters, and we found, depending where we put that in our mix, like at what stage, we could mix it by hand.
So you're reusing the 2018 mold? Yeah, so I just want to know the methodology building from that going forward. Did you guys have a target thickness and then keep doing mixes until you could get that, or was the mix first and then design your layup over that mold afterwards?
Yes, because we just wanted to know, we had to develop a process as well as how we're going to cast it. So that really depended on our mix. At first, we actually had a higher slump because again, that's standard. Concrete's got to spread, right? But we decided afterwards that we got to change the slump to almost zero. And at that point, we were very far in our mix trials. So that changed our process. I get a complete idea from the beginning to the end of where we actually cast it.
That we use that were consistent thickness. So we put on one layer of patties and we put on our mesh and we put on the next layer of patties. So that was our form of thickness control. It was the patties. We just put on 2 layers of patties and that gave us the quarter inch approximately that we were.
What was the advantage of using laser fibers, but I think it's fibers, and I saw the size is really big, 36.
We just found it was easier to mix in, and it gave us the an extra little bit of tensile strength. Again, we were unsure about this because this is our first time doing a mix. So we figured the larger size that we can go to a macro fiber really would be in our benefit, and over glass fibers or nylon. Basalt fiber is sourced locally. It was free for us. So hopefully we continue that partnership and use it in future mixes.
Just I know green is your color, but
please
next year don't put a green background in your report. It's really hard.
This stuff, yeah. Do you have what are your plans for continuity and maintaining the club? Like you said, it's a struggle of 6-year hiatus is significant. So are you guys coming back next year? Do you have a plan for next year?
We're all second-year students.
So we're all coming back.
I see.
Hoping to, with riding off of this year, bring in a bunch of new second and first years, and then it's harder at the college because they only have 3 years under the civic program.
Okay.
And there's a lot of 3-year programs that there's a lot at college, which makes it even harder to diversify our club membership because they're only there for 2 years.
Well, welcome back, and thank you again.
Thank you.
Alright, hello everyone. We're the Queen's Concrete Canoe Team, here to present our 2025 canoe, the Freck. I'm joined by Andrew Woodruff, our team captain, Julia Shepard, concrete head, and myself, Charlotte Richardson, also captain. So, getting right into it, the spirit of the Freck. So our theme this year is the Freck, and as you saw in that trailer, there are orientation leaders for engineering orientation week. These leaders represent strength, leadership, resilience, determination, and collaboration, which are all values that us as a team and engineering students in general align with. This year, one of our goals was to focus on our theme enhancement and developing that on the canoe itself. So as we have a male mold this year instead of a female mold, we have easier access to the exterior surface of our canoe. And doing so, our inlays that we tried this year were pretty successful. It was the first time we've ever tried inlays, so obviously we learned a bit along the way that we would change for next year, improve our methodology, but overall we did like this method.
So for concrete, we did 32 iterations to get the best mix possible that we could get. Our main goal this year was to get a lighter canoe than last year. We did that both through the actual mix design itself, but also placing. So we made sure that when we rolled out the layers, they were nice and thin and even. So we successfully did that. We had 490 pounds last year, and we got down to a whopping 214 pounds, which was huge for us. And so for coloring, we went kind of for our theme, a dark gray. It was attributed to a high silica content, and then also the added black dye.
Looking at the design of the canoe, as Julie just mentioned, we've had actually a series of massive improvements. Our biggest one is just cutting our weight by over 50%. Additionally, we used a male mold with also a different technique of applying our concrete by rolling it into sheets so we can actually evenly measure out a thickness that we desire and specifically choose it with more ease. So we've done 2 layers and we were able to roll out those sheets in a little bit more uniform way. And we actually were able to make it quite a bit thinner, which is the reason why it was able to cut the weight by so much, which is really just pushing our concrete's strength and testing that just to the max with much thinner walls. Additionally, we used a curing room. So we actually used a humidifier and a curing tent, and that allowed us to have a bit of a longer, slower curing process. And then additionally after that, we spent a little bit more time on our sanding process using higher quality sanding equipment and just taking our time with it using different gradients to apply a better finish to the outside and inside of the canoe. So that just looked a lot better this year. And then we do additionally have some improvements that we would recommend for next year. Biggest ones are actually going to be moving up our pour day again. So we actually moved up our pour day already from last year, as that was a suggestion. We moved it up by about 20 days, and we'd actually recommend moving it up even more just to give a little bit more buffer. Really when we're testing ourselves here to, new limits with stuff that we haven't really ever done before, it's better to have buffer. And additionally, we would actually advise to work on the rolling technique a little bit more on not just the inside, but also on the outside in tough areas, especially with something like an inlay, spending more time rolling out the thickness of that so that it's a bit more.
So in terms of sustainability, we lowered our cement content to reduce CO2 emissions. We also tried to locally source as many materials as we could.
And additionally, waste to be sustainable, we also had use of recycled materials in our mix. We do have the possibility of lower use for future years, or even just repurposing the foam for transportation purposes. And finally, with our curing tent and humidifier system, we reduced our water usage by trying to just trap that moisture in and not requiring the use of the humidifier as often.
In terms of finances, for our fixed cost, we're at just over about $1,000 for one canoe, and for our variable cost, about $9,000. So for one canoe sitting around $10,000, for 100 canoes sitting just under $900,000 there's a lot of labor and stuff to go into this. And, really looking at community as a whole here, comparing ourselves to last year, looking at the big improvements, we're just on an upwards trend. We came from a limited knowledge transfer from last year, and this year we came back, we cut our weight by more than half. We're trying out new things with inlays. We're really testing ourselves to the max and really just showing that we care a lot about getting better and better and better. The finish on the canoe is even better this year, and we're going to continue growing as a team. We really feel we're a great option, and we would love to partner up this year. We really feel like we're a passionate team that's just going to keep going upwards. So thank you for listening, and we'll open up the floor to some questions.
Queen. We're definitely on the lower spectrum in terms of compressive strength, right? Just below 6 MPa. Is that, you just reported it actually like that. Is that the 7-day, 28-day?
Yes, 28 day.
28
So-
days, like 770?
Yeah, so we did have a lower compressive strength that we wanted to have. We were aiming for around 8 to 12. But due to, wanting to get a lower weight in general, we decided to sacrifice a little bit of that strength. And that's why we didn't make our canoe any thinner than an inch. So it's still thicker, on the thicker end, but we were just our main goal this year was the weight. So we just had to sacrifice a little bit of that strength.
Okay. And also, there's no ribs, right? So you just went with the thickness of the canoe to compensate for that weakness. Because some teams go for ribs or thicker gunnels to help.
Yes, so on our gunnels, you can see certain parts they're thicker, and we did that with our milling design, and also our biggest focus was really just creating a sleek shape. This mail mold was a very different process for us, so we really just wanted to do what we were going to do to a high level, and we felt just adding ribs, might have just been a little bit too much. We're also trying to limit the amount of concrete we're using, and it's something that we are also thinking about experimenting with next year as the next step, go for even more strength, and potentially even have that as a way to reduce weight too.
And we did notice a few cracks on the side stemming from the gunnels. So are those worrying you, and what do you think they are due to?
They're definitely worrying us for sure. And a big thing that has definitely contributed to those cracks has been transportation. It's just been a very long trip here, and fitting your canoe properly for the bumps in the back of this pretty heavily suspension truck don't totally crack your canoe. It was really hard to do. So bringing it in and out and then driving 24 hours, there's been a lot of cracks. For those, best we could probably do is at this point taping them. And for next year, knowing that's a possibility, we're just going to have to spend lots and lots of time investing potentially something that's going to stop that from happening during transport. We thought we had a good game plan, and clear that we just need to spend a bit more time.
And to add on to that, we're also going to maximize our set retardant to kind of help with that cracking. But also on top of that, get a thinner mesh. We had some problems with the placing since we chose quite a big mesh that wasn't very flexible. It created some problems with the placing and some bubbling. So I think if we go next year with kind of a thinner mesh that we can add, have a better finish, I think that'll also help with cracking.
Your punching shear analysis relies only on the concrete. Did you consider the contribution of the fiberglass, or is it assumed that it's ineffective in that case?
Well, looking at that, we're kind of then doing like a worst case scenario. So, that would tell us worst case, best case, with that added fiberglass, because it was hard to really measure for our construction heads, hard for them to measure, how much that's going to help. Their first time using it, limited specifications on it. We would definitely have to do more investigation with that to get the higher number, and our lower number, should be the worst case. If that answers.
Yeah, thanks.
Part of your budgeting process is very 25. See what your opportunities reflect on how much of that contingency kind of into the process that's next year.
Good question.
Changes there.
Yeah, so it's actually 25% on both ends. So it's actually a massive increase. The Engineering Society of Queens doesn't like going over budget. And if you think about it, construction, super common. So, reasonably speaking, like, makes sense from their end. That's what we technically have to do for them. And if we're partnering with the Engineering Society for our banking next year, which we actually have an option of going to the Civil Society, it wouldn't be the same metric of budgeting. And if we're part with the Engineering Society, we have to continue doing that. That's just their specifications.
You guys figured that your molds could last approximately 20 canoe castings. How did you determine that?
I think, so it's a difficult one to determine. Again, we haven't used the male mold before here in many years. And also, it was a new styrofoam that we're using this year. It's not the same as the old one. And we weren't really sure how it would hold up. So again, that would be more sort of a, hopefully underestimating, just to, be more realistic. It's in great shape. We pulled it out. We could use this easily more times. And we felt that, hey, let's be realistic here. After, lots of use, this mold could just be too damaged to give you the same quality canoe. So it just makes sense to, predict maybe some worst case here. Are we going to have to replace this mold?
You guys also touched on at the start of the presentation that you had some lessons learned that you would implement next year for the inlays. Know what those are?
Yeah, so for the inlays this year, we've done our exterior layers. We had our first layer, sheet mesh, and the final one. We had slightly as we were doing the rolling process for the inlays, as we did a separate, as we applied it, we realized that it kind of was adding a bit more of a thickness than we wanted to, and just almost a bit too thick than the rest of the canoe. So I think for next year, we just make sure we fully confirm that we have enough room and also kind of make it a thinner final layer.
And to add on to that, even instead of doing inlays on the outside, we do maybe some outlays or inlays on the inside instead, just so that if we switch molds or if we do the male mold again, the outside is more smooth and safe.
What do you consider the water absorption from your aggregates in computing your water to cement ratio and water to cement ratio in Excel sheets?
Sorry, could you?
In your mix design Excel sheet,
Yeah.
you consider the absorption of water from your paragraph in computing water to cement ratio.
Yeah, we got that from the SPS sheets or the material safety data sheets. Yes, we use it for each different material. And kind of like that.
In your report, you said you did extensive testing on building after those are how substantial were the results to be able to achieve?
Yeah, so we were sponsored by both Euclid Master Builders. We had a few different options for the different types of admixtures. So we did most of our iteration was deciding which. So we for both mixtures or admixtures, we tried low range, mid range, high range, and also kind of had a few mixes going. We had two different mixes that we kind of liked. So we had to kind of test with both. But to be honest, each company, they generally were similar, but we found that Euclid maybe needed a little bit more for the mix that we ended up choosing to get that high range versus Master Builders. So we figured long term, Master Builders was good. We also used it last year, so we know it would hold up. But next year, we'll definitely still do the comparison based on the mix we chose. But for the mix we chose, the Master Builders was more compatible.
Maybe comments in your focus area evaluation matrix. Table 1 was not very intuitive for me. You had the total score, you have waiting, it was not easy.
Do you think?
Yes. You have the total 100%, you have score 4.3 out of 5. Maybe next time, make it more clear.
Yeah, that's good. Thank you for the feedback. Yeah.
Thank you, Queens.
This year, McGill Concrete Canoe is proud to have been shaped by adversity. Expertly navigating space access issues and material supply delays, our team has been through the trials and tribulations of the metaphorical battle. And through the smoke and the dark dungeons of McGill, we continue to forge our own identity, an identity of strength and resilience, pride and valor in our craft. Honed like a sharp blade, we are proud to present the latest improvements in concrete canoe technology. Stand with us as we present to you Valora.
Hear ye, hear ye. I, Zealand of Academics,
Alina of Hull Design,
and Iris of Mixed Design,
present to you with greatest honor McGill's long-awaited, most valiant canoe yet, a canoe of concrete that doth float, Valora.
Despite the medieval theme, Valora possesses modern features. The main innovations of this year's project include a reanalysis of the symmetry of the hull, the use of lightweight aggregates in the mix, and the transition from a male to female mold. Beyond the product, our team puts an emphasis on sustainable and financially conservative projects that will make our products stand out. Year after year, we have reduced prototype carbon emissions through material choices. In addition, our trained financial team is part of every aspect of the design and manufacturing process. Every single expense must be pre-approved by captains, ensuring that we stay on budget despite McGill budget cuts, limited lab access, and unexpected material needs.
After being awarded McGill's Design Team of the Year, we know there are many things that set us apart as a team. We pride ourselves on diversity. As a team of over 50 people, we're over 60% women and gender minorities. Half come from departments other than civil engineering. Our resilience this year was demonstrated through navigating space challenges, supply setbacks, casting twice, and ultimately a transportation delay. These were managed masterfully utilizing our hierarchical management structure as well as organizational accountability. In addition, we introduced a social media coordinator who introduced our presence on multiple platforms and helped keep our team more connected.
Taking a closer look at Valora's design, starting with the hull, we focused on the importance of harmony between the canoe and its paddlers. Before drawing anything, we sat down with our paddlers to discuss the performance of last year's prototype and align our goals for the year. An example of an outcome from this conversation are the raised bulkheads, which were added to deflect any water coming over the bow. Based on judges' feedback, we also re-examined the asymmetry of the hull to ensure a more efficient weight distribution. Overall, our design strikes the perfect balance between versatility and performance. Valora boasts racing-inspired features such as a high L/B ratio and high rocker that grant our paddlers the speed and precision to excel on the water.
This year for our mix design, we decided to try out some new mixing methods as well as modifying our concrete to make it more sustainable and cost efficient. The biggest change we made towards these goals would be substituting white metakaolin for fly ash. We did this because fly ash is cheaper, easier to source, and a waste byproduct. Another change we made was increasing our cement to Portland cement ratio. This was chosen to decrease our CO2 emissions, which you can see in this graph here. In addition, another change was substituting Norlite for perlite. This change was made because to reduce the risk of inhalation when mixing, as well as just to reduce the specific gravity of the final product. Finally, we changed our mixing methods a bit this year to ensure a better incorporation and distribution of all materials within the mix.
Recovering from a gap in knowledge transfer after COVID-19, our team relied on male molds, which are easier to build and easier to demold. But imprecisions in the hull and poor surface finishes requiring hours of sanding compelled our team to take on the manufacturing challenges of a female mold. The female mold also doubles as a snug, protective case, perfect for safely transporting our prototype from Montreal to Winnipeg. And because we designed it to release the canoe without damage to the mold, it's fully reusable. A decision that paid off when we had to recast.
We know that from a business perspective, it takes a lot more than just good looks to sell 100 canoes. We were able to decrease our cost estimate per canoe for the mass manufacturing case, even in the face of rising inflation rates. Detailed in our enhanced focus area, our research, design, and development lay a strong foundation for large-scale production and distribution. Building upon the transportation challenge, we use our EFA to explore various transportation methods in a feasibility study seen above. We assessed each option based on cost, sustainability, safety, and speed. By considering novel transport methods and ensuring global deliverability, we set ourselves apart in terms of preparedness. This strategic groundwork positions us well to transition into the next stage, marketing and distribution as a full-fledged business.
It is with great honor that we have presented our canoe Valora, defined by the innovations in her design as well as materials and cost efficiency in her production. May she prove to be legendary. Only time will tell, as tomorrow we strive, with valor in our hearts and concrete beneath our bottoms. May thou find us, deem us worthy to be crowned champions.
Thank you.
Thank you, Miguel. Are you relieved to have your canoe finally?
Yes.
Now, I thought to ask a question because your EFA literally revolves around transporting the canoe. So, you know, what happened? How did you manage it? Could it have been avoided?
So the main reason that happened is that basically we, as everyone else, are a very busy team. All of us have internships or working jobs this summer, and we just simply did not have the time to spend 3 days driving out our canoe from our house. So that is the reason why we chose to ship our canoe primarily. It also ended up being more cost efficient in terms of like we wouldn't have to house anyone, pay for gas, those kind of things. Those were some of our main reasons. Another one is that we made other attempts at transfer. So like we reached out to other teams as well to attempt to see if we could coordinate, figure out something along those lines. But eventually choosing the shipping company was what we thought was the best way to do it. Another misunderstanding on our part that we didn't realize until we arrived was that we had been told by the shipping company we had to pick up the canoe within 24 hours, which is why we shipped it so late. We did not realize that we could have asked someone here to hold the canoe for up to a week for us before that. So that was a misunderstanding on our part. That is the main reason.
Yeah, because I was gonna ask why you shipped it earlier, but yeah, you couldn't because
we misunderstood. It was the first year we're shipping canoes, so.
So part of our decision making, we did look at many different transportation options, and we decided upon this as a team. Ideally, we did want to drive it. That was our first choice. We felt the most secure in that. The next choice for us was the professional driver, hiring someone and outsourcing it to do this. That was the logistical decision we prevailed with due to those constraints. But we also, really the biggest factor for us was cost. This was our original plan, looking at how we could reasonably transport our canoe here ourselves. We looked at different routes. We really made all the considerations, but ultimately it was just a good decision.
It goes to show that you can plan everything.
We tried.
Okay, thanks. I'm glad you made it.
Yes.
Your punching shear resistance is calculated at 0.463 MPa, and your factor demand is 0.46, which is extremely close. Did you test this in practice or simulate higher loads? Because, yeah, the margin is practically nothing.
The margin is very small, and it was the case that we were most concerned with. We don't use mesh in our calculations for the punching shear resistance, so we are certain that that contributes a significant amount to the shear resistance in our canoe. We chose just to use the concrete strike to make sure that that at least was secure. And then
we did test the punching shear. We did that as a physical test. Another point would say to ensure that we're not going to, in that cases, we're going to wear knee pads so that for the paddlers, the area is a bit more distributed instead of the area we were testing with, which was quite a small surface area as well for punching.
But it was the leading factor in the thickness of our canoe, deciding what thickness to choose with the punching shear.
And you also mentioned that you plan to reuse crushed concrete in Miguel's lab, we can do. How do you assess the viability of this used recycled concrete aggregates, because it's not a typical mix?
So the purpose of this, we share our lab with some of the undergraduate labs, and one of our previous captains is currently a TA, so she's helped facilitate this arrangement. They have the means to crush it, and since it's not going to be for anything structural, it's just going to be for demonstration purposes, it would be an appropriate use.
I was looking at your engineer's notebook with the installation of the mesh on the inside. It looked like it was cut into sections to make it fit in. Correct me if I'm wrong on that.
Yeah.
Did you guys have any concerns on that not being continuous length of your canoe?
Absolutely, yeah. We wanted to make sure that none of the cuts that we made were continuous across the longitudinal or transverse direction of our canoe. And we ensured that we were tying them with small pieces of wire together to make sure that they're still snug in place and fit.
Additionally, for the mesh, the photos in the engineered notebook are from our first casting. We had some issues with the exact problem with the cuts, and when we cast again a second time, we moved the cuts, minimized them a bit more, and ensured that we tied all of the mesh together to avoid that exact.
As part of your sustainability, the cultural approach this year, and it states that it guides all your decision making. So what decisions for this?
So I would say that, sorry, is guided in the sense that we want to give back to the community. So as we mentioned, crushing up some of the old canoes for the labs that we were talking about. So basically in giving back to our community, another thing we have attempted to do with our old canoes is turn them into like flower beds for our grounds. And basically it's just trying to, as well as outreach in terms of our new social media coordinator, just being able to get the word out and make sure as many people are involved.
Another part of this is a lot of our team has spent extensive experience in canoes, and most of us are not Indigenous, and we wanted to bring awareness to that on the team. It's not something we traditionally recognize as a concrete canoe organization, so we wanted to start doing that.
You say use quick crates, cement jack. I want to know just the manufacturer of this. Who's the manufacturer of this?
I believe it's quick. It's
From here in Canada?
it's just the kind of cement you can pick up from workers.
The document provided in the engineering book, I didn't say TDS. I saw a document, but it wasn't TDS.
Okay.
It wasn't clear.
Okay. We'll double check.
When we took a look at your prior to this, there was some sliding of the ankles. What's your plan for next year to address?
Our plan, so we believe that occurred because due to the injuries not adhering properly to mold, is a pretty sure using female mold as we mentioned, so we're still kind of in the learning process of that. So our plan for next year in making them stay better is that we are planning to essentially, we use silicone to attach them this year so that it was removed from the mold. But we cast them the night before, ensuring they were good cured to make them stay. But I think even further in advance of it, we were trying to avoid hole joints. But as next year we have smaller inlays, it will be less of an issue, the hole joints. That I think is our main thing. Of course, we're not sure exactly of our design next year, but it's definitely something we're going to keep in mind.
So I noticed in your analysis, you mentioned that you optimize patio placement to minimize your values, right? So I understand that in theory, you just draw that arrow and that works, but when you're going to be on the water, how are you going to guarantee that the paddle is not going to restrict themselves in a good position?
Well, that will take proper planning when our paddlers are getting into the canoe. Also with the knee pads, if they're on their knees with they shouldn't be sliding around very much. We've had canoes in the past where if any water gets in, you find yourself sliding around, but we wear sneakers and especially with the wetsuits, you should be pretty stable in the canoe.
Yeah, be careful with that because you can't guarantee that they're not going to move around, especially if things start shifting. So
Absolutely.
And I don't know how much gain you're getting by just putting them in optimal position. A little bit to the left or to the right shouldn't put you in danger if it's the same problem.
I'm also curious to know what was the permeability concern you had last year in design, as you say in the design section. Permeability concern.
Oh, it was, we use quite large aggregates. So we just, even though we have a sealant, evidently, we had an issue with water coming through the canoe, because it is very porous. And so we were just trying to reduce our larger aggregates this year. In terms of aggregate profile, we used 2 to 4 millimeter pour over, and we greatly reduced that past years, as well as reducing, we substituted perlite for perlite, which is our other large aggregate. That was also significantly reduced in amount to try and deal with the porosity.
Well, did you measure the permeability? Or did you have
It wasn't measured. It was just noticing, through practice in competition, as well as testing what the cylinders are floating.
Thank you very much, Miguel.
Thank you.
Bonjour, nous sommes l'équipe de l'Université de Moncton. Je m'appelle Noah, accompagné d'Emmanuel et Zachary. Aujourd'hui, nous sommes heureux de vous présenter notre canot de béton, l'Avalanche. Afin de répondre à la demande de conception et production sans canot à béton, l'Université de Moncton avait comme objectif de livrer un produit final convenant à performance, qualité et fiabilité, tout en respectant les exigences d'une production à grande échelle.
La conception a été réalisée afin de prioriser la performance. Nous avons opté pour un canot avec une coque symétrique qui permet d'avoir une navigation à la fois stable et prévisible, peu importe la direction. Ensuite, le canot a été dimensionné de sorte à pouvoir accompagner confortablement 4 ramas, tout en assurant une bonne performance hydrodynamique et une autonomie maximale pour nos rames. Ensuite, le canot avec une enfourche de U, avec un fond plat et des parois raides, permet d'augmenter considérablement la stabilité. Ensuite, les rapports transversaux ainsi que les plabords ont été dimensionnés afin d'augmenter la résistance, sans pour autant augmenter le poids. Finalement, le patin a été fixé à 4 mm, ce qui nous permet d'obtenir un canot à la fois robuste et léger.
Pour conclure les granulométries, nous nous sommes basés sur un mélange de type béton projeté reconnu pour sa compacité, sa performance et sa mise en place efficace. Cette approche nous a permis d'avoir une distribution optimale des particules, favorisant une meilleure densité et une résistance accrue du béton. La partie cimentaire de l'avalanche est composée d'un mélange optimisé de liants hydrauliques et pouzzolaniques. En diminuant une teneur de ciment Portland et remplaçant par des liants alternatifs comme la chaux hydratée, nous diminuons l'empreinte écologique de notre mélange. Cette substitution améliore également la résistance mécanique, diminue la perméabilité du béton sec et facilite sa mise en œuvre. Nous avons aussi intégré un mélange d'adjuvants afin d'optimiser les propriétés du béton. Ceci nous a aidé à retarder le temps de prise, limiter les fissures de retrait, réduire la quantité d'eau et modifier la viscosité. Le tout dans le but d'avoir un béton à la fois plus durable et performant. Nos mélanges ont été planifiés afin d'optimiser le rythme de production. 5 monoxydes fonctionnent simultanément afin d'avoir un rendement élevé. De plus, une coordination précise dans l'équipe de malaxage et coulage a été afin d'avoir
Afin d'obtenir un produit final uniforme et de grande qualité, nous avons opté pour la méthode de construction suivante. Premièrement, nous utilisons un moule de polystyrène expansé, découpé avec précision à la machine CNC. Il est ensuite recouvert de ruban adhésif afin d'être prêt pour la station de coulage. La coulée se passe en plusieurs étapes. Premièrement, on commence avec une première couche de béton de 2 mm. Ensuite, on ajoute notre maillage avec une technique de frottage afin d'assurer d'avoir une bonne cohésion entre nos 2 couches de béton. Par la suite, on ajoute une deuxième couche de béton de cette fois-ci 7 mm. Afin d'avoir une épaisseur uniforme tout au long de la coque, nous utilisons des trombones modifiés calibrés à la bonne dimension. Après l'étape de béton, vient l'étape de la cure. On met le canot dans la cure pour 14 jours. Ensuite, on le démoule et puis on le replace dans la chambre de cure pour 14 jours supplémentaires afin de la compléter. Dernièrement, il y a l'étape du sablage, où on commence avec un sablage mouillé afin de remplir les vides en surface et on termine avec un sablage à sec. Finalement, on ajoute la peinture et le scellant afin d'avoir le produit final de la vente.
Afin de produire un canot à la fois fiable et sécuritaire, nous avons performé une analyse structurelle sur tous les cas prévus lors de la compétition. Pour prendre en compte les charges dynamiques, nous avons rajouté un facteur de sécurité de 1,25. Ensuite, l'analyse a révélé que le point critique serait donc que le plan mort, avec une contrainte en tension. Nous avons donc décidé de rajouter des fils de poudre pour augmenter sa résistance sans pour autant augmenter le poids. Finalement, nous avons utilisé les critères de coulomb mort pour évaluer nos contraintes, ce qui nous a permis de développer une enveloppe d'extrémité à la fois fiable et garantir une résistance des canaux en toutes conditions.
L'avalanche représente un équilibre optimal en performance, qualité et fiabilité. Avec sa masse légère et sa grande résistance mécanique, il a été conçu pour répondre aux exigences techniques sans pour autant enlever sa qualité. Il est performant, il est lisse, il est hydrodynamique, et cela ajoute tout cela à avoir une construction efficace sans enlever sa qualité. L'Université de Moncton amène un produit de qualité. Pour produire 100 canaux, il a été décidé que le prix total est de 8 350 000 $. Ce coût total englobe tous les prix de fabrication, de conception et de production. Ce projet est non seulement viable à grande échelle, mais aussi économiquement stratégique, considérant la grande part de performance, qualité et fiabilité. L'Université de Moncton est prête à livrer à grande échelle. Merci beaucoup.
Merci, Martin. Pas de passer dernier? Non. Ouais, écoute, votre temps de malaxage, je vais y passer de 6 minutes à 18 minutes. Là, votre mélange a changé, évidemment, puis vous dites que c'est donné le temps à c'est quand même très long, 18 minutes. Là. En termes logistiques, c'est sûr que ça vous met des contraintes. Il n'y avait pas moyen de. Ça valait la peine de garder ce mélange-là s'il prend autant de temps. C'est très long, ça.
Oui, parce que on a commencé avec 3 malaxeurs, puis là, on a acheté 2 comme de plus, puis là, on avait comme 5 minutes entre chaque mélange. Ça nous a apporté comme le temps parfait pour être capable d'appliquer le béton. Puis là, on n'avait pas trop de mélange en même temps quand on coulait. On avait comme le temps de faire sûr qu'on n'avait pas de joints froids. On avait le temps de vraiment bien appliquer tout le mélange avant qu'un nouveau silo arrive avec un nouveau mélange.
Oui, je comprends que tu as bien géré, mais c'est vrai que 18 minutes pour un mélange, c'est très long. Puis, dans les années futures, parce que tant mieux, c'est beaucoup de mélangeurs, là, mais c'est quand même très long. Là, les autres équipes, si on regarde, dans ce cas, ceux qui boivent d'habitude, ça tombe dans les 5 à 7 minutes. Je pense que c'est vraiment nécessaire, là, 18 minutes, vous l'avez vraiment timé, ou genre, à 12 minutes, il n'est pas bon, mais non, encore.
On l'a essayé, comme, on a fait je pense qu'on a fait 12, 16, 18, puis là, 20. Puis là, on est arrivé 20, on pouvait bien le sortir, ça venait vraiment lisse. On avait une meilleure homogénéité dans tous les matériaux. Nous autres, on a trouvé comme les 18 minutes étaient vraiment optimales pour nous autres, selon nous autres, on voulait pour la performance.
Okay. Vous considérez que votre moule va être bon pour un seul canon? Est-ce que vous avez un système de moule qui est peut-être plus durable ou modulaire ou augmenter la réutilisation?
Alors, en ce moment, on utilise un moule mâle. Et on sait que pour le moment, c'est juste ce qui fonctionne pour nous. Ça fonctionne bien, ça fait 4 ans maintenant qu'on utilise ça. C'est sûr que dans le futur, on comprend qu'un moule femelle est capable d'amener un gros bienfait dans le point de vue réutilisable, éco-développement, toutes ces choses-là. Mais pour cette année, on a posé avec un moule mâle. C'est vraiment juste ça qu'on est avec.
Votre facteur de sécurité en traction, c'est 2,7 à peu près. Est-ce que, en situation de choc, parce que les twins ont des gros bras, là, est-ce que vous considérez quand même que ça reste suffisant pour éviter toute rupture? Ou...
Ouais, on a rajouté un facteur de sécurité de 1,25 en des charges, mais on assume que c'est assez pour prendre les charges qu'on va mettre dessus à l'avant.
Okay.
Puis, je pense que c'est
C'est un petit commentaire aussi dans votre abstract, et le temps de prise pour une propriété. Je pense que c'est vraiment le temps de prise du béton. La date, la mesure. En revenant pour le temps de la les 18 minutes, parce que vous avez un plan d'augmentation de température en 18 minutes de votre mélange.
On garde le laboratoire vraiment une bonne température. Nous autres, on n'a pas évalué que la température vraiment affectait le mélange. Je pense qu'on n'a pas vraiment pensé que la température pourrait affecter le béton comme tel.
Pas besoin d'utiliser la glace de l'eau froide.
Non, pas. On fait sûr qu'après qu'on applique le béton, comme des personnes en charge, de garder le béton quand même assez humide, pour que ça comme cure. On a.
Il n'était pas chaud au toucher, là, parce que ça commence à réagir aussi.
Non, il n'était pas.
Okay.
votre renforcement primaire, juste le maillage que vous avez utilisé. Je vois que vous avez utilisé un chevauchement de 25 mm. Ça me semble comme pas beaucoup. Comment est-ce que vous avez décidé ce montant-là?
Qu'est-ce que tu dis, un chevauchement de 25 mm?
Yeah.
Ah, pour, ok, oui.
Entre les épaisseurs,
les deux
c'est ça.
pour le joueur. Les années d'avant, on n'avait même pas mis de joueurs en fait, puis ça avait still quand même très bien fonctionné. On n'a pas eu de problème avec le maillage cette année. Comme tu dis, si on pourrait rajouter 2 pouces comme ça serait still capable d'assurer qu'on avoir du maillage tout le temps. Puis vu qu'on utilise aussi la technique de frottage qui fait qu'on évite vraiment le maillage dedans en béton, on pense pas que la mèche avait une chance.
Non, il n'y a pas de risque de séparation avec les deux épaisseurs à la même place.
Sur l'optimisation de votre galvanométrie, vous avez utilisé la norme européenne, quelque chose. C'est quoi la particularité?
Je n'ai pas entendu la fin.
Vous avez parlé d'une norme européenne dans votre rapport. C'est quoi la particularité de cette norme-là pour
C'était celle-là qu'on avait trouvée, on a un peu plus. Je sais pas, c'est elle qu'on est venu dessus, c'est elle qui nous a aidé à trouver notre granulométrie. On pensait que ça était quand même assez bonne.
Le modèle de production repose principalement la production de plusieurs canaux.
Ça
repose surtout sur des tâches qui sont manuelles et répétitives par plusieurs personnes.
Donc,
est-ce que vous voyez un problème de maintenir ce niveau de qualité-là pour produire 100 canaux identiques?
Je dirais que la manière dont on fait notre poulet, on a 2 personnes en charge de contrôle de qualité dans la salle de relaxage et 2 personnes de contrôle de qualité dans la salle de bétonnage, en plus de 2 autres personnes qui sont là pour faire sur le contrôle des passeurs avec nos 3 modifiés. Alors, je dirais à cause des personnes qu'on a en charge de faire sûr qu'ils sont bien dans la tête que le contrôle de qualité, je dirais qu'eux sont vraiment là pour faire sûr que notre canot reste uniforme à travers nos 100 canaux et qu'on a le même produit final tout au long de nos 100 canaux.
Pour la coulée, vous avez mentionné que vous allez garder juste les meilleurs. Parce que le moins bon, vous allez les remercier.
Dans le fond, là-bas, on a choisi ça. On a fait une pratique on a section typique qu'on a fait avant. Alors, on a mis plusieurs personnes en bétonnage. On a vu les personnes qui étaient les plus habiles à faire l'application du béton. On les a gardés comme bétonneurs lors de la coulée. Et les autres personnes ont pu les mettre à faire plusieurs autres tâches durant la coulée. Comme des tâches importantes. C'est pas pour venir à quelqu'un ou le café. Non.
Vous mentionnez, je trouve ça quand même intéressant, que la granulométrie généralement utilisée dans le béton projeté répondait tout ça. Donc, vous avez utilisé la granulométrie de béton projeté, c'est ce que vous avez obtenu ça, puis c'est quoi vraiment qui répondait à vos critères?
Ben, si on voulait quand même réduire le pourcentage d'air dans le mélange cette année, puis avec le béton projeté, ben, il y avait comme la façon dont ça remplit les vides, on était capable de convertir ça dans nous autres, on cherchait. On a été capable de passer de 12% d'air à 5% d'air dans le mélange cette année. Ça remplissait les vides qu'on voulait remplir.
Puis comment tu as obtenu ça? C'est un fournisseur ou c'est des théories générales?
On a fait la recherche en revenant de la compétition l'année passée. Parce qu'on avait parlé avec quelqu'un qui est venu voir la compétition, puis il nous a parlé du béton projeté. Puis ils nous ont dit à propos de béton projeté, puis on a fait de la recherche au courant de l'été, puis on a commencé vraiment avec la granulométrie.
Et mais la mise en place d'un béton projeté et le béton n'est pas pareil. Quelque chose de
Non, c'est juste vraiment pour la remplir comme les vides. C'est juste pour ça, parce que, comme on dit, on avait parlé avec la personne dans la compétition, il nous a dit que ça pourrait être bénéfice pour nous autres, parce que avec le béton projeté, utilise un tuyau pour jeter le béton. Ben, nous autres, on va juste vraiment l'appliquer sur la façon que nous autres, on voulait l'utiliser. Ça marchait vraiment bien pour nous autres.
Comment vous êtes venu avec le nom de l'avalanche?
Ouais. Pour dire le vrai, on a commencé, le thème était un autre thème, mais on s'est fait dire qu'il y avait quelques autres universités qui avaient un thème similaire à nous. Alors, on a décidé de faire complètement 180, avec un thème de ski. Puis après ski, on aime ça, c'est le fun, c'est party, si tu connaissais Monkey, comment ça fonctionne. Mais on a décidé l'avalanche, je pense, on a fait un vote, on a décidé à des gens nous laisser savoir qu'est-ce qu'ils pensaient dans l'équipe. Puis après ça, on a choisi les 5 meilleurs choix, puis on a fait un vote, puis c'est le nom qui est survenu.
Est-ce que ça aurait été
C'est bon pour l'Université Laval. C'est ça que
Laval? Voilà.
Si vous avez une curiosité sur ta proposition, peut-être une copie de ce projet.
Ouais, dans le. C'est pas sur la clé USB en fait, on a une copie de papier. Non.
Ok, ça va être là-dessus. Tu viens de montrer. Ouais, c'est ton personnage sur la page couverture, c'est quoi que tu tiens d'enseigner?
Mais comme.
Merci beaucoup pour ta
Thank you, everyone. To have a couple words about tomorrow race day. So, Alex, if you can explain tomorrow day, we have a couple information for you that you should know before. Like, you don't want to learn that tomorrow morning at 6:30.